latest technology, hottest job of the 21st century, most in-demand job. Well, cloud computing has received these accolades many times now. But do you know why? As per recent findings by SkyQuest, around 78% of IT professionals are dependent on some kind of public cloud computing for their daily work. 43% of enterprises now use the public cloud, and more than 80% of organizations are planning to expand their public cloud infrastructure. These are not mere numbers that show the importance of cloud, but it shows how organizations have migrated themselves on cloud platforms and how heavily they are investing on cloud. Needless to say that has made the demand for skilled cloud professionals skyrocket. What? You don't believe me? Well, here is another statistics for you that will blow your mind. The global cloud computing market size and share revenue was valued at an astounding $429.5 billion in 2021. And hold your breaths, it is estimated to grow to about a whooping $1,025.7 billion by 2028. Take a second to let that sink in. So, if you want a job in a domain that is here to stay, then stay with us till the end of this session on AWS, the largest cloud service provider in the world today. In this session, you will get to learn all the important skills and concepts you need to know to begin your career in the AWS cloud domain. From in-depth concepts to quizzes to hands-on implementation of some very important AWS services, we are going to cover everything in the minutest of the details. Just to give you a brief, here is a list of some of the topics that we are going to cover in this video. But before we jump onto the agenda of the video, please make sure you drop a comment about the video, like it, share it, and as obvious as it may sound, subscribe to our channel and stay tuned. Now, let's move on to the agenda of the video. We'll start the session with an introduction to cloud computing in AWS, where we will lay a foundation for you about how cloud functions, and then we will jump onto categories of AWS services like compute, storage, networking, analytics, database, and so much more. Since the demand for AWS professionals have increased many-fold for certified professionals, we will also discuss career in the AWS sector and various certification paths. We will have various rounds of fun, interactive quizzes in between with a complete hands-on on all the popular services that are there in AWS. We will be wrapping up the session with some of the most important and frequently asked interview questions. Let's start the session with an interactive scribble video on AWS to ease you into it. So sit back, learn a lot, and watch the video till the end.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
So first, what is cloud computing? So in the simplest terms, cloud computing is a technology where a resource is provided as a service through the internet to a user. For example, there is a data center somewhere in America and they have an application hosted on that server which can be used by you in India, sitting in India or any other country. You can access that application right from there, and that application, that service is provided to you via internet. That is, you have a website, Amazon Web Services website, that is aws.amazon.com. When you open that, you get a list of locations and you get all the services available. So basically, after you log in, you can choose the service, you can choose the location and access that particular service. So basically what happens is, cloud computing is a way, and it is a technology which provides you a service via the internet. Not via there, you're not going to exactly see where that application is hosted or on which system your application which you are hosting through a cloud computing server is hosted, but it is hosted somewhere. You will be given all the required information like the public IP address and the security group port numbers and all. So you can use that to launch your application on your server which you created using AWS. So the basic explanation for cloud computing is, it is a technology which allows you to use a service via internet. Basically, they are renting you a computer. So Amazon Web Services buys a lot of computers and keeps it in a place, gives it internet connection and uploads and installs some software in it, and they rent those computers to you via the internet. So that's what you're going to use. So that is cloud computing. Now let us look at the benefits of cloud computing, why people are switching to cloud computing, why organizations are switching to cloud computing. The first one is data privacy and security. Cloud security is one of the highest priorities in Amazon Web Services because you are paying them to store your data and also host your applications. So their first priority is to keep that data and your applications which are hosted safe. To do that, they take utmost precautions and keep their architecture so well built that there are no vulnerabilities or loopholes. And then no maintenance worries. If you are using Amazon Web Service, so they take care of all the maintenance, because when you pay, they take care of all the maintenance because it is their hardware. You're only hosting your software in it, but the entire hardware is taken care by them. And also if there are minor upgrades or uploads, for example, there is a PHP 7.0 installed and if there is a new version of 7.5, so they update it or upgrade it for you automatically. And then faster data recovery. So you might have to store a lot of data online or in some cloud storage for backing up or archiving purposes. So for that, you can use Amazon Web Services or any other cloud service because they provide you faster data recovery. You can store it in the nearest server possible and recover that data as fast as you can. And then scale dynamically. So if you own an on-premise setup, basically your infrastructure has its limits. It cannot go beyond some limit. It cannot also be idle for some limits, because being idle will also cost you money. Going above the scale limits will not cost you money, but you'll not be able to give your entire services to your entire customer base. So if you use cloud services, they automatically scale your services for you. For example, if you have 10 servers which can accommodate 10,000 users, what if there are 10,000 more users trying to access your website because of some viral trend in your website or something? So what happens? Amazon Web Services can automatically create 10 new servers for your application and host it. So now the rest of the 10,000 people who are trying to access your website will not face a crash, or your website will not face a crash. They'll be redirected to the new servers which got created. And then reduce costs. So if you use Amazon Web Services, you only pay for what you use for the hours you use. For example, you use a server for 2 hours every day. So you only have to pay for 2 hours, not the rest of 22 hours. It is not, even if you have stopped the instance, you don't need to pay them. You don't need to pay for that server if it is stopped. Only for the running hours, the bill is taken care. So let us see what is AWS. AWS, or Amazon Web Services, the full form of it, is a cloud provider which provides its users a wide range of services via the internet. So AWS is a cloud provider. They provide services through a website called aws.amazon.com. So they have their own website, which is a front end for us to use the AWS services. So the most known AWS service is EC2, which is basically launching yourself a server. You can launch yourself a server and you can host your applications on the AWS cloud all by yourself, and it is very simple to start with. Now, let me give you a story of an entrepreneur. So basically, let us consider you are the entrepreneur here. So first, you have an amazing idea for a startup. So you spend your entire time, you spend 2-3 months to develop your code and you create an application now. And after creating the application, you think, so how will I get a server? Servers are very expensive. How will I buy them and how will I run them? And also I'll have to monitor, manage and apply patches, upgrade them. I have to do all these tasks. How will I do it all by myself? That will be a lot of tasks, and also that will cost me more. It will be very expensive for me. So then a friend of him, or he saw a YouTube video or whatever, he got to know about AWS, he got to know about a cloud service. So now what he thought, he learned a little about AWS and he learned how to host, how to serve his application on an AWS server. So what he did, he successfully did that and he saved a lot of money. So how did he save money here? In AWS, if you host or if you serve your website, you only pay for the server and the time you use. On that server. You don't pay for managing, for monitoring, for deploying it or applying patches, upgrading it, for nothing. You'll have to pay for just the time you use that server, nothing else. The monitoring cost, everything is taken care by AWS. So for example, you buy a server. You don't buy a server, you rent a server. So you rent a on-demand server. So you can rent an on-demand server for $0.02 per hour. So consider for a single person, he'll not have that much of capital. So he cannot invest $2,000, $3,000 at a go. So what he'll do, he can invest on AWS per hour. If it is $0.02, then for 100 hours, it will be $2. So I think a person who is able to develop an application can afford $2 for 100 hours of his application. So now Suddenly, after some time, your application is getting hits. So many people are starting to liking your application. So they are trying to buy stuff or whatever your application is concerned of. So if it is a food order application, many people are ordering from your application. So when you get a lot of hits, now what you can do, you don't need to do anything else. You just have to upgrade your plan with AWS. You just have to scale up with AWS. But for this, you can set up an auto scaling policy. What is an auto scaling policy? Let me explain that now. So you have your application hosted on a AWS server. So now, before you were getting 100 users were using your application. So one server was more than enough to keep them at bay. So in that one server, 100 users were able to seamlessly use it, get information back, order food, whatever. But now, as your application is getting popular and popular, you need a large amount of servers. You will need, for example, let us say now there are 300 users. So if one server can accommodate 100 users, then for 300 users, you will need 3 different servers. So now AWS will provide you 2 more servers once your first server is getting a lot of hits. You can set up as such, when the workload on your first server is getting high, then AWS will automatically provide you another server. And when the workload is getting high in both of those, it will give you another server. So here you will not be paying for creating these servers. You will be only paying for the time you have used these servers. So now what if your application is not getting that many hits? Well, let us consider your application is not that much of a hit right now. It goes by 100 users down. So before it was 100, then it became 300 users. Now it is just 200 users. So now, if your application's customer base reduces, AWS, you can set up a policy which basically checks the workload decrease. So if your workload decreases, you should provide a threshold, and if your workload goes below that threshold value, AWS will automatically take off one server. So right now you're not doing anything. Your application is working normally. AWS is providing you servers. It is deleting servers. Whenever there is an increase in your traffic, it provides you more servers. Whenever there is a decrease in your traffic, it reduces few servers. So right now your cost is also managed because you only pay for the hours these servers are used. You don't pay for the hours when these servers are stopped or when these servers are deleted. So this will make sure your cost, your capital on cloud is very less. So this is why people prefer AWS. So for a single person, for one application, if it can save this much amount of money, consider for an entire organization. So Netflix is one of the organization which is all in on AWS. So Netflix entire architecture is hosted on AWS. They don't do anything. They don't have an on-premise setup. They don't have their own servers. All of their servers are rented from AWS. They pay AWS. They take care of everything else. They just host their softwares and host their movies and series on that. So moving on. So before cloud, before AWS, you had to do all of these. You had to maintain the servers, and obviously the expenditure will be very high because you'll be doing all of these by yourself. And then you also have to take care of security. You should build your code accordingly that it is secure. You should keep your infrastructure accordingly that it is secure, and also scalability and flexibility. So scalability, as I told you, AWS provides you more servers when traffic increases. They'll reduce the amount of servers when traffic decreases. So now scalability and flexibility before AWS, you will have to take care of. So you should increase the server whenever there is a traffic increase. You should decrease the server whenever there is a traffic decrease. But you would have already bought 3 servers. Even if you decrease 2 servers according to the traffic, those 2 servers which you have bought will be idle. So that is a waste of money. So that's where AWS came in, and they provided these benefits. 1, data privacy and security, because your entire architecture is hosted by AWS, and obviously their data centers are very secure and they do not allow any malpractices, and also their network architecture is built so that no attacks are made on them, and no maintenance worries because AWS takes care of our entire maintenance of our servers and other services. And then faster data recovery. So if you own few servers, if those servers are destroyed or if there is a natural calamity happening, if those servers are gone, your data is lost. But in cloud, you can store your data in multiple regions. So when one region goes down, you can get your data back from another region. Scale dynamically. This I explained with an example. Whenever there is a traffic increase, you can scale up. Whenever there is a traffic decrease, you can scale down. And all of these benefits together, it will reduce all your costs. So if it scales dynamically, then yes, costs will be reduced. If faster data recovery, yes, your costs will be reduced because you don't need to have multiple storage locations all by yourself, and no maintenance worries. Again, this will reduce costs. You don't need to hire a professional who will be maintaining all these servers, and data privacy and security, they'll take care of it. Now, let us look at some facts of AWS. So first, the largest companies in the world, Netflix, Reddit, Expedia, and NASA are few examples of whom use AWS. So NASA is a very huge organization. They are the #1 space exploration organization in the world. And Netflix is one of the best media streaming platforms, and Reddit is one of the best social media sites, and Expedia, it is also a huge company. So all of these companies use AWS for their hosting needs and for their cloud needs. So if a company like Netflix and NASA can use AWS, why can't your startup? Then AWS provides 165 different cloud services right now. So the number of services AWS provides are increasing day by day. They are working on a lot of services. Right now they provide AWS for machine learning. They provide AWS for artificial intelligence. They provide a lot of services right now, and they keep on increasing every day. And then on average every minute, consumers view 7 million videos online, ask Siri 100,000 questions, and also buy $222,000 worth of items from Amazon. So these all happen in just 1 minute. And you know what? All of these are hosted on AWS. And also there is one more fact that 1/3 of any website you go online is hosted by AWS. There is a very good chance that 33% of all websites you visit are hosted on AWS. And also AWS had a 47% staggering public cloud market, because the top 3 clouds are AWS, Azure, and GCP. And comparing these 3, AWS had 47% of the cloud market. Not comparing all the cloud domains, not comparing IBM or Oracle, just comparing the top 3, AWS has 47% of that market. And finally, now AWS has its data centers in 69 different availability zones across the world in 22 geographic regions. Geographic region in the sense countries. For example, in the US it has like 4 different regions, and in 4 different regions it has multiple availability zones. So like that it has in many regions and also 69 availability zones. And also they are building in 3 more availability regions. So you can see Indonesia, Italy, and South Africa are some of the recent countries which they are working on to bring more availability zones. So why? Because that will increase the data availability. Now moving on. So these are some other cloud providers: Azure, Google Cloud, Alibaba Cloud, IBM Cloud, and VMware. So Azure is the second after AWS. AWS is the #1 in the cloud industry. Second comes Azure, third comes Google, and the others keep on changing. Their market share changes. So Azure is the same as AWS, but it is a service provided by Microsoft. Google Cloud again is a similar service to Azure and AWS, but it is provided by Google. And same goes with other services also. With Alibaba Cloud, it is an Alibaba's cloud service, and IBM is IBM's, and VMware is a separate cloud service. They provide you virtualized environments, they provide you servers, and they provide the same services as Azure and AWS, but they are not popular as that. They are still used by many organizations, but still AWS is the #1. Now, why use AWS? So this is one of the main topics we have to discuss now, because if we understand why we should use AWS, then we can go and learn AWS. So So first I'll tell this. So first, Amazon leads the race to the cloud. The number one cloud in, just a second. So the number one cloud provider in the world is Amazon. Second comes Microsoft, then comes Google, IBM, Alibaba, Salesforce and Oracle. So if you see in the Q2 of 2019, this means that the second quarter, the second 3 months of 2019, Amazon had a 33% public cloud market share. So if it had a 33% market share, then you can assume that if there are 100 jobs in the cloud domain, 33 of those jobs will be from Amazon. So if you study Amazon, you have a higher percentage of getting a job than studying Alibaba or Salesforce or Google. So as said, AWS has a higher market share, and because of that, it has higher job opportunities. Now going back to this slide. So these are a few more examples of why you should use AWS. First thing, it has a simple and per hour billing. That means you don't get billed for the entire month. If you're launching a server, using it for 1 hour and stopping it forever, you'll only get billed for that 1 hour. You will not get billed for that entire month because you have a server, but it is not running. You'll only get bills for the running hours of that particular servers. And then Amazon's brand name. As you know, Jeff Bezos is the richest man in the world, and Amazon.com gave him that status. So Amazon is a very widely popular name. It is one of the biggest names in the internet industry, and yes, that also adds value to AWS because Amazon Web Services, it has the name Amazon in it. And finally, easy profile setup. To start off with AWS, you don't need to know programming languages, you don't need to understand cloud, you don't need to understand any technicalities. You just have to know how to fill in a form and also how to fill in your credit or debit card details. If you fill in them and hit enter, you are good to go. Then after that, you should start learning about AWS. So any person could start off with AWS. That is why it is widely popular. Okay, so now we saw why AWS, why not any other cloud service. Now let us look at the steps to learn AWS. Yeah, so first thing you'll have to do is you will have to learn the cloud and networking fundamentals, because you will be learning how to create an architecture or an infrastructure completely on the cloud service. So for that, you should completely understand the cloud models and the cloud fundamentals as well as networking fundamentals. Now coming to AWS, after you learn cloud services and cloud fundamentals, then you will have to move on to AWS. You will have to start off with what is AWS and learn how to sign up with it. So to get started with AWS, it's very simple. It is just like signing up a form for Facebook or Twitter. For any social media site, you'll have to provide your email ID, you'll have to provide your username, and then you'll have to provide your debit or credit card details. So basically, they take 2 rupees or your own currency amount related to the equivalent of 2 rupees. So they take it just for verification whether your debit and credit card details are correct. If it is correct, you will get your profile for AWS and you can start using AWS. So sometimes it takes some time to set up. For example, 2-3 hours might take after you sign up. Then you'll be able to use all the AWS services provided. So debit and credit card details are a must. Without a debit or credit card detail, you cannot log in or you cannot create a AWS profile. And finally, you can go through the exam guides of various certifications and you can go through the white papers which AWS provides. So if you go through the white papers of AWS, it is completely created by someone working on the AWS services and they provide you white papers. So basically the documentations have they have the exact same things which were used to create the AWS services. So for example, if you take one service, let's say S3 or EC2. So if you take any of these services and you want to check the exact working of them, AWS provides a documentation for that. You can go through the AWS documentation for each and every concept of any particular service you take up. And also they provide white papers. So white papers are separate from documentations. White papers provide more valuable information. So For example, the best practices you can do on AWS. For example, you might have an architecture already hosted on your on-premise setup. Now you want to migrate it to AWS. So now AWS provides this white paper where they provide the best practices for migrating. So you'll have to understand how to migrate it and then use those best practices, and accordingly you will have to migrate your on-premise architecture onto the AWS cloud. So once that is done, you will be good to go. So first, these are the three things. These are the three steps to learn. Understand the cloud fundamentals, start learning of what is AWS, and then slowly move on to the services which you like to learn first. I would suggest to go with EC2, S3 and RDS in the beginning. So these are the most commonly used services and these are very easy to learn. So first understand these three services. Once you understand these three services, you can move on to the other services. So EC2 is called Elastic Compute Cloud. Elastic Compute Cloud in the sense they provide you virtual machines running on the cloud. So you can use those virtual machines according to the operating system you choose and it will be running on the cloud. You can use any device with internet connectivity to access it. S3 is called Simple Storage Service. It is used for storing. Basically, it is like a storage service like OneDrive or Dropbox, but S3 is better than them. You can store virtually unlimited data in it. And then finally, RDS is called the Relational Database Service. So they provide a service on which you can create a database which is running on the cloud and you can use that endpoint. Now we saw the steps to learn AWS. Now let us see the different ways of learning it. So the first thing I would suggest is the documentation and other AWS blogs which we provide. So even we have created a complete blog on AWS. You can go through that. It is very informative and you can go through the official documentation. You can go through white papers. You can go through all of these and gather the valuable information you need and also practice the tutorials which are provided in those documentations. Second, go through YouTube tutorials. We Intellipaat have provided complete AWS courses on YouTube for free. You can take up those videos and practice AWS completely. We also provide we also have added different hands-ons for Lambda, for EC2, for load balancers. There are a lot of hands-ons. You can practice all those hands-ons. And finally, the last step would be to take up an online training because you might not know where to begin, from which topic to begin. So if you want to take up a online course from scratch which goes till advanced concepts, you can take up one. Even we provide one. So these are the different ways to learn AWS. One would be going through blogs, the second would be going through YouTube tutorials, and third would be taking up an online training. So I would suggest first get a basic idea of what is AWS and learn some things about AWS before taking up an online training. But if you take up an online training, it would be much easier to go ahead of learning other AWS services. Okay, so now we looked at why AWS, why not any other cloud service? Because it is the #1 cloud service in the world, #1 cloud provider in the world, and many Fortune 500 companies have their architecture on AWS, so you can have a chance of getting a job in those companies, in your dream companies. And it has AWS Solutions Architect has a lot of jobs available and the pay is also very high. So now there is not just Solutions Architect. There are various AWS certifications. Now let us look at them. So available AWS certifications. So basically the foundational course would be called Cloud Practitioner. So Cloud Practitioner is not for any specialized certification test. So basically Cloud Practitioner is the most basic exam in AWS. So if you understand the basic cloud concepts, the basic AWS concepts, and have enough IT knowledge, then you can take up Cloud Practitioner and easily clear it. So it is not required that you should take the Cloud Practitioner exam and only then can move on with architect or operations or developer. It's not like that. So basically this is a foundational course, but the associate courses also do not have any prerequisites. So basically you can see 1 year of experience solving problems and implementing solutions using the AWS cloud. So why 1 year in the sense? 1 year might, for example, if you're working in an organization, then 1 year would be sufficient to learn all the services with the enough amount of industry experience. So if you are not working on an AWS role, if you're working on a different role, and sometimes you do not have, or from a technical background, still you can take up one of these AWS certification exams. So basically you'll have to understand what exactly is each AWS certification exam and learn what is inside that, what you'll have to learn to clear that exam. And if you're confident enough, so basically anyone from a technical or a non-technical background can directly go to solutions architect. So it is the most popular course or the popular certification in AWS, because solutions architect, as a solutions architect, you do not need much of coding. You just have to understand how to create resilient, highly performant, highly available architectures on the AWS infrastructure. And coming to SysOps administrator. SysOps administrator in the sense systems and operations administrator. And developer is basically a person who develops applications on the AWS cloud, or a person who develops applications which are going to be hosted on the AWS cloud. So coming back to SysOps administrator. So a SysOps admin is a person who will administer the servers running on the AWS cloud. So these are 3 different profiles, and these are 3 different certification exams. So you can take up the AWS Solutions Architect certification first and go up by taking up the Solutions Architect Professional once you have enough experience as a Solutions Architect. Or after taking Solutions Architect, there is no restriction between taking these courses also. You can also take a SysOps admin course, you can also take a developer course, you can go horizontally or you can go vertically. So if you take up solutions architect, a better take would be to take up the professional course after taking up the associate course. So associate in the sense, so we'll discuss what is the amount of each certification exams, how much you'll have to pay for that, how much you'll have to pay for the certification exam to take it up, and we'll also discuss other things. So right now, let us discuss the professional courses. So the first one is Solutions Architect Professional. So for a professional, you need much higher experience in designing and operating and troubleshooting solutions. For example, as an associate, you might know how to create a highly performant architecture which is running on the AWS cloud, but you would be expected to be able to provide a solution for a particular problem on the AWS cloud. Let us say you have created an architecture. So now there is a problem somewhere in that architecture. So you should be able to monitor and figure out where exactly that problem is, and you should be able to troubleshoot that solution as soon as possible. So you should have that much experience, and after that, I suggest you can take up the professional certification. If you take up the professional certification, I'm pretty sure you can go up the ladder and become a senior AWS solutions architect or a team lead for your solutions architects. And coming to the SysOps admin and developer, so you can become a DevOps engineer. So DevOps, development and operations engineer. So basically you can either be an operations guy or you can be a developer guy to take up this particular certification exam. So again, DevOps engineer is a professional certification. For DevOps engineer, you should know a lot of DevOps tools. You should know tools like for configuration management, you should know Chef, Puppet. You have Opsworks on AWS, so you should understand that completely, and you should know Docker, Kubernetes, Nginx, Terraform. You should know a lot of DevOps tools. And why DevOps engineer on AWS? Because you should understand and you should be able to use those DevOps tools to create a DevOps lifecycle on the AWS cloud. So you should be launching servers using the AWS services to create a DevOps lifecycle completely and manage it. So these are highly professional courses. So if you're done with your professional examinations of solutions architect or DevOps engineer, you can go to one of these specialty domains if you're good enough, or if you want to become a specialized person in AWS, either in advanced networking or in big data or in security or in machine learning or Alexa skill builder. So you can either directly go to a specialty course, specialty certification from the associate, or you can go up the ladder first and then move on to specialty. So all these certifications are available in AWS, and I would suggest you to take either architect, operations, or developer. So if you're a fresher, I would suggest to take these three, and Intellipaat provides courses on all these three. You can look it up. Now let us look at the format of all three exams. So the format of all three associate, professional, and specialty exams are multiple choice, multiple answers. So you get questions and you can answer them by choosing them, and also some questions might have multiple answers. So for an associate exam, you'll have to provide the exam in a testing center, and these are the same for all the other types, the professional type and the specialty type. But for associate exam, you get 130 minutes to complete the exam. For a professional exam, you get 170 minutes to complete the exam, and again for specialty you get the same. And the cost of the examination would be $150, and the practice exam, if you want, you can take it up before giving the actual exam. It costs you $20. And the examination is available on 4 languages: English, Japanese, Korean, and simplified Chinese. So all of these 3 different types of certifications are available in all 4 languages, but the cost differs and the timing differs. So the cost for the professional and the specialty exams are $300, and for the practice examination you'll have to pay $40 to take it up. So these are the exam details for the certification paths. So if you take up any one of the certification, you should know exactly what you're going to write for. So for example, if you take solutions architect, you should understand all the concepts which are provided in that particular exam guide. Only then you can take up that certification exam. So once you are done and you have a certification and you are confident enough that you can take up an AWS job, I would suggest add it in your resume. Do projects by yourself, do AWS projects by yourself, add them in your resume. So once you add them in your resume, obviously they're going to improve your resume's value. Now, AWS job roles. So let me explain the most common AWS job roles: the solutions architect, the cloud developer, SysOps administrator, senior AWS cloud architect, cloud DevOps engineer, and operational support engineer. So as we know, solutions architect is a person who creates architectures, highly resilient, highly available architectures on the AWS cloud. And for this, it is good enough to take up the AWS Solutions Architect certification exam, because the certification provides you a better stand in front of other people who are applying for the job. And a cloud developer. So for this, you can take up the developer certification. So as a developer, you should know much about the AWS SDKs, AWS CLIs, and APIs. You should know how to code using the AWS SDKs, and how to launch AWS services so that your applications can be hosted successfully on them, and also your applications are highly available and scalable. SysOps administrator. So you will be an admin for the AWS cloud for your company. So it is basically administering your entire company or your entire company's architecture which is running on AWS. So a SysOps admin's main job would be monitoring and reporting. You will have to monitor all the servers, all the services continuously, also have to generate reports continuously. According to that, you will have to provision or troubleshoot the running AWS services. And then senior AWS cloud architect. So it is the same as solutions architect, but as a senior, you will be leading other solutions architect. So basically you will have to understand how an architecture can be split up and given to multiple people so that each person can work on one particular task. So after doing that, you can put it up together. So you'll have to exactly understand what can be split up in the architecture. And cloud DevOps engineer, yes, you can either be a normal DevOps engineer who uses tools to create DevOps life cycles instead, or you can become a cloud DevOps engineer who basically again creates DevOps life cycles using DevOps tools. But for a AWS cloud DevOps engineer, he basically creates a DevOps lifecycle, or she basically creates a DevOps lifecycle on the AWS cloud using the AWS tools or other DevOps tools. And finally, operational support engineer. So an operational support engineer should be able to troubleshoot any kind of an issue which is coming right now on your AWS cloud architecture or your infrastructure or your console. So he should understand, an operational support engineer should be able to understand what exactly goes on the AWS architecture, what problems will occur. He should anticipate it before according to the metrics he gets, and then he should provide support. Basically, another part of a support engineer would be to guide the customers who are currently using the AWS architecture. So these are the various job roles, and according to the certification you take up, according to the learning process you take up, you can apply for one of these jobs. So basically, if you know enough of AWS, take up the examination, clear it if you have the certification, and if you have done some projects on AWS by yourself or working in your company, that add it in your resume, that will add a lot of value. Now with your resume, after you're applying for a job, now it's pretty easy. Just prepare for the interview and clear it, you're good to go. Now let us look at some AWS services. So let us try to understand few AWS services. This is to give you an idea of what AWS provides, what they offer. So first, AWS offers domains. AWS offers services on all of these domains. One is compute, then database, storage, migration and transfer, customer engagement, security, identity and compliance, then management and governance, and also networking and content delivery. So these are some domains. There are a lot of domains still, but these are some domains. These are one of the most used domains. So compute, database and storage are very used domains in AWS. So these are some domains which AWS provides us. Now let us look into few services from compute, from database, from storage, from security and management, and also content delivery. So let us look into some services and let us discuss them and let us see how they work. So first, I obviously have to say EC2, because EC2 is the most popular service. If you're starting with AWS, I would suggest you to start off with EC2, because EC2 is the basic and integral part of the AWS ecosystem. Any service uses EC2, because if you launch Elastic Beanstalk, so Elastic Beanstalk is basically a platform as a service. They provide you a service where you can put your code and it will automatically provide you a DNS name where your website is hosted. So now you will just see the website where there is a DNS name and your code is uploaded, but you will not see where your code is hosted. So that code will be hosted in EC2 server. It will be hosted in an EC2 server in the backend, in the data server. So right now, they also provide a service called EC2, that is called Elastic Compute Cloud. So Elastic Compute Cloud is a virtual machine service. So what they do, they provide you a server in any data center which you choose from. For example, if you choose Mumbai, the server in Mumbai, so they provide you a EC2 server which is hosted in the Mumbai data center, and you can use that. Server to launch your applications. You can host your databases. You can host your websites and all that. You can also choose for example, you can choose a server or a region in USA also. You can also create a server sitting in another country in US also. For example, if you're in, let us say you're in Russia, and from Russia you're trying to host a website in US. So you can just choose a region from USA, and in that region you can launch a server, and in that server you can launch your website. So right now from Russia you have launched a server in USA. So that's what capability and flexibility that EC2 provides. So you can see EC2 enables on-demand scalable computing capacity in the AWS cloud. As I already told you, If you have one EC2 server, you can make it larger also. For example, if this server has 2 GB of RAM and let's say 10 GB of storage space. So now you need a bigger system. So you don't need to create another one bigger. You just can change, you can just modify this server to have more storage space and also a higher processing power of like 10 GB of RAM.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And coming to scaling part, if you enabled auto scaling, so that means whenever there is a need, you can create multiple copies of this server. That is, whenever there is a traffic increase, it will create one more server and again one more server according to the needs, and also it will reduce one server whenever there is a traffic decrease. So EC2, as I told you, if you are starting with AWS, start off with EC2 because it is the most integral part of AWS ecosystem and it provides you scalable computing capacities. So now let us go and look at the next service. The next service is RDS. It is a relational database service. So this service provides you access to relational databases which are hosted on AWS. So you can see there are 6 different database engine options. One is Amazon Aurora, one is MariaDB, one is PostgreSQL, one is Microsoft SQL Server, then MySQL and Oracle database. So these are the 6 different database engines which RDS provides us. You can choose one of these database engines to host your database needs. So RDS provides a console, a web service. You can go to the RDS console, you can choose one of these databases, and then you can use this database. You will get an endpoint for this database, you will get a port number for this database, and you can use this endpoint and port number like how you normally use a database. For any database hosted locally, you will have its own local name. That is, for example, if you use XAMPP or WAMP, you will have the name called localhost, and port number would be 3306 for MySQL, and the exact same thing happens in RDS also. But here they'll give an endpoint which will redirect you to the database which is available on the AWS server. So you should use that endpoint instead of the localhost name. You should delete the localhost name, put your endpoint there, and then in the port number, it is the same port number, it is 3306. Then you should provide the username and password which you use to create this particular database on AWS. So now you might be thinking, okay, you might know MariaDB, PostgreSQL, MySQL and all the others, but you might not know what is Amazon Aurora. Amazon Aurora is a database service provided by RDS. Amazon Aurora supports MySQL and PostgreSQL. So it has this completely different architecture. So Amazon Aurora is a database cluster, not a single database, but I'm not going to go into Amazon Aurora. Just I wanted to clarify what is Amazon Aurora. You can create a database in Amazon Aurora in either MySQL or a PostgreSQL engine, and it will give you multiple databases. It will give you one write database and one read database. So this is a database service. Now moving on, let us look at a storage service. And again, this is one of the most used service. EC2 and S3 were the first AWS services which got launched in the year 2006. So to start off AWS, we can say EC2 and S3 are the most integral parts of the AWS ecosystem. S3 is the storage. It is called Simple Storage Service, and it is an object storage service. It offers industry-leading scalability, data availability, security, and also performance. It is very simple, guys. You should create a bucket. A bucket is basically like a folder. So inside that folder, you can upload your content. For example, a PDF. You can upload your PDF to that folder. That folder is hosted on AWS. It is like a Google Drive. You host your folder there, and inside that folder, you create multiple files. You upload files. You can also download those files whenever you want. So it is basically a bucket service. So you have this bucket and you put all the content. For example, you have a bucket in your hand and you have some objects. You just throw them inside, and whenever you need that object, you leave your hand inside and take it. For example, if you want a ball from that bucket, you just leave your hand, select the ball and take it out. The same thing happens here. You will be able to see all the contents inside that AWS bucket, that AWS S3 bucket, and you can choose that particular object and download it. So it is a simple storage service. Basically, you can think of it as a service like Google Drive. You can upload your contents to Google Drive and download it whenever you want, and same goes with S3. And then a networking service called CloudFront. So you might have heard this concept called CDN, a content delivery network. You might or may not have heard. So I'll give you an example of a CDN using YouTube. So YouTube has so many videos. Every minute there are like 100 hours worth of content getting uploaded to YouTube. So where does YouTube store all of this content? It has to store it somewhere, right? So it stores it in a CDN. It stores it in a content delivery network. So how does a content delivery network work? So you are a user trying to access from Asia. So now what you do, you might think whenever you try to access a video, it goes to the server and brings back it again to you. But it does not work like that. So you have your origin server where all of the content is, or you can also have multiple edge locations where few of your content is. So in YouTube, you might have this content restricted to a particular country. So those restrictions could be made using a CDN. So this edge location is only for Asia. So whenever an Asian user is trying to access data, it takes from this edge location. And when an African user is trying, it takes from this. And when a European user is trying, it takes from this particular location. And all of these locations are connected to the origin server. If this particular location does not have the content, it does not say, I don't have the content. It goes back to the origin server, collects the data and stores it here and sends it back to the end user. So basically a content delivery network is used to deliver data, videos, applications to customers globally. You can set up edge locations in any location in the world, in any location where AWS is providing services. You can set up in any location and it provides high availability of data and videos in all of those locations. Moving on, now a security service. It is a simple service. This service is called Identity and Access Management. So this service provides you access management service. So basically you might have given credentials, you might have created multiple users in your AWS account. And for example, not all of those users do the same tasks. One of those users might be an admin, one of those users might be a web developer, and one might be a data scientist. So a web developer does not need all the services in AWS. He just needs the EC2 server where the HTML code, the JavaScript is hosted on. And a data scientist does not need to know about the EC2 server, how it is hosted, all the web code. He just needs the metric data. He just needs the data coming out from AWS, and admin requires all the access. So using IAM, you could particularly restrict these users to use only those particular services. So that is why you use IAM. You can create permissions and assign it to particular users so they cannot go beyond those permissions. And finally, CloudFormation. This is a service which provides you infrastructure as code. So you can code your entire infrastructure into one file, and when you run that one file, it will create an entire architecture for you. For example, in that code you would have mentioned, I need 10 servers, I need this much of storage space, I need a database service. So you can just code it into a YAML or a JSON file and upload it to AWS CloudFormation and hit enter and run that code. And that code can be uploaded locally, or it can be uploaded to an S3 bucket, and when you run that code, it will automatically create an entire AWS architecture for you. So to learn CloudFormation, you should first understand what is AWS. I wanted to explain these services to make you understand what kind of services that AWS provide.
Alright guys, so moving forward now, let's go ahead and do some hands-on. So what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give boot 1 2 3 4 5 6 7 8 9. And the country or region, you can select any region that you are in. your address, the city that you are in, postal code. So let's say the city is Bangalore, state, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right. So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have ground station, security hub, artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. Alright, now what we wanted to do was we wanted to launch our first server, and for that there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2, so I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that, and now this link would basically open your EC2 dashboard. Right? So from here you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're gonna have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. you have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay, so let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from, right? But the only server that is free for you would be T2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is this. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being in launch. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch a Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it will give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it will verify the key that I inserted and it will be able to connect to the Putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay. So you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this, right? T2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. Alright, so we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect, and this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator, and if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch, but this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here, right? And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I'll just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this, PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes, and now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk? Right? So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET, I can put my web app in Go, I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these were all the settings that you had to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy, and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. Alright, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, firehose, syslog to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end, that is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that, you know, your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3, you want to archive the data, put it in Glacier, all those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. Alright guys, so now let's start off with EFS. So I'll just click on the EFS service on my AWS Management Console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default guys, don't touch anything else. Let's create the file system now. Alright guys, so my file system is now being created. Now remember guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances, right? Now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here. And now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is the security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay. Now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services or AWS is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, If I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is, it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB, or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is, under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server, or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query, that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS management console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now, what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now, what is an application account? Let's say I have a website which can upload data to S3. Now, how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise, it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means key management service. So key management service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS Opsworks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer with in an auto scaling group which is connected to an RDS instance, which in turn is also, connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in in one particular region. I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS Opsworks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS Opsworks, and what you can do is in AWS Opsworks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how Opsworks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So Opsworks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in Opsworks. Now don't get confused with CloudFormation and Opsworks, guys. CloudFormation is used to deploy an architecture. Opsworks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through Opsworks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using Opsworks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the Opsworks architecture, and then in that case it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes which are very important and have to be same across all the servers, I use Opsworks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, you know, AWS CloudTrail should log each and every action which is happening, and it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it, and then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure it will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, you'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called Simple Notification Service and the other one is Simple Queuing Service. Let's see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the Simple Queuing Service. Now, what is a Simple Queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether whether it has already sent an email to that to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So for I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will pay, you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate, because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right, so the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details for. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect the service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free, and the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now as of now, this MySQL database is on the local host, and also the website is on the local host, and right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like. So let me jump on to my browser. Right, so guys, my website basically exists on localhost/new. Right, so this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. Alright, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once the entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now how can I give authentication to my website so that it can upload on S3? For that I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket, right? Which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is, the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, there's test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size. That's why it's not uploading. So what I can do is let me take this particular image, right? And let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from images, select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database. And the type of database that I want is MySQL. Let's select that. And now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it will ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take, guys, 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Alright, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit, right? So this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry, guys. I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded, right? So I'm uploading, I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website, right? So if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right. So once I've done that, it works great. It works like it is supposed to. Now, I guess we should go ahead and check if my RDS is ready. Yes, guys. So my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my localhost. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for the security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my local host. So the table name would be names and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select star from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance, right? Now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here, guys, is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if you go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that guys, and it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it.
As I already told you, in this session, we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our local host and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service, and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc1, and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had two images, and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc1, and this one was uploaded.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
From this local host. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session and then we'll move on to the hands-on part. So come on, let us go. Okay guys, now let us begin with the session. So typically an application comprises of three components: the front end, the back end and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end and the database service on an individual server. So what happens here is whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help and it will store somewhere and it will show the response in your website. Also, there needs to be information stored in the database because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website, which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is front-end service uses 80%, but the backend service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now the system falls under a deadlock and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture? It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all software components was hosted, so what happened there was backend server will consume most of the CPU resources and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website and the website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front-end server and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service, and whenever to retrieve this particular image, the database service provides the link and the backend service will use that link to show the image to us. So let us consider this and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front and the backend and the database services club together. So now we have learned what is a distributed application architecture and how the front end, the back end and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now, what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service while EC2 is an infrastructure as a service. In Lambda, it provides you a platform to run and execute your backend code, but in EC2, it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C#, and a few more. No restrictions in EC2. You can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2, you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda, you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors. So you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is The maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment, like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds. So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs. And after that, the Lambda executes the function or the code in your behalf. You don't need to run it. So, but to run the code, you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. You need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger. And whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description. Description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds because that is the capacity or that is a timeout period for a function which I have already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment you can run a Python file, a Java file and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime, and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes, and these were already announced. So first it's .NET Core 2.0, C#, so and then Go programming language, and then Java, Node.js, Python 3.7 and Ruby 2.5. And the other supported languages are Node.js, but an older version 8.10, and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes and other dependencies. So instead of downloading using the code which you write in your Lambda function, you can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers, and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file, so what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in-development function code independently from unchanged. You don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket which it is connected to. Also, whenever a put operation occurs, that is when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do an hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is we are going to upload three types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket. And whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is we are going to use the S3 buckets uploading, that is put as or post as a trigger, and whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So let me show you the code first. So this is the code. There are two files, one is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is normally if it does not exist, $key will be just $key. But if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we have seen this code. Now let me show you the Python code which is used for the Lambda function. So in the Lambda function, using that we are going to send this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly, and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket, I'm getting the name here. This is the file name, I'm getting it here, and copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from, and this is the object which is going to be uploaded, and this is our CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like you can go to that log streams and check out these things when the function has started. So when the function started, this will be there, and after that this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't yet, check whether extension. First you get the extension or the last four characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object, bucket, this is the destination bucket, this is the file name, and this is the copy source, that is the file which you're going to upload from the bucket. That is, from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code. Let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that and you have to attach a policy. And I've created a policy already which is s3_move. So you have to create a policy and use this particular JSON code inside it. So I'll explain what this means. So I'm giving effect allow. And also over here, so here I'm giving the actions logs, create log group, log stream and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First, you have to create a role which lets Lambda call other AWS services. So here, after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next, you have to give it permissions. You can see here there are a lot of permissions, that is, there are policies available. So before we created a policy s3_move, and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3 and I'm searching CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tag, so I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are 2 policies attached: Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role and now the role has been created, and as I showed you before, here you can see this, and also I can go into the policy and show you the JSON part. This allows all the actions for S3, and the other policy allows all CloudWatch actions. See, you can see in the JSON, so you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part. So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let's create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything. You don't need to give any tags. So you just click next and it already sets permissions. So block all public access, and also if you want you can review it once. And then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image, and I've created that. Okay, next thing is I'm creating to the bucket PDF, and I'm giving next and create bucket. And finally I'm creating to bucket text. So I'm giving next, and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless AppRest or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python, so I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created a role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is see, I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7. This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever an object is uploaded to the S3 bucket from the bucket, then this process will start happening. First let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our lambda will be triggered right now, and that function will be running, and this process would have happened. So I refreshed it, and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3, and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now, and it gets segregated according to the extension, and it gets copied. So I told you after execution of the function, you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics, and here you can see some data. So this is invocations 1. So the function has run one time, and the duration was The duration is given here. And also the success rate was 100%. There was no errors. So you can see that here. Also, let me show you the logs. So a log has been created. I'm opening that. So you can clear. So function start CloudWatch. So let me open the code first. Okay. So here function start CloudWatch. Function start CloudWatch. And you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name and request ID has been. So after the request ended, it is ending the report and the report has been sent. And you can see here it took 566.10 milliseconds and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda Demo. And I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is the default PHP page and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code because okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in filelogic.php you have to change the path because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/ your file. So index.php and filelogics.php will be in this directory and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is you have to click on all the files and choose over here and you have to archive it into a zip file. So if you ask why should we zip it rather than make the file a RAR file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button. So I have to choose a file. So what I have to do is I have to go back. We go to AWS demo. So this is the file which I have to upload. So AWS uploads file logic and index files are within this particular zip file. You should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda Demo. So it is AWS Lambda Demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda Demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket it's empty and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image, and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, doc.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket, and you can see the PDF file over here. And then to finally to the text bucket, and I'm refreshing it, and you can see the text1.txt file over here. So right now our Lambda function is working, and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application, and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded from the bucket, and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image, and then PDF, and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy, and first we created a role, and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function, and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3, which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens, and this function code runs. So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk, and we deployed it, and we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that, and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution, and this is one particular function execution. This is one. This is one. So the function has been executed this many times, and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100%, and there are no errors because all the files which we were uploading got uploaded, and the function never got any errors, and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that, and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM so that we have to create a policy first, and then we know how to create S3 bucket. We know how to write code in a Lambda editor, and then we know how to use CloudWatch, log streams, and also metrics. And also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL. You can access it from anywhere in the world.
So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites. The second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it. You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services. You can use services like EC2, S3 and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
We have seen the various Amazon services. We are going to learn about some more services on the management side, the deployment and managing of Amazon services. Till now, if you want to deploy applications, you might be using EC2, EBS. For monitoring, you would use the CloudWatch. For storage, S3, even EBS would be helpful for your persistent storage. For scaling, auto-scaling, Elastic Load Balancer and CloudWatch. VPC for security, IAM for security, RDS for database. Now, we will be talking about the deployment and management. How do you deploy your application better way? How do you manage them better way? That is what we are going to cover. The Amazon Elastic Beanstalk. We would see what is Elastic Beanstalk. We would see about the key features. Now we are covering a few services where it's very important for us that we understand why they are used. We might not be going deep down, but at the same time, their understanding why this would be useful and how would I use that service, it's very important for us. Elastic Beanstalk is a easy to use service for deploying and scaling web applications and services like Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker, whatever stack you want to work with, it is available. What it does is, if you are a developer, suppose you are a developer, you want to deploy your application on Amazon. What are the steps you would be creating? You would be creating an application. Now it's a Java, you might be creating a var file or jar file, something like that. For .NET, it might be separate format, something you would be making over there. Whatever the version of your code, you would be uploading that to an EC2 environment. So you would be launching an EC2 environment. You would be managing this environment. So the management includes so many tasks like security, AMI creation, server setup, let's say your Tomcat or PHP or whatever, your load balancer, your auto scaling, so version management whenever new version is coming, that you would be doing with the AMI also, backup management. Now log management, all these tasks you are doing in managing environment. What if there is a tool available which would be doing all these tasks on behalf of you? All these tasks it's doing on behalf of you. You only need to focus on creating an application and uploading here. Everything else is being taken care by this environment or this tool. What would you call that? Yes, I'm sure you would be saying it's an Elastic Beanstalk, you would call it. No, there is something different word also. It's a very easy to use, very simple, and the advantage is it gives you very quick deployment options. It supports various stakes, multiple stakes. It also supports the automated deployments. It's available free of the cost, no charge at all for all this management. Yes, any resource it you launches, like it launches an instance, it creates a load balancer, whatever it is doing, that would be it's charging for that. It's a scalable because it's doing all this scaling activity on behalf of you. Highly reliable. It does support your version management too. This is a PaaS offering. It's a platform as a service offering for you, which is managing all the platform for you, your deployment, scaling, backup. A platform is offered to you. If you remember in our cloud computing video, we talk about this. This is a PaaS which helps me manage my platform. Here, Elastic Beanstalk, where the developer would have a full control. Here you would have a root access to your EC2 instance also, and in that same instance you can create your own applications also. It does support auto scaling, Elastic Load Balancer, RDS, CloudWatch, so integrate with those application services. It also helps you make your custom AMI. If you want to make your custom AMI, you can do that. Let's not stop that only Elastic Beanstalk is doing this. Elastic Beanstalk says I am doing everything on behalf of you, but you are also free. If you want to do something more, you can do that. Important is, if you want to manage load balancer, you want to manage the auto scaling, you want to manage the CloudWatch part, you want to manage the EC2 configurations. Here with Elastic Beanstalk, everything available monitoring at single place, easy to manage for you.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but It also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
It gives you an automated deployment, automated version management. It has the manage environment settings. So all environment settings are managed by it. You can always modify that. Whenever you upload a version also, new version, it keeps the backup of the older version also. And whenever it is deploying this new version, it would automatically restart of server and AMI creation would be taken care by it. Whenever this version is doing, it also manages the log for that. So everything is easily managed by you with the Elastic Beanstalk. If you see under the hood, underlying how the Elastic Beanstalk would work for you is, it gives you an environment where you would have when you create an environment, it would be creating a various EC2 instances. That each EC2 instance would have internally, if it's a Java stack, it would be having Amazon Linux. On top of that, there would be an Apache and Tomcat install out of that. Only thing you need to submit is application. Application would be automatically deployed on Tomcat. A log file would be created for that over there. Automatically, it would be making an AMI also out of this. And this whole environment would be managing, it would be, if required, creating auto scaling, load balancer, everything it would be creating for you. If it needs to replicate more environment, it would be doing everything managed by Elastic Beanstalk. Let's see the demo of the Elastic Beanstalk and see how it helps us. So I am in my AWS console and I am going to the Elastic Beanstalk. Here currently I have no application available. As we say, it supports the multiple platforms: Java, Node.js, PHP, Python, Ruby, Tomcat, IIS, Go. These are the web servers you want to, or Dockers also, the containers also it supports. Pre-configured Docker with the Glassfish, Go, Python, it supports that. I can go and say create a new application on top. I give name something like this. For Elastic Beanstalk, I shouldn't write. Now, which web server do you want to use? Do you want to use the web or do you want to use the worker environment? The web means you are going to deploy an application with the web server like Tomcat or something like that. I can say create. I'll say I'll go with the Java. Do you want to go with the single instance environment or do you want to go with the load balancing environment? I say go with the load balancing environment. I am okay. Now, do you want to upload your own application or you say no, use the sample application only? Whatever the sample application available with this Beanstalk, you can do that. It also supports the how do you update your application also. Sometimes you want to update your application. What you can do is, if it's a with the load balance and all that, you can say 30% of the fleet only update that time, or only whenever you're applying a batches or patches, whenever you're applying new application, do it for one instance at a time, then do for the rest instance. Then this is my environment name would be, and my URL would be something like this. Let me check it's available or not. It is available. I just give some description and I say next. Do you want to create an RDS database also with that? If you want to, do you want to create this environment inside a VPC? I say yes, create inside a VPC. Okay, which key pair you want to use? I say use my original key pair, Intellipaat. Do you want to get notified anything about that? I say yes. Do you have any application health check URL you want to specify? I say no. Whatever the load balancers, these are the, now you see, these are all load balancer settings you are doing. You are making those checks here. Automatic updates, health checks, cross zone load balancing, connection drainage, everything you would be supporting here. What would be your root volume? Do you want to say magnetic general purpose provision? I say general purpose. Do you want to specify your size of the root volume? I say no, go ahead, whatever is default I would use that. What is the key name? So name is already we have reserved. So if I want to give additional tag saying that environment, it's a demo environment, I can say that. Which VPC do you want to use? I say this is the default VPC. I want to go assign a public IP address. Yes. Do you want to use the ELB supports all zones? EC2 also supports here. So auto scaling would be also supporting. So here we are supporting for the ELB and the auto scaling, which zone it would be used. VPC security group, I can say use my Intellipaat security group. Elastic load balancer visibility, it's a external only, it should not be a internal. Do you want to create a role? No, I'll just go ahead with whatever it is. These are the settings we have configured. So you see application information, environment, it's a web server, 64-bit Linux with load balancing and auto scaling. Sample application we are using. Environment name is this. This would be my URL. It's a T1.micro, key pair is Intellipaat, general purpose volume, VPC with security group, all is configured, and I'll say launch. It has started creating environment for me. Isn't that easier? Everything is being taken care. Now we learned the load balancer, we learned the auto scaling, how do we configure everything. Here everything is taken care by a single platform. Wouldn't that be a fun and easier way to manage? It would be creating each and every, so you can see the log also at the bottom, what it is doing. Whenever it keeps doing everything, it would keep adding the things at the log also. So we can see, till the time it logs comes, we'll see different part. When I go to the configuration, you can modify various configuration. As I mentioned, it's one place to monitor or manage all your configurations. So here you can say, this is my auto scaling configurations, where it says number of instance 1, auto scaling by entity also defined here. So it says currently there is 0 instance, but minimum and maximum is set. It says minimum is 1, maximum is 4. It supports all availability zones. Cooldown period is 6 minutes. Scaling triggers are also set that on network out you scale out, network in you would be scaling up. So scale out means adding one instance, or scale up over there. Scale in means you are decreasing the instance. If you want to set up the time based, schedule based scaling, you can also set up that here. You can add a schedule event also here. So this is how you are configuring your Elastic Beanstalk with that. I come back to configuration. You would also see this is the instance type, storage type. If you want to modify that, you can do that. This is the notification. This is the software configurations. How the updates would be deployed. Your networking. So this is your load balancer thing. You want to set up, this is the listener port. If you want to use the SSL with that. Do you want to enable the session stickiness? Health check interval. This is how we configure health check with the Elastic Load Balancer. So all the Elastic Load Balancer parameters in a single page. Same way all your VPC parameters in a single page. Now remember what is happening. Till now we learned the various services. We learned the EC2, we learned the EBS, we learned the auto scaling, we learned the load balancer, we learned the VPC, we learned the CloudWatch. Now you see combine of everything is available in a single page. This is your pass. Gives you the power to manage your application. It would also keep generating the logs, what is happening. Currently since application is not logged or launch, after that it will start generating the logs and do that. It will keep checking the health of this also. What is the instance ID, what is its status, you can see also here very easily. So load balancing request, latency, how it's performing, load average, everything available here easily. You can do your own monitoring with the CloudWatch. Alarms you want to configure, you can add alarms also. If you want to subscribe to various events, you can do that. You have given certain tags, it would be doing the tags also. If I go to my EC2 by now, you would find that it has started launching one instance for me. The demo name which we give, it is the URL of this. This URL it is working on. It is having the various security groups. So it is having 3 security groups. One is Intellipaat, which says 80 and 22. Should just check the rules here. We can check the rules here. So it has opened 80, 22, 80, all rules it has opened here. So this rule it has added from the second rule is coming from this new security group it has created. The new rule says open port 80 for this security group. Now what is the security group? We will see that. This is SG414, which says open for some Elastic Load Balancing Security Group. That's a 94. I add the second group also. This group allows over 80 traffic. So now load balancer is allowing the traffic on port 80. My security group allows traffic from port 80 from load balancer only. So if I directly try to hit this URL, it would not allow me. It would allow me because I have another security group which is added. That's the Intellipaat. If I remove that, it should not work. Rather, it should not allow port 80 directly with this. Even if I have not selected Intellipaat, that is okay. It was not required because Elastic Beanstalk has created its own security group and manage everything on behalf of me. I believe everything is ready for me. It's still creating. Let's check the URL if it's available and working for me. You can see that's ready. Your first Elastic Beanstalk Java application is now running on your own dedicated environment in the AWS cloud. You can see how do you work with the Elastic Beanstalk. That's the links they have just given. How do you work with the logs? These are the things available. But this is my application is set up and running over here on port 80. So this is how you will be setting up your environment and how it would be working for you. We can now go ahead. We can see this is the environment. It must have created a load balancer also. A load balancer is having a URL something like this. This URL is mapped with my Elastic Beanstalk URL. And this is how it is managing. My load balancer is managed with the URL. So that is managed by the Elastic Beanstalk internally. It would not be using my Route 53. It would be using the Elastic Beanstalk, and how this load balancer URL is mapped, that is managed by the Elastic Beanstalk. But overall, everything, yeah. If you want to give a sensible name to this URL, then you can use the Route 53 on your own. You can use Route 53 and manage this. Otherwise, you can directly use your own or whatever they given by Amazon, you can use that. So this is how the Elastic Beanstalk works. We are going to learn about the AWS DynamoDB. For that, first we would try to understand what is a NoSQL database. We would have an introduction to DynamoDB. We would have a key DynamoDB terminology, and then we would have a hands-on on the DynamoDB. Generally, when you have an RDBMS, that's a relational database, what does it follow mainly? It follows the ACID properties of a database: atomic, consistency, isolation, and durability. Now, in some cases, it's not possible to follow the ACID. Plus, when you see a database structure in a table, what would happen? If you have a, suppose you need an address record, you have a 10 fields. 6, 7. For now, keep it 8 or 9. Now, each column or each row would have the same number of columns. Whether you are using or not using, it would always have same. That is the rule of the RDBMS. But in some cases, you need only 2 columns. In some cases, you need only 4 columns. In some cases, you need completely different data structure. Is it possible to achieve with the RDBMS? No, the ACID properties does not allow that. What if we have a completely unstructured database? Unstructured database means in one row you want 3 fields, you get 3 fields or 4 fields. In one row you need 10 fields, you get those 10 fields here. In one row you need only 1 field, you use that only. This is the unstructured, and it may happen that whatever the data is in row 2 might not be similar way, the columns might not be similar as row 1. They all would be different. It's a kind of a schema-less unstructured data. NoSQL database is an unstructured database. It stands for not only SQL. It doesn't mean that it doesn't have the SQL. It means not only SQL. There are popular NoSQL databases like MongoDB, Cassandra, CouchDB, and many more. Amazon is having its own offering called Amazon DynamoDB. That is the NoSQL offering from Amazon. Amazon DynamoDB is a key value store where everything is stored as a key and there would be a value corresponding to key. So for example, you take the data of a citizen. A citizen would have some unique ID to identify that. Now one thing it would have is its a name, email, address, phone, everything. One would have this ID, but only its education you have not much information. One would have its a name plus it would have some more data like its a name, phone, email, address, education, graduation, job information, his personal information, everything would be one row might have that. So it's a completely unstructured. You can do this with no SQL. So important is there would be a key and each key would have a corresponding values. It's a highly scalable and fully managed database. Now what do I mean by the fully managed? The fully managed database means you don't have to worry about the database creation, database scaling, database backup, security patching. You don't have to worry at all about that. Everything is being managed by the Amazon itself internally. High availability, fault tolerance, everything, even scaling. So what you have to go is you have to go and create a table only. Even you don't have to create like we in RDS we were creating a database instance and inside that we created a database and there it had a database tables. So where we were responsible for managing backup or if we require snapshot. Though RDS provides all the mechanisms, or we have to plan for the multi-AZ, we have to plan for the failover, we have to plan for the performance with the read-only. Even we have to select the instance type, large, small, extra large. Nothing here. You just have to go and select a database or directly create a table only. Now what is the advantage you get here is with this, since it's a fully managed, you would be now able to work in a way that it would be able to, you just have to define the performance. What are the concurrent users you would have? Only thing you need to define is that, and based on that you would get the throughput, based on that automatically it will be scaling, automatically security patching, fully it will be managing on behalf of you. You can access through console and APIs. It doesn't have a separate database client like in MySQL we use the HeidiSQL, or you can use the Toad, PLSQL Developer, MSQL Studio, something whatever you are using. Here there is nothing like that. It is only through console or APIs you would be able to use that. Very high performance, and you can dictate your performance also. You want to say I want the 1000 reads 500 writes, or I want the 10,000 reads 200 writes. What is your performance required? You can define and you get that. It's a fully managed, so automatic hardware and software provisioning. It's internally secure, all the data encrypted. It does manage automatic patching, upgrade everything. Very easy to use. So we saw that DynamoDB is a fully managed scalable database. And it gives you predictable and controlled performance. The predictable and control means you can define what kind of a performance you want. You define and say what is your requirement. It comes with a built-in fault tolerance. So whether it's a working fine, not fine, it's everything is defined here. Automatically it would be internally if it fails, like we saw the case of the Elastic Load Balancer RDS, inherently it's a fault tolerance and it would be start serving you from the different infrastructure. Very flexible. What's your requirement? So you watch your concurrency requirements, otherwise it's scalable, easy to use. It can integrate with the Amazon's own Hadoop offering called Elastic MapReduce. It can work with the CloudWatch for the monitoring it provides services. It gives you strong consistency and atomic counters. So there are two kinds of a consistency model it offers, which we will see in a while. When you go to the DynamoDB in RDBMS, if you go, it would have a table. Each table would have a row and a column. Here it would have the table, but then table would have an item and the attribute. You do not need to create a database, just create a table. And DynamoDB database itself is a collection of table for you. So table would be collection of the data. In each there would be an item which is nothing but a group of attributes. And this attribute is nothing but a fundamental data entry or how the data is stored. For example, you have a training record. So for that you have a given unique ID, that's ID number 1. Who is the trainer name? ABC. Which training did he take? That is the AWS. On which date did he take? This is the date. What was the rating? 4 or 5? Whether course material available or not. In some case it's not that, it would be who took the training, that's a XYZ. The training is still not ready, so you just have that content ready or not, it's not ready. In third record you would have a trainer name, trainer email, trainer rating, date, follow-up session, hands-on session, training material available, feedback, and many more attributes. Each and everything, this what you are seeing is an attribute. You can say attribute is like a column in database, but the difference is it's a fundamental data entry and it can be unstructured in a way that multiple attributes make one item, and each item can have a different number of attributes. In our RDBMS, each row had same number of columns. Here you can see one item has a 2 attributes, another item has a 10 attributes, another item has a 6 attributes. That's why besides the key attribute, this is the key attribute. That's where the record is identified. Apart from that, everything else is unstructured. Each attribute is identified by a primary key. In the primary key is nothing like through which you identify. The primary key are of two types. One is a partition key, which is a simple primary key, which is composed of one attribute known as a partition key. That's like a normal primary key. Apart from that, there is a partition key and a sort key. This is like a composite primary key. Sometimes you want to say the training record and then the trainer name. Both should be combined because one training is conducted by many trainers. So here the trainer name would be a sort key and the training ID would be a partition key. So one would be having a multiple names over there, or training name would be.
Till now we have learned the various services and covered about the Amazon CloudFront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send the bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you. A few months back, Amazon SES also started a service called Receive Email. Initially, it was only for sending email, where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay-as-you-go model, very cheaper. Free tier gives you almost 50,000-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1,000 emails. So that's a very cost effective and cheaper service. It's highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it has a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email, for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1000 mails and 10 mails bounce, that's okay. But if you send 1000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much overquota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very, very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very, very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES is having two modes. First is you have to sign up with a simple email service. Initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once the production access is approved, Amazon would allow sending around, if I remember, 24,000 to 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all. But yeah, in that case, the feedback would come in a picture. It would keep checking whether the person is having a lots of bounds, complaints, and if there is so much complaint, the production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now, the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then it's considered as a legitimate mail and it would be delivered to your inbox only. It would not go to some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using SES console or using the REST APIs. What are the typical use cases of the simple email service? You can use for the transaction emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be a easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like Intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this Learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, it is authorized. Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. If I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID. Else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a@smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk. Or so that's why it's important how you deal with that. Now if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name, this would be port, you can use that. If there is a Amazon creates its own separation list, like if there are the mails bounced across the globe from various people, you can use that also. Those would be automatically, if you're sending the people using SES to those same people, it would be removed automatically. You can remove those separation list also here. If you have enabled the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do, all that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also.
Amazon Elastic Block Storage is mainly used for the persistence data storage. Now, what is block storage? So when you talk about the storage system, there are two kinds of a major storage system. One is a block level storage system, another is a file level storage system. In the block level storage system is more like a SAN or storage area network, where each block behaves like a raw unformatted volume. It's like each block is an independent hard drive. It works like a device which is mounted. It works as an independent hard drive. This each block is again controlled by the operating system. If you want to imagine, this is more like your hard disk over a remote network. In compare, when I go to the file level storage is more like a NAS systems. It's more like your regular file system. It's very easy to use and manage. Now when you go to the Windows and whatever kind of a file system you find, that's more like a NAS systems. And that's why it supports the various protocols like NFS, SMB, CFS kind of a protocols it does support. Advantage of the file level storage is that each can control individual files and folders, and that can be managed by this file level storage system. We know that we have in Windows, we would be creating a files and everything we can work with. Here in the block level storage, they are unable to directly control the smaller storage blocks. Here everything works as a block. Yeah, block might have as a data as a folder, or block might have a data as a file, but it's a whole as a block. One block may have a multiple data as part of that, and that's why those smaller storage blocks would make up your files and folders. So if you want to control at the OS level, now when you see at the OS level, you can see, oh, even my Linux machine would have a files and folders, then why it's still block level storage? But remember, at the underneath there is a block level storage, which everything works as a blocks, and the data might be stored in the various blocks, and Amazon, when you talk about, manages those blocks independently.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So that's why when you talk about the block level storage, one thing which is very important, you have to create a volume, you have to deploy an operating system, and then attach this created volume to the instance or server where you want to attach. While in the same case of the file level, the storage device handles the files and folders on the device over there. So there is a difference between block level and file level storage. At the same time, block level would also bring you more control, because if you want to take a backup and something, it would be easier to do that part also. Very good part over there. So we would be talking about the Amazon's own persistence block level storage, that is EBS. It gives you block level storage volume. So each EBS is known as an EBS volume, and that would be used with the Amazon EC2 instances. Also, Amazon does offer the relational database service, that's a RDS, which we would be seeing in the future videos. That also uses the underneath the EBS, because at the end what you need is a persistent storage, and that makes it idle for file system persistent database storage. EBS is the use case for you. If you remember, in the EC2 section we talk about there are two kinds of AMIs, EBS backed and the instance store backed. In the EBS backed, the root device is EBS volume. It gives you persistent storage, and this persistence also helps you achieve high availability and the reliability for the volume and the data. If you want to take the backup, it's a very easy mechanism. Just take the snapshot, and you would be doing in the hands-on also. That's a very easy to do that snapshot. Advantage is snapshot is an incremental, so whatever the data is being modified, only that part would be backed up, not everything. This EBS volume comes between size of the 1 gigabytes up to 16 terabytes. So you create volume as per your requirement. You increase that. It also helps you with the security because it provides the encryption mechanism. In addition, if you want to increase the size of the same system, you can do that. You can add multiple volumes to a single instance. So there are multiple use cases and advantages of using Amazon EBS volume.
So let's get started right now with the IAM, that is Identity and Access Management. So Identity and Access Management is basically a service wherein we can create multiple users to whom we can assign the AWS login ID and password, the access and the credentials. So let's get started. We will look into what is IAM. We will look into users, groups, roles, and demonstration, the hands-on demonstration I'm going to perform for each one of them. Identity and access management enables you to securely control access to AWS services and resources for your users. So we can create and manage users, assign policies, we can create groups. Then Identity Federation is the service using which we can associate Active Directory with AWS. And we can create and manage roles, and we can restrict the users, like what all services they can use in AWS. So that's the reason the term has been used. Fine-grained access to AWS resources. We can create and manage policies, and the most important part, this service is free. Only you are charged for the underlying resources. So let's get started with IAM. So, and sign into the console. So here we go, and we have to go inside IAM. Using IAM, we can create groups, we can create users. So first thing first, let us create a group. So I'm gonna give the name Intellipaat admin. So all the admin users will be put inside this group, and I can attach the policies. Suppose all the users who are being added, I want to give them EC2 full access. That means both read and write access to EC2, but not anything else. And I will go in users and add user. So the first username will be Ram, then it will be Ramesh, it will be Rohan, then it will be Rahul, and one more. So these are the 5 users I have added, and I want to enable the AWS management console for them to be accessed using the username and password. So either I can go with auto-generated password or I can customize the password. So as of now, I will keep the password as 12345678. And if I check mark this option, users must create a new password at next sign in. And now it's asking me, there is already a group that is int admin. Do you want to associate it, all the users with the group? Yes, I want to. So these are the choices I have made. There has been one policy attached, that is IAM user change password. That means on the first login, it is gonna ask the users to reset the password for them. And then I will hit create users. So these 5 users have been created. I can download a comma separated file so that I can share it with my management. So individual users name has been added with a link with which they can log in. So he will use this particular link, and the password, the username is going to be Ramesh, and the password will be 12345678, and sign in. We can see that Ramesh is able to log in right now. So straight away it is asking to reset the password. So the new password is going to be any random password, 8765431 and 8765431. So he has Ramesh @ root login ID, and he cannot use any other service other than EC2. So the only service that he can use is EC2. The only service he can use is EC2, and let us say if he wants to use S3, because we have only given the rights, that is EC2 full access. So you can see access denied, but no issues at all with EC2. He can spin up the virtual instances. He can see the other virtual instances. So on and so forth. Now I can log out from here and log into my root. IAM username is going to be, so I will log in with the root account, that is my account credential. And now, so the users have been created right now. So we can add a feature called multi-factor authentication, right? Like those of us work from home, the companies provide us one key fob so that we can access the company's network remotely using a VPN. So we can have the same feature here as well. Like, so we are inside Rahul's account, and we can go inside the Ramesh account as well. And if I go in security credentials, so you can see that the console login ID, we cannot edit it. Like the password, we can edit it, and we can also enable multi-factor authentication. So how do we do that? I click here. It's asking me, do you want a hardware MFA device or a virtual MFA device? So I will go with a virtual MFA device. And next step. So it's basically asking here that on your smartphone, you should have one Google Authenticator. Okay, so you can see on my computer screen, this is my mobile phone, and so this is the application that I have downloaded, that is Google Authenticator. And you also need one application, that is QR code reader. So QR code reader is right here. It's right here. So what I'm going to do is I will go here, and it's asking me to scan the code. So I'm going to scan the code with the application, that is QR code reader. And you can see that on my mobile phone, Amazon Web Services, a key has been added in Google Authenticator for Ramesh. And for Ramesh, this is the code 254157. 254157. So I will type 254157 and wait. So it's changing. The new code is 718125. So I'm going to say 718125. Hit enter. It accepts. So I will say finish. Now next time Ramesh tries to log in, okay, so here we go for Ramesh, and the password is 8765431. I say sign in. It asks for a multi-factor authentication code. So I will again refer to my cell phone 300083. So 3000. Now I'm able to log in into the Ramesh account using multi-factor authentication. Let me log in back with my root account. So I will say sign out, and let me log in with so I will click on this link and it will take me to the root account. So we can attach the different policies on the fly. Like if I go in groups, so right now in this group, we have Amazon EC2 full access. Let us say I want to give the users S3 full access, and so I can do that. Okay, now all the users will be able to access EC2 as well as S3. So that is users and groups. Now this is the flow chart. Create users, create groups, assign user to the groups, create the policies, assign policy to the user or group, user access, AWS resources. So this is what exactly we did just now. Now these are the definitions. So these are some terminologies. The account you use to register with AWS is the root account. Then we can create the login password, secret keys, and AWS policy can be integrated with S3, so that we have already seen. Then we can add multi-factor authentication using IAM.
Now, it is very important for all of us that do we monitor this service? Monitoring is one of the key aspects of any infrastructure. Unless you monitor, you would not know how this infrastructure is behaving, what are the trends, whether you need some upgradation, whether you need some more resources, or you want to decrease the resources. Amazon offers Amazon CloudWatch as a monitoring service. Amazon CloudWatch is a monitoring service for Amazon's own services. Though there are multiple things in addition to Amazon's own services, but the major purpose why Amazon CloudWatch was launched was monitoring of the Amazon's own service. In this session, we would talk about the Amazon CloudWatch and how it would be helping for you. So when you talk about the CloudWatch, CloudWatch has numerous examples or numerous advantages. The most important advantage you can think of is it is used for the monitoring service. So you can monitor Amazon resources in the real time. Now you mean real time means whatever the data is happening within a minute or 5 minutes you get the updates. You get the updates in a graphical way, so it's easier for you to understand. You can get the data in the various metrics and trends. So you can get trends, what is happening over the period of time. For example, if you see, let me draw this way. There is a graph something like this, which tells you that at certain period of time, like 9 a.m., your load increases. At 12 p.m., your load is much higher, and then post 5 p.m., the load started decreasing. That is the case. Unless you see graphs, unless you see the data, you would not know what is happening. And the advantage is you can get up to minutes of the statistic with that. And what is the use of any monitoring service if it cannot alarm you? And that's why Amazon CloudWatch has an amazing service called Alarms, which can send you notifications. It can send notifications over email. In if you're in the United States, it can send over the SMS, and there are some other ways also where you can get the notifications. It's also integrated with the various Amazon services like Amazon Autoscaling, which helps you to scale up and scale down also resources. You get the visibility of your resource utilizations, and the most important, the demand patterns. What is the peak usage? What is the bottom usage time? How is my trend going on? And that helps you to plan or forecast the resource requirements. When you're doing budgeting, costing, everything would be helpful for you. And don't forget, it also helps you for setting billing alarms. Everybody is using Amazon for the cost effectiveness. Though that's not the primary use case, but that's one of the important use case. And when you're talking about the pricing, it's a very important if you can set certain billing alarms which would tell you that how my usage is going and if it is going to cross certain limits or not. So that's what the CloudWatch is all about. Recently, I won't say it's a recent, it's a little a few months back, Amazon has started CloudWatch events concept also, which gives you delivery timely stream of the events. If there is some events happening, like there is change in Amazon resources, new instances are launched, new instances are terminated, they would be getting to the events and they would notify you also. And you can set up certain rules that on this event, take this kind of a route, notify something, or there is a service called Amazon Lambda, something you can work on that. So all these things would be working here. So this is what Amazon CloudWatch we are going to learn more and more today. And where can you use CloudWatch? You name the services, and it's very likely CloudWatch is having a monitoring service for them, whether it is Amazon EC2 or EBS, which we have seen till now. But then, apart from that, there is a autoscaling, S3, CloudFront, Cloud Search, DynamoDB, RDS. You might not know quite a few of the names. Route 53, Redshift, and as I said, estimated Amazon charges. That's the one of the key aspects. I want to know what is my billing I can get through CloudWatch. How do you start using CloudWatch? Generally, when you sign up with Amazon, CloudWatch is available for you. In quite a few, or I would say most of the services, it would be giving you data at every 5 minutes. That is known as a basic monitoring. When CloudWatch is giving you data at every 5 minutes, that is known as a basic monitoring. In some cases, it gives you a detailed monitoring case also, which is where it would be giving you data at every 1 minute. And we would be seeing those services in a while. CloudWatch can send notification to autoscaling also, where it can help you to scale up and scale down. And you don't need any additional software. Use whatever is offered by Amazon. You can use that very well. Now, how do you start using it? With the EC2, if you are in EC2, go to Amazon console, launch an EC2 instance, you would be seeing the detailed monitoring part. Yeah, there would be a monitoring tab. Generally, it would be a basic monitoring. It will be a basic monitoring aspect. If you enable the detailed monitoring, then it is a chargeable thing. You can get the instance state. So what is the instance, whether it's in running state, there is some issue with the instance. That also kind of a matrix CloudWatch does provide. And you get everything in a graphical way, you can get it. Yeah, if you want to get the data, you don't want to see only graphs at the Amazon level, but you want to collect the data, you can also do that. Amazon provides the APIs, command line tools, download the data, store it for your repository, and manipulate or present in your own way also. So this is how on the right hand side what you see is the how the CloudWatch graph would look like. When you see, I said there is a tab called monitoring. So this monitoring tab, when you click on that, there would be a few aspects. One is says enable detailed monitoring. This enable detailed monitoring, if you enable this or if you click this and you enable it, it is a chargeable thing. It would be chargeable, and remember that is not part of the free usage tier. So Amazon would cost you, or rather Amazon would charge you. How much? They would charge you $3.5 per instance per month. If you enable that for whole month, it would cost you $3.5 for whole month total. And when you go, if you have not enabled, that is a basic monitoring. Now you would say, what is the difference between basic and detailed? As I mentioned before, basic means it gets you data every 5 minutes, and detailed means it gets you data at every 1 minute. So if you see here the CPU utilization, discrete operations, there are multiple metrics which we are going to see now are available with the CloudWatch just for EC2. For each and every service, there are various kind of the available metrics and you can monitor those. Now, after all this introduction, if I go and tell you what is a CloudWatch, CloudWatch is nothing but a repository of the data which helps you in one of the core part of the scalable Amazon services. How? For example, if you have set up CloudWatch with your EC2 instance. Now, the CloudWatch, when it is set up, it would keep on generating various logs. Along with CloudWatch, you can set up alarms. When you can set up alarms, that alarms would notify you or notify Amazon services whenever there is a breach in the threshold. So if it crosses certain above level or certain below level, it can notify Amazon auto scaling. And you can configure auto scaling that whenever it receives the alarm, it can scale up or scale down. So this is the concept where CloudWatch plays a key aspect with the auto scaling. It would be very important that the CloudWatch generating the events or generating the thresholds and notifications, sending auto scaling would result in some scale up or scale down. As I mentioned a while back, CloudWatch is nothing but the repository of the data. It's just a collection of the data where data is collected in certain format at Amazon CloudWatch. Now, when data is collected, that would be in a format, say, it would be if you say a metric would have some name, namespace, a timestamp, a unit, a value, quite a few parameters a metric would have that would be stored inside CloudWatch. So if you see, it's just a database of the monitoring data. But that's not only for Amazon. Definitely, the prima function of the CloudWatch was to monitor the Amazon resources, but it does support your custom data monitoring too. You can monitor the custom resources, like if you have a desktop and you want to monitor the resource of that, you can do that. You can send the monitors, or rather, you can send the metrics to CloudWatch. CloudWatch provides APIs, command line tools, which allows you to upload your own data to CloudWatch. I'm sure everybody would say, why would I upload my own data to CloudWatch? Does it give me any advantage? It does. Because with the CloudWatch, it has CloudWatch alarm. The CloudWatch alarm can be sent that whenever metric, suppose I'm drawing a graph that my usage is something like this. And I can say, whenever it crosses the above threshold, or this is my below threshold, whenever it crosses the above threshold for some time, it would generate an alarm. So I can configure an alarm that's saying whenever CPU utilization is above 70%, take certain action. Or whenever CPU utilization is below 10%, take certain action. So this way, CloudWatch alarm plays a key aspect. And we all believe that there is no use of a monitoring service unless it gives you alarm, because it's not possible to keep on monitoring 24/7. If you get the alarms, that would be more actionable item for you. CloudWatch goes one step beyond. It takes actions on behalf of you also. You can configure the actions. So it can allow to take three kind of actions. First action is Amazon Simple Notification Service. Now, Simple Notification Service comprises of the four major blocks where it can send a notification over email, it can send notification over some HTTP URL, it can send notification to some SMS over through. But remember, SMS is only available for US as of now. Also, there is a SNS where you can send to your custom, like the mobile notifications you want to send, you can do that also. So it does support the mobile notification also. So email, HTTP URL, SMS, and the mobile notification. SNS, Simple Notification Service, is a service which sends notification over four channels. So whenever, for example, CPU usage goes above 70%, CloudWatch would notify SNS saying there is an increase in the CPU utilization. SNS would say, okay, I have an action configured here which says that whenever you get this kind of an alarm, send an email to Intellipaat. It would immediately send an email. It can also do that. I have also configured email that whenever there is some event, you notify over HTTP URL. Now you would say, what would the HTTP URL help me? Suppose you have created a automated report tracking tool which is hosted on some website where there is a HTTP URL. You can hit it there. It will automatically create a ticket for you. It's just an example. If you are in USA, you can get an SMS also. So CloudWatch would help you get real-time notifications. Apart from that, the second service which it sends notification is, or it can send, is auto-scaling. The auto-scaling service we spoke in the previous slide allows you to scale up or scale down. So auto-scaling would be scaling up or scaling down and help you. Then third service is Amazon. If it's for EC2 only, it helps you to take EC2 action. Like due to certain reason, you want to stop an instance, you want to start or terminate an instance, or you want to restart an instance. Now just imagine a case. You have set up a web server. Now there is a web server which is running on your EC2 machine. Due to heap memory or certain issue, the web server becomes unresponsive. It has stopped. It might have crashed. Right? Now your EC2 machine is running fine, but your web server has stopped. If you have set up certain kind of your custom parameter or certain kind of a monitoring which says that your web server has stopped, what you can do is you can notify the CloudWatch would then notify your EC2 instance and say reboot. It would reboot, and if you have set up the bootstrapping for your instance for your web server, it would automatically restart the server and would solve your problem. In some cases, you think there is a long running process which can run 8 hours, 10 hours, 15 hours, 3 days, 5 days, something like that. Take an example, some batch processing, heard of something, and you want to say whenever batch process completes, it would be copying data automatically to some centralized folder or some database. But after that, I don't want the instance to continue running. Reason, it would be costing me. There is a better option available for you. Why don't you stop the instance or terminate the instance? So you can set up that for this kind of a EC2 instance, whenever CPU usage falls below 1% for 1 hour, 2 hour, you can say take an action and terminate or stop the instance. So CloudWatch can take action on behalf of you also. What are the action? SNS email notification, auto scaling, and EC2 instances action. We would be seeing in the demo most of the actions as now. What are the services CloudWatch supports? When you talk about the basic monitoring, which is every 5 minutes, it has a EC2, auto scaling, Elastic Block Storage, DynamoDB, Elastic MapReduce, Amazon Machine Learning, Simple Notification Service, Simple Queue Service, and a few more. There are quite a few services which it supports every minute of the monitoring. Out of this, only EC2 and auto scaling, when auto scaling running for the EC2, when they have detailed monitoring enabled, it's a chargeable. Apart from that, everything is free of cost. It doesn't cost you extra. Now, when you want to see the default metrics for CloudWatch, there are various kind of a metrics available with the CloudWatch. If you see, there is EC2 instance. EC2 instance would have a lots of metrics like CPU utilization, discrete bytes, discrete operations, discrete bytes, discrete operations, network I/O, and many more. CPU credit usage, CPU credit balance. Those are available when you have a T2 family, which gives you CPU credit. When you see all these parameters are available, and quite a few are available at every 1 minute also. A few parameters which would be interest for us is status check field. When you launch an instance, if you remember in the EC2 I mentioned, we have to wait till the instance state is 2 by 2 status check pass. Unless that is 2 by 2 status check pass, it's not used for us. And why it was the case? Because this 2 by 2 are, one is status check failed and one is status check failed system. These are the two checks an instance has to pass before it is available to you. Now, why do you need those chains? These checks are required because it's a virtual machine available on the cloud, available over the internet. So Amazon does a checks on behalf of you, like whether instance is launched correctly, does it have a network connectivity, does that system has a power capability, if it does not have any software issue or any hardware issue. So anything at a hardware level or firmware level issue, they are check at an instance level. Then anything at the operating system level, like failed system status check or misconfigured networking or startup configuration, memory issue, corrupted file system, incompatible kernel, all these issues would be checked by the system status check system command. If these two pass, that means there is no issue in the system and system is running perfectly or instance is running perfectly fine for you. So it is important that when you see the status check, if it's a 2 by 2 means both the checks are passed and the system is available for you to run. At the same time, when you see Elastic Block Storage gives you the parameters for the read operations, write operations, read time, and so many. So when you see the IOPS, it would be for the operations or the for optimize total read time. So you get all these attributes which would help you to understand what are the metrics important for you. If you are interested to read more about the metrics, these are the URLs available. You can go through and it would list down each and every metric. Now I keep on talking about the metric. A metric is the fundamental concept in the CloudWatch that represents a time order set of data points. That means a data at certain point of time. For example, current time is 10 a.m. So at 10 a.m., what was the temperature? That's a 30 degree. That is your metric. So what metric would ever? It would have a name. What is name? Here you can think that temperature is the metric name. Then namespace would be whether it's a combined under the some environment variable or something. It's a group of the variables. It would have a one or more dimensions, timestamp, and unit of measures. Now, what are these all aspects about? When you talk about this, a namespace is nothing but a container for the metrics, where a multiple metrics combine and make a one unit. So, for example, a EC2 instance. The EC2 instance has a multiple metrics. It would have a for CPU usage, it has a disk read, or it would have a CPU carried, kind of a various metrics available. All these metrics are combined under one namespace, that is AWS/EC2. Same way, autoscaling would have a different metrics. They are combined under AWS/autoscaling. So namespace is nothing but a bucket or a container for all the metrics. When you go to the dimension is nothing but a name value pair that help you to identify a metric. For example, in EC2 you would have a autoscaling group, image ID, instance ID. Now what does that mean? If you take an example, you have a EC2 instance. That each EC2 instance would have some instance ID that is launched from some image. It would have some image ID. It has an instance of size micro, small, large. It would have an instance type. It might have some volume attached to that, so it would have a volume ID. So these are the attributes of an EC2 instance, and that each would have some value associated with that. Now you would think, why do I need this? Sometimes you can group based on that. For example, you want to see how are my all micro instance doing. So you can group based on the instance type. Correct? Or how are my instance which are launched from this my own AMI doing? You can get it from here. The dimensions are nothing but a way to identify a metric, a different or unique way to identify the metric. Each metric would have a timestamp also. That is the most important. That would be in a microseconds or whatever way, and the timestamp would be in a UTC format always. UTC, that's what the Amazon supports, the time zone format. Each unit would have or each metric would have a unit also. That unit you can think of it like a byte or seconds or the percentage or kind of a unit it would have. Each metric is always specific to a region, because all service would be specific to region, so it would be part of that region only. Some of the sample namespace I have listed here, they are for Elastic Block Store, it would be like EBS. For Elastic Compute Cloud, it would be like EC2, or SNS, it would be like SNS, something like that. That's the namespace. And each would have a multiple metrics as part of that, and each metric would have a dimensions as part of this. So dimension, as I just mentioned, it's a name value pair which helps you to uniquely identify an instance. Timestamp is also a very important aspect for you. Timestamp is ranging, it would be where it would be up to 2 weeks in the past. It is very important to understand that the timestamp is always measured in UTC format, so it can convert to your own format. But Amazon CloudWatch keeps the data of the last 2 weeks only. At any point of time, there would be data of the last 2 weeks only. There would not be any data beyond that. But you say, oh, I want to capture the data of the data before 2 weeks. How would I do that? Then you have to download the data on your own and you have to save that. You have to download the data on your own and save it. Amazon does not provision any option to save the data. You download it and you store in your own database. We talk about the units. There are the various samples which are the units, like you can have a seconds, bytes, bits, percentage count, bytes per second, bits per second count, or second none. So there are the various kind of units you can have that. So when you talk about the metric, as I said, has a multiple things. It would have a name which defines the name of the metric, like it's a CPU utilization, it's a read operations, write operations, what is it that? Then it would also have on top of that a namespace which uniquely identifies to helps you to group the metrics. Then it would have a dimension, which are the attributes of a metric. It is having unit, it is having a timestamp also. Also, CloudWatch provides the various kind of a data aggregation methods. That is the statistics, where it gives you statistics like a minimum. So over this period of a 1 week, 2 week, what is the minimum value? So it would show the sample values of the minimum. It would show the maximum values during that period. When you see sum, it would say all values submitted and the matching metric added together. When you try to get the average, it would say what was the value of sum or sample count during that part. When you say sample count, it would find out the sample during the each period and give you. So Amazon CloudWatch also helps you to get the various. It does have a periods also. The period can be as short as a 1 minute and as long as a 2 weeks, because it goes up to the last 2 weeks in the back. You would have a start time and end time also. You can specify to determine what period data you. Alarms, the best thing that happened to the CloudWatch. That's because it helps you to make decisions and take an immediate actions. Alarms can automatically initiate the actions on your behalf, and based on the specified parameters, it can work for you. It can take an action to SNS, as I said, email, or if you want to take the EC2 action, or even it can take the auto scaling actions, kind of a various actions it can take. Each Amazon is specific to a region. Rather, each Amazon CloudWatch metric is specific to a region, and one region data is not available in a separate region. Because the service belongs to that region, the data of the CloudWatch also belong to that. CloudWatch does support the custom matrix. The custom matrix helps you measure or monitor the data for your own case. So, for example, you have some example where you want to take the case of your own Linux operating system. How is that doing? What is the device space, or what is the disk space available? What is the disk space used? Those kind of a matrix you can see here. The CloudWatch does support that. What you have to do is, if you are using a Windows, you just need to run certain PowerShell scripts. And if you are running a Linux, you run some Perl scripts, which should help you to generate the matrix and send it to the pricing. CloudWatch basic monitoring is free of the cost. It doesn't cost you. Plus, if you are part of the free usage tier, you get up to 10 metrics, 10 alarms at free of the cost with the CloudWatch. But remember, detailed monitoring is not part of free usage tier. It would be chargeable to you. So don't forget that digital monitoring would cost you. So that's it for the Amazon CloudWatch theory. I hope you all enjoyed this. Bye-bye.
So Opsworks is a configuration management tool that basically involves a DevOps tool called Chef for continuous deployment. So as I said, it is a configuration management service that helps you configure and operate applications of all shapes and sizes using Chef. These are the key features. It supports any application the whole configuration becomes code due to Chef, automation to run at scale, and resource organization. So there are few terminologies used in AWS Opsworks. The first is stack. Now the stack is a cluster of EC2 and RDS instances. Okay, and a layer is a blueprint added to it, which basically defines like what type of EC2 instance is going to be that. Is it going to be a web server, application server, or a database server? So those kind of configuration details are mentioned in the layer. So layers give you the complete control over which package are installed, how they are configured, and how applications are deployed. Now, recipes and cookbooks are something which we study in detail when we actually take up the topic on Chef, because recipes and cookbooks is something which is denoted by Chef only. So let me show you the practical demonstration for AWS Opsworks. So for AWS Opsworks, let me check if there is a video that is available. You can check, like the one we had for Elastic Beanstalk. I think there is a video. So we can get that video here. So many times people ask what is the difference between CloudFormation and Opsworks and Elastic Beanstalk. So the first major difference is Opsworks does not work alone. It works in collaboration with Chef, which is a DevOps tool, and it has cookbooks and recipes to deploy the configuration. So here is the video. That it's a 3 minutes video. Whenever you get time, just go through this video. That is introduction to AWS Opsworks stacks. And first thing first, we have to create a stack. So right now, do we have a stack? Let me check. So first of all, we are going to add a stack with Chef 11 because that has built-in cookbooks and recipes. So I'm going to name it as Intellipaat first, and rest everything will be same. And I say add a stack. So the stack is being added right now. Now the next step is to add a layer. So how do we add a layer? We click here, and here I'm going to add a PHP server. So I would say PHP app server because the code, my application that I want to deploy is written in PHP. I do not want to attach an Elastic Load Balancer as of now. And I say add the layer. So the layer has been added. And to the layer, I'm going to add one EC2 instance. So I'm going to add t2.micro, which is free tier eligible. And I say add an instance. Now on this instance, I'm going to start it. And on this instance, my PHP application is going to be hosted. So it is starting the instance right now. So as I said, it is explaining the difference between Opsworks and CloudFormation. So CloudFormation is used for spinning up the AWS resources. However, Opsworks is something which is used for deploying the third-party applications, which can be written in Go, AngularJS, Node.js, Ruby, Python. All right. So the same difference is between Opsworks and Elastic Beanstalk as well. Like Elastic Beanstalk does not involve any Chef configuration. So the instance, the EC2 instance is getting started right now. Okay. So it is online. The instance is online. The next thing is to add an application, the PHP application that we were talking about. So I'm going to give it a name, Intellipaat first. And my application is stored on Git repository. So I'm going to provide the URL for Git. It's right here. So here we go with the URL. We say add an application. So the application has been added. Now the next thing is to deploy the application. So we are going to deploy it on the EC2 instance that we just created. And it is being deployed right now. Okay. So this has been successful. And all we have to do is go to PHP app server. And basically we need to go into instances. And this is the IP address. So it says your PHP application is now running in your own dedicated environment in the AWS cloud. And this host is running PHP version 5.3.29. So in CloudFront, we will learn about edge locations. We will see the hands-on practical for CloudFront. And so CloudFront works on the concept of edge location. And there are around 54 edge locations across the globe. So what is an edge location? An edge location is the third-party data center that is not directly owned by Amazon, but Amazon has done tie-up with certain vendors such as Reliance, Tata, etc. So the whole purpose behind edge location is to expedite the complete process and decrease the latency. So let us say I'm sitting in India, New Delhi, and I want to access a website that is hosted in United States. So the content of the website will first be delivered to one of the availability zone here in India, which can be in Mumbai. And from Mumbai, it will be transferred to one of the edge location in New Delhi. And it will be stored there permanently as a cookie or as a cache. And then the page will be delivered on my laptop or my desktop. Now, the second time I ask for the same page, the request would not go to United States server. It will directly search for one of the edge locations in New Delhi. And if it finds the content there, it will pick it up from there and deliver it on my computer, right? So CloudFront is a global content delivery network service. It caches the static objects. So that is what I told. Charges are pay as you go. And in Asia, there are around 13 edge locations right now. And what it does is it puts the objects in S3 and then it creates the distribution. So what do we mean by creating the distribution? It transports the content to the 54 edge locations across the globe. And it issues a link to the object. So one can access the objects using a link or a hyperlink. So that is something which we are going to look into right now. So this is the basic diagram of CloudFront. So there are developers. Developers store the object in S3 or HTTP server. And then a function is triggered to call Amazon CloudFront. And what CloudFront does is it distributes the content across all the edge locations. So on the right hand side, you see a diagram wherein a user is sitting on the computer. It is asking for the website, and the request goes to edge location. If it doesn't find an edge location, it goes to the S3 bucket or the HTTP server where exactly it is hosted. And then from there, the request is retrieved onto the edge location and finally onto the end computer. Basically what happens in S3 bucket, we can store a lot of variety of objects like HTML, CSS, JavaScript, images, and then CloudFront fetches the information from S3 and then distributes it across the edge locations. So here we go with aws.amazon.com and sign into the console. So let me sign in with the credentials. And here we type CloudFront.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So straight away it asked me to create a distribution. So there are two types of distribution. One is web and other is RTMP. RTMP stands for real-time messaging protocol. So the difference between web and RTMP is that in web, the content will be stored both in Amazon S3 or it can be on an HTTP server. But here in RTMP, it can only be on Amazon S3 bucket. It cannot be a EC2 server or HTTP server. Okay. So that is the difference. So we will go ahead with web option. And here it gives me the S3 buckets that we had created. So let us go with Intellipaat training S3. So let us check first what all objects are there inside the 3 buckets. So this is the bucket and we have all type of objects, cf1.png, cf2, tp1. So all these are there. Okay. So origin path I will keep blank. It is for the specific file that I want to access over an S3 bucket. And restrict bucket access, I will keep it to no. And I don't have any header name and values as of now. And protocol policy, I will go with HTTP and HTTPS both. And I can choose this option, that is get head options put post. So these are basically functions which will be triggered whenever somebody tries to access my S3 bucket. And here we can customize the object caching. The minimum time to live is 0 seconds and maximum time to live is 31,53,000. No, it's more than that. So these many seconds are there in a year, right? So default time to live is 86,400 seconds, which are there in a day, 24 hours. So if we multiply 86400 by 365, so it comes out to be 3,15,36,000 seconds, which is in a year. So these many seconds are there in a year. So maximum time to live is 1 year, and rest of the options will be kept default, and distribution state I will keep enabled and hit create distribution. So it is creating the distribution right now. It will take exactly 15 minutes, 15 minutes to create the distribution. So these are the number of edge locations that we have in different regions across the world. So if we talk about Asia, we have the edge location in Chennai. Then we have the edge location in now, as per the recent report, the edge location is there in Pune and Delhi, New Delhi as well. So 3 edge locations. Now these are the different features of AWS CloudFront. Like we have caching, fast and simple, easy to use. Then we can download the distribution. It supports HTTP and HTTPS request. It is elastic in nature because it is configured with S3, and we can have the real-time streaming with RTMP. It supports cookies. It integrates with other AWS services, and it is secure with private content. Okay. So it supports the query strings, as in some queries which are written in SQL, even those are supported. The one that we saw, get, head, push, post. So those kind of strings are very well supported with CloudFront. First of all, we have a user, and let us say he is sitting on the internet. So this is internet, and trying to access a website that is hosted on the AWS cloud. So this website is hosted on the AWS cloud, and there are 2 servers. One is the primary server, and the second one is the secondary server. Now there can be one elastic load balancer in between, which is distributing the traffic towards the primary server and the secondary server. Okay. Now, let us say he's trying to access a website. All right. That is www.eduism, because that's the domain name I have purchased from GoDaddy, eduism.co. All right. So the request can come to the primary server, or it can come to the elastic load balancer, and then elastic load balancer will route the traffic between the primary server and the secondary server. The brief architecture. This is the brief architecture, how things work. Eduism.co top-level domain name server. It checks into the authoritative domain server. It also checks into the example.com authoritative DNS server. Fetched. So the route 53 comes from the name, because this route 53 service works on the port number 53. That is the port number for DNS. Okay, so that is one thing. So this is once again a cycle. A user is sitting on the computer, and he's looking for a website, www.example.com. The request comes to domain name server, and domain name server, if it has the records, it will forward it. If it does not have, it will say, I don't know. And I will ask the authority server. So authority server is when the request goes to route 53, and route 53 reverts back with the IP address of the example website, and it forwards it to DNS resolver, and finally the DNS resolver forwards it to users. So as discussed, it is a highly available and scalable domain name system web service. It effectively connects user requests to infrastructure running in AWS, such as EC2, ELBs, S3 buckets. And we can also route the users to infrastructure outside of AWS. So that is something which we are going to see right now. It is fast, easy to use, and cost effective. It answers the DNS queries with low latency by using a global network of DNS servers. And if you need a domain name, we can find an available name and register it using Route 53. So these are some key takeaway points. Now, it is reliable, fast, integrated with AWS, easy to use, cost effective, and flexible. It is reliable because it works on the concept of edge locations. So there are 54 edge locations supported by AWS, and it can be managed using command line interface as well. It is quite cheap, and it follows the round robin scheduling. So if the request is coming onto the Elastic Load Balancer, it has the capability of following the round robin scheduling to distribute the traffic among the various servers. We can run application in multiple AWS regions and route users to the one. So in case of failover, okay, let us say that this server stopped working, and this entire infrastructure is in Mumbai region, okay, and we can failover to a server that is in Singapore region using Route 53. So any request that is coming to the primary server will be rerouted to the failover server in the Singapore region. So that is what I'm going to perform the practical demonstration. So you can see that, okay? So that is one thing. And it follows the concept of hosted zones and record sets. So what exactly is the hosted zone? So let me show you right now. Now we have a website called mail.google.com. Then we have something called as contacts.google.com, and we have drive.google.com, and we have photos google.com. So these are basically the record set for a single hosted zone, that is google.com. So hosted zone here is google.com. This is the hosted zone.
In this, we are going to learn about the AWS SES or Amazon Simple Email Service. Till now, we have learned the various services and covered about the Amazon Cloudfront and Amazon Import Export with the Snowball. Amazon Simple Email Service. You would see what is Simple Email Service, where this is used, what are the key features of the Simple Email Service, and we will see a demo of Simple Email Service too. Amazon SES is a cost-effective, scalable email service. It is useful to send bulk emails. Remember, this is not your replacement of your Gmail or Outlook mail. No. But if you want to send a bulk mail, transactional mails, huge number of mails, this is the ideal solution for you. A few months back, Amazon SES also started a service called Receive Email. Initially, it was only for sending email. where the mails would be received, delivered to your AWS S3 bucket. But the major purpose is it's used for the sending email. Important aspect is it supports pay-as-you-go model, very cheaper. Free tier gives you almost 50-60,000 plus emails in a month, free of cost for up to a year, and then over again also it would be charging you 6 cents per around 1000 emails. So that's a very cost effective and cheaper service. It's highly reliable and very scalable. Simple email service, easy to use and very scalable. Important is it gives you a feedback loop mechanism also. So whenever a mail is bounced due to any reason, over quota or due to the wrong email ID, it gives you back. And it also keeps track of that how many mails from your end are bouncing. And with this feedback loop, you can always increase your delivery rate. It does work with the Amazon other email services or other services. It can integrate with them. And it has a very easy to use interface. We will see that also in a demo. Where it would be useful. When you want to send for bulk and transactional emails, it's a perfect support. It does support the SMTP also. So you can use the SMTP to send the emails using Amazon SES. It does support the receiving emails also and deliver them to the S3 bucket. But do not use as a junk email, as AWS may stop your access. Remember, that's a very important point. If you try to misuse the SES as a junk email for sending junk or hacking or some other purpose, Amazon would stop your access, because Amazon keeps giving you feedback, what your success rate, everything, and it also keeps track of that. If it finds there is a huge number of bounds and your production access may be stopped for SES, it would not allow you to send more emails. It's very important you use it wisely. It's a very cheaper email service for delivery, cost effective. And those emails are bound to fail. We know that emails may bounce. So it doesn't mean that if one or two mails fails, Amazon would stop your production access. No. But it evaluates you. It continuously keeps checking what is your bounce percentage. If you send 1000 mails and 10 mails bounce, that's okay. But if you send 1000 mails and 600 mails bounce, there is a serious problem. If there are a huge number of complaints received from your email, or the quality of email is not good, it keeps checking how much bounce percentage, how much complaints, how much over quota, something like that, and it thinks, okay, there is something wrong. SES takes those parameters very seriously, and it can reduce your production access. But if your bounce percentage and the quality of email is good, it's within a measure, that measure is defined by Amazon, SES is very cost effective and service for sending email for you. How would you use SES? When you sign up with the SES is having two modes. First is you have to sign up with a simple email service. You would be using, initially you would be using beta access. During the beta access, whatever email you want to send from, so if you want to send from my email ID, learnawsonline@gmail.com something, and you have to first verify those emails before you can send from that ID. Even if you're sending a mail to abc@abc.com, you have to still verify that email ID. Otherwise, it would not support. You have to send to approved emails only. So abc@abc.com has to approve you. Then once it is done, you can request a production access. Once the production access is approved, Amazon would allow sending around, if I remember, 24,000 to 50,000 emails in a day, or little more, much more. But everything keeps increasing gradually based on the mail quality you are sending. And then you can send email to all. It will keep checking the feedback. So in the production access, you do not need to get approval of each and every email addresses. You can send to all. But yeah, in that case, the feedback would come in a picture. It would keep checking whether the person is having a lots of bounds, complaints, and if there is so much complaint, the production access would be banned. Sometimes it may happen that the people, suppose you are sending an email from abc@gmail.com. Now the mail would be from this person, the SMTP and the from would be something from Amazon SES. In this case, quite a few mail clients would consider that this is a spam mail and they would immediately move that to a spam. So that's not the right way. How can you overcome this? You have to use domain key identified mail service. This is this is a standard that allows senders to sign their email message. So when those email messages are signed, they know this is an authorized email, this is not a junk. It might be used from a program, but it's an authorized. Then it's considered a legitimate mail and it would be delivered to your inbox only. It would not go to some other box. This DKIM signing helps you delivery of email message. ISP can verify this. This DKIM also you can configure using SES console or using the REST APIs. What are the typical use case of the simple email service? You can use for the transactional emails, bulk emails, system emails, gaming, social networking, blogging, subscription emails, business emails, and many more. Just in a case, the people who are using Candy Crush, they might be sending a request to their friends, though it might be through Facebook, but there might be a way you can invite through emails, or there would be a way you want to share your score with your friends. Simple email would be an easier service for you in this case, where you are a game programmer, you want to send those transactionals or gaming or the bulk social networking mails. This is a perfect solution for you. Let's see a demo of the simple email service. I'm going to simple email service. Currently there is nothing available. So either you can, if you are owning your own domain like Intellipaat.com, you can verify your domains, or I'll start with the email address. I'll say verify a new email address. So verify this email address. It has sent an email to this learn AWS. The verification is pending from this user. If I open my inbox, it would show there is an email from Amazon Web Services. It says, do you authorize this person? I say yes. Once it is authorized, it is authorized. Now I can use this console. It's a verified. I can use a send a test email. Remember, I am still in a production access. Sorry, I am still in a beta access. I need another email ID. So if I say abc@gmail.com, just an example. If I try to say send, it would not. The abc@gmail.com is not verified yet. I need to verify that email ID. Else I have to send an email to only authorized email ID. So it would send the mail to them. You would see that there is a mail from me only. The sender is me and it has sent me, hello, how are you? If I go and try to see the headers, you would see the received from a@smtp amazon ses.com by Google to learn AWS online.com. So mail is received from this, and in those cases, if it's not authorized, it's likely that it would be marking them as a junk. Or so that's why it's important how you deal with that. Now if I go back to my console, this is how you send an email. If you don't want, you can always remove this ID. You can get your sending statistics with CloudWatch, how many mails you delivered, how much it worked. You can make your SMTP settings also. If you want to use it programmatically and you want to use it you want to do it using SMTP, you can do that. This would be your SMTP server name, this would be port, you can use that. If there is a Amazon creates its own separation list, Like if there are the mails bounce across the globe from various people, you can use that also. Those would be automatically, if you're sending the people using SES to those same people, it would be removed automatically. You can remove those suppression list also here. If you have enabled the domains, then after enabling domains, you can also enable the DKIM setting. That also you can do that. So this is all about this. Now you would say, how do I enable my production access? So to enable your production access, you have to go and request over Amazon support. Over Amazon support, you have to go and request. So if I go to support center, and here you have to request for the SES production access. I have to create a case. Remember, this is where you have to request for service limit and Amazon. Here you have to accept request for that. Okay, for US East, I want what are my times of mails, what I'm going to do, all that you will be able to request here. You have to request over support. Now remember, the support service is free of cost because you have selected basic support plan. Amazon offers various different kinds of support plans. Ideally, with a free user tier, it would be good. We can increase the limits with that also. So this is about the Amazon SES, a powerful and scalable and easy to use tool for sending an email.
So these are some key terminologies. What is EBS, what is EBS volume and EBS snapshot. So EBS is the block level storage. It is just like the solid state drive. And it is really fast. So EBS volume is the EBS. It can be a general purpose SSD or provisioned IOPS or magnetic volume that can be attached to an EC2 instance. And a snapshot is a point in time backup of volume used to instantiate multiple new volumes. And we can expand the size of a volume or move the volumes across the availability zones, regions, as well as the various other accounts as well. So snapshots can be transferred from one AWS account to another AWS account, from one region to another region within the AWS account, and from one availability zone to another availability zone. That is how it contributes to high availability EBS snapshot. So the one condition is that the EBS volume which is going to be attached to a EC2 instance has to be in the same availability zone. Let us say we have this EC2 instance in 1A. The EBS volume that I'm going to attach to it has to be created in 1A only. It does not work like cross availability zones. It does not work. So right now the server is ready. So let us run the command lsblk to figure out how much space we have got. So it is saying only one volume is attached right now, that is XVDA, which has got two components, XVDA1 and XVDA2. And it is overall 10 GB in size. We can also see the volume through df minus h. So it also says 10 GB volume is there. This is the volume, the boot volume that was created along with the instance A, 10 GB. And we can create a new volume. So we are going with general purpose SSD. If we go with provisioned IOPS, it's going to cost us extra. That is chargeable. So as cold HTTP and throughput optimized. Magnetic is free, but it's very slow. So that's the reason I will go with general purpose SSD. And size I'm gonna take is 10 GB. Maximum I can take 16 TB. And the IOPS, that is input output operations per second, is going to be 300, and the maximum is 3000. So since we have taken 10 GB, the IOPS has changed to 100. If we take 30 GB, Let us keep it to 10 GB as of now. And the availability zone is going to be 1A, and I want to encrypt this volume. So I want to encrypt it with the default AWS EBS key and sign into the console. So I will have to go in IAM, Identity and Access Management, and check out the option encryption keys. So right now the key that we are using is AWS EBS. I can create my own key. So I can create it by the name EBS, and I will keep the same description. And I want to have a KMS, that is Key Management Service. I would not go for external. And I will hit next. So this is the key that has been written in JSON format, is ready right now. So this key has been created in North Virginia. So that means I should be able to use it here. So I want to go with 10 GB. It will change to 100 IOPS. And I will make sure that I'm creating the volume in the same availability zone, that is 1A. And I can encrypt this volume using either default ABS, or I can use EBS as well, the one that I just created right now, and hit create. So I will give it a name as extra volume. It is available right now, and I can go in actions and attach this volume. The moment I click on instance, it's automatically going to show instance A in North Virginia. And the device it is going to allocate is /dev/sdf, and I say attach. So now if I go back to the console and run the command, so let me run the command. So now if I run the command lsblk, I can see that XVDA is there with 10 GB, and XVDF, the new volume that we just now added, is there 10 GB. Now if I run the command df-h, only 10 GB volume is there, that is XVDA. It is not showing up XVDF. The reason is it is not mounted and it is not formatted as well. So first of all, we will have to mount it, as well as we will have to format it in order to replicate the changes. So first of all, we will format this, and the command that we are going to use is sudo mkfs-t ext4/dev/ the name of the volume that we have attached, that is XVDF. It has been formatted. Now the next step is to mount it. So in order to mount it, I will first create a directory, new, and now I will mount it on the new directory. So I'm going to mount this newly created volume on new directory. So it has been done. Now if I run the command df-h, it is very well showing here. So two components are there, XVDA and XVDF. So it's very well showing here, and I can cd into the new directory and create some empty files. Sudo touch 1 2 3 4 5. So I'm going to create 5 empty files, and if I run ls-lia, all the 5 files are listed: 1 2 3 4 5. So on this new volume, 10 GB volume, extra volume, xvdf that I created, I have added 5 empty files to it just for the demonstration purpose. Now let us dig deep into EBS volume. So this is the life cycle of EBS volume. We have unused space. We create a volume from 1 GB to 16 terabyte. We attach it to an EC2 instance. Now we can use it. So we are done till here. After that, we can create a snapshot. What is a snapshot? It is point in time backup of the EBS volume, and that snapshot will be uploaded on a Amazon S3. We can attach this snapshot across the AWS account within the multiple regions, as well as we can transfer it from one AWS account to another AWS account. And from this snapshot, we can create multiple volumes of even bigger size. Let us say that this 10 GB volume, I created a snapshot. Now from that snapshot, I can create even a 20 GB volume that will have all the data of the 10 GB volume as well. So that is what we are going to see right now in the practical demonstration. So this is the architecture of EBS volumes. EBS with the EC2 and S3. So basically what happens, all the EBS snapshots are stored in S3 volume. So basically we can create the snapshots, and from that snapshots, again, the volumes can be created and attached to EC2 instances. And all of this can be managed and accessed via the internet. So these are few features about snapshots. We can create a snapshot of any EBS volume, and these snapshots are stored in Amazon S3. There is a charge attached to snapshot. It is $0.095 per GB of storage. And these are the advantages. We can create new EBS volume from snapshot. We can expand the size. We can create the volume in separate availability zone or region or different AWS account as well. So overall, it helps for disaster recovery and high availability.
In this session, we are going to talk about the Amazon Autoscaling. Amazon Autoscaling is a service which allows to add new EC2 instances based on the conditions defined. Before we move on to autoscaling, we would first try to understand what are the types of the scaling possible in regular world. We would understand what is autoscaling, what are the types of autoscaling, or how do you achieve the autoscaling, and we would go a little deep down about the autoscaling too. Let's see first what are the types of autoscaling in the market. Suppose you have a M3.medium instance size and you have a EBS, that's a root volume of 40 GB size to that. Now if you want to increase the capacity because your load is increasing, one way is from M3.medium you change the size to M3.large. To change the size, you have to stop the instance and then change the size, provided this is an EBS back instance. Yes, if you want to change the size from 40 GB to 80 GB, you can also do that. You take a snapshot, you create a new volume of 80 GB, attach as a root volume. But changing the instance size or changing the volume size, in these two cases, it would require instance to be stopped temporarily and then the size would be changed. But that is possible. If you can do it in a off-peak hours or something, you can back up. It's a possible thing. In another case, you want to change size from M3.medium to M3.extra large again by stopping server. Yeah, if you don't want to remove the original size of the EBS volume, you can attach additional EBS volumes also. You can rate them and then you can make them as a one EBS volume. All these cases are case for the vertical scaling. In the vertical scaling, you add resource vertically to your current infrastructure. Whether you add memory, you add compute power, whether you add storage, all the cases are of the vertical scaling. Vertical scaling has some kind of a limitation because one limitation we just saw, it may require the instance to be brought down. In some cases, there is a threshold. Beyond that, if you keep on adding more resources, it may not improve the performance because eventually it's a single machine. A single machine has its own limitations which might not work beyond certain capacity. So when you think about M3 extra large, M3 large, in both the cases, this is how it's going to work. Let's think over the another option that is known as a horizontal scaling. The horizontal scaling case, you add more resources horizontally to your fleet. So you have one M3 medium, you add another M3 medium, you add another M3 medium. All three are managed by the elastic load balancer. So suppose you have a 10 requests coming up. Now even if you have a 300 requests coming, it would be evenly distributed among each machine with the 100 requests. So that's the horizontal scaling for you. Amazon auto scaling helps you achieve horizontal scaling. It adds more resources horizontal to your fleet, and you can also make them part of the ELB automatically, which allows you to scale horizontally. And believe me, the horizontal is the go-to thing for you, because if you want to add more and more from 5 to 10 to 15 resources, that's a possible. Plus, it does not need any downtime, and it doesn't need, or it won't have any capacity threshold like a vertical scaling. You keep on adding, it would work perfectly for you. Auto scaling helps you achieve horizontal scalability for your applications. It's a perfect case for the high availability. It can scale up and scale down EC2 capacity automatically based on the conditions defined. You can manage your desired capacity. Now, what is that? When you make an auto scaling case, it would have three kind of parameters: minimum size required, maximum size required, and desired capacity. Minimum means it would never go below those many numbers. So suppose at any moment you think I need 2 EC2 instance running. So at auto scaling level you define that I need 2 as a minimum. Now due to any conditions it would keep adding more resources because there is a load increase something. What happens if there is a DDoS attack and it keeps adding more and more resource? You don't want to do that. Or there is a known case because you know there is a virus scan going on. It's not a real increase in the load, but my CPU is behaving oddly. What you can do is you can set up the maximum limit also. You can say my maximum limit is 8. So when the load increases, it keeps adding more and more resources. So from 2 to 3 to 4 to 5, it would not go beyond 8. It would stop at 8. So this way you can control. And at any moment, how many instances you want, that is defined by the desired capacity. We would see in the demo how can you scale up, scale down, how can you define the minimum size, maximum size, and the desired capacity. But it's important to understand these are the three parameters: minimum size, maximum size, and the desired capacity. And with this, you can see you can increase or decrease capacity seamlessly. Now that's why this is the perfect case of the cost optimization. You would say, how would it optimize my cost? Imagine if you have 5 instances. Now, for these 5 instances, you might have to, you don't want the 5 instances running all the time. You say at any time keep 2 running. Whenever required, load increase, add 1, 2 instance over there. If you were in your own data center, you might have a procured capacity as per 5 instance and it would running. Here, you are running only 2 instances. As and when load increases, you add more resources. As and when load decreases, you remove the resources. And beauty of Amazon is you pay for only what you have used. So you would be paying for those 2-3 instances only when they are available or only when they are being used. That case, you would be paying for those additional 2 to 3 instances for some few hours only. That's why it's a huge cost optimization for you too. Autoscaling helps you to achieve the best of the high availability because it does keep check of the health of the instance, and even if it finds any of the instance unhealthy, it would terminate that and launch a new instance for you. You will read a little bit more about that in the future. Also, if you think, it helps you since it's a scalability. So if one zone goes down, so that instance stops behaving, it would automatically scale up because the CPU load increase, something like that, and it would help you achieve high availability and disaster recovery too. Autoscaling is ideal for hourly, daily, weekly variability. If you ever load something which is in a spike, something like this, that's not the case. The reason is by the time it spikes up, you are about to spin up a new instance. It has spiked down, it has come down, and it's about to be terminated. Then again it spiked up, it is about to be launched. So you have to find a pattern and baseline something, and then only you should be setting up the auto scaling formulas or events to come across. It works with the ELB and the CloudWatch perfectly. We'll be seeing in the demo how does it help you. And the most important, it does not cost you extra. It's a free of the cost service. So autoscaling is elastic by nature. We know it's elastic. It can add more compute power elastically, and that's why it helps you in the dynamic scaling. You want to add the resource, you want to remove the resource, it helps you for that. And that results in your cost savings because you are paying for the resources which are added only when required. So helps you for high availability. The important point is it works within a region only. So autoscaling is particular to a region. So whatever condition defined would be part of that region only. Whenever load increase, it would keep on adding. Whenever load decrease, it would keep decreasing. It works in that way. Autoscaling, how do you work with that? So there are the few steps you need to follow when you are working with autoscaling. First and foremost step is you create a launch configuration. So when you go to the autoscaling, there are two things you need to work. One is a autoscaling launch configuration, another is a autoscaling group. Now what is a launch configuration? You have to think, what is the role of a autoscaling? It launches an EC2 instance based on the condition. Now while launching an EC2 instance, what all parameters do you need? You need instance size, you need key pair, you need AMI because it would be launched from that. You need security group, you need EBS volume, and a few parameters which are required to launch an EC2 instance. While launching an EC2 instance, we have followed these steps multiple times. That is the exactly thing you define in a launch configuration. Here you identify the EC2 runtime parameters. It's a very important. The AMI ID is the most important because you want that I have a application set up with the Apache web server. Now I want to do that whenever there is a load increase, it would add a Apache server over there or new instance over there, which is the Apache server already running part of that. What you can do is you set up an EC2 instance, install Apache over there, configure that whenever the instance boots up, Apache starts automatically, and create an AMI out of that. Provide that AMI to EC2 launch configuration. So in future, whenever autoscaling launches a new instance, it would launch this also. It would also launch this instance, and where the Apache is already installed, Apache would start automatically, and you make it part of the load balance, it would start running for you as it is. It's very important you identify the runtime parameters, and that would be defined based on your AMI. That's the one key aspect. Apart from the AMI, you would be selecting more parameters like key pairs and the security group and the EBS volume size and a few more. The next step is, and here you are just identifying parameters. The next step is you create an autoscaling group. In the autoscaling group, you would be selecting or taking this launch configuration as part of this, as well as you define maximum size, minimum size, and desired capacity as part of this. You also define which all zones does this. I'm talking about zones of a region, not multiple regions. Zone of a region. Which all zone this auto scaling be part of. So what happens? As soon as you create an auto scaling group, it would launch an EC2 instance. How many instances it would launch? It would be based on the desired capacity. And if you have not specified desired capacity, then what is the minimum capacity you have specified? Based on that, it would launch EC2 instances. Those instances would be launched based on the launch configuration parameters you have selected. It would select the same AMI ID, same key pair, and everything it would take out of that. So your first step was creating a launch configuration. Second step is creating an auto scaling group. Once all this is done, you can create an auto scaling policy. In the policy, you define that whenever there is a threshold above 60%, below 60% something, or based on time, you launch a new instance. So as soon as CloudWatch detects the condition breach, it would notify auto scaling and it would execute this scaling process. When the scaling process is executed, that also be part of ELB. You have configured that. So everything works seamless for you. Launching a new instance, and even if the vendor it goes below the threshold, it would terminate the instance also. So when you think of the auto scaling process, the important steps are creating a launch configuration, creating an auto scaling group, and creating a policy for that. Auto scaling with the elastic load balancer gives you a perfect resiliency. So what happens? Suppose auto scaling has launched an EC2 instance. Now that instance is also added to the elastic load balancer. Auto scaling itself also performs the health check on the instance. Now we know ELB does perform the health check on the instance. Auto scaling also performs the health check on the instance. In this case, as soon as the instance becomes unhealthy, ELB would stop sending traffic to that instance. ELB would stop sending traffic to that instance. We know that ELB keeps check of the health of the instance. When it's unhealthy, it stops sending traffic. And if it's unhealthy, auto scaling would terminate that instance automatically. And since it's terminated, so your desired capacity has to be maintained. Auto scaling would launch a new instance as per the desired capacity. That instance would be part of the ELB again, and the whole thing starts working back to the normal. So even if due to any zone outage or any other outage Amazon level instance goes down, ELB would stop sending traffic to that. Auto scaling would terminate and launch a new instance for you. That would give you the case of the perfect resiliency. Auto scaling works in the three scenarios. Let's see what are the possible cases in this three scenario for the auto scaling. First is a based on the time. Scaling based on the time. You can create a schedule action. Suppose when you are doing your load monitoring with the CloudWatch, you feel at every day 9 a.m. the load increases and every day 5 p.m. the load decreases. What you can do is auto scaling allows you to scale based on the schedule. So you can create a schedule where based on that load it would automatically increase the capacity, based on the schedule it will decrease the capacity also. You can set up the time in Amazon Management Console. You can also set up, it's not a week, one day. You can set up that if it's a recurring, it's a one time, what do you want to set up that? And based on this desired capacity, it would be changing that. So this is scaling based on time. Where you know the pattern and you want to scale up, scale down, you can do that. Second is a dynamic scaling, where you want to scale based on the conditions. You don't know your application is working normally, but suddenly there is a huge hike on the load. Let's say at the 9 a.m. the load has increased by the 50% or 60%. At 5 p.m. the load is decreased by this something. It happens. Now, what would you do that? You would be creating a policy for scaling up and scaling down. You can say that, sorry, it's not a time waste, that's my miss. You can set up that, okay, when there is a CPU utilization. So if I say my application is working normally, my normal CPU utilization should be below 60%. Now, due to certain conditions, if the load is increases and it stays there for a longer period, you can set up a policy which would scale up automatically based on these conditions. So you can create a CloudWatch alarm which says that whenever CPU is more than 60%, notify auto scaling. Now, this auto scaling would then take up and launch a new instance as soon as it receives a notification from the CloudWatch. You can also set up a bottom threshold that whenever it's below 20%, again notify auto scaling. So whenever it goes below 20%, it would then also terminate the instance. So you can set up the scale up policy and scale down policy. In the same game, third is the manual scaling or the constantly growing scaling. When you want to follow the certain pattern, how you want to scale up or scale down, you can do that. And this is more about, you know that, okay, this is the time I want to increase the load. You don't want to wait for any conditions. You don't want to wait for any time base. You want to do it manually. This is the case for you. It's very easy. You just go to the CloudWatch. You just go to the auto scaling and change the desired capacity to your required, and it would be based on the desired capacity. It will scale up or scale down. The one of the exact example I would say, due to certain conditions, you have set up that okay, it should scale up, but you don't want to set up the scale down policy as of now. So what you've done is, when the load increase, something happens, you would be scaling up. Now after some time you think, okay, this is the time now I want to scale down. You can go and manually change the policy. Again, as long as there is a less manual intervention, that is the best policy. But in some cases you might require that. So you can think of that option too. This is a simple architecture of the how the auto scaling things would work. You would have a website, something like example.com, that is being mapped to some IP address of the load ELB, and I would say not IP, it's a DNS using Route 53 service. With this elastic load balancer would be sending the request to the instances, and there is an auto scaling configured as part of that. When auto scaling is configured part of that, and whenever there is a threshold or some breach of the conditions, it would add more resources to this auto scaling group, and that would be again part of the load balancer. So when the load increase over the example.com, automatically it would be taken care by the using elastic load balancer, auto scaling group, and CloudWatch. It can scale up, scale down based on the policy defined, and it receives the alarm from the CloudWatch. Let's try to understand a few vocabulary of the auto scaling. Auto scaling has a launch configuration. The launch configuration we spoke about, it's a first step to create your auto scaling, where you define what all runtime parameters it should use to launch an instance. This is the EC2 runtime parameters. Then it does have an auto scaling group too. Auto scaling group is nothing but a representation of a multiple EC2 instance. So it uses the launch configuration to launch an instance, but what would be the max size, minimum size, what zone it supports, that all thing you define in the auto scaling group. As soon as the group is created, it launches a new instance. You also have a policy. A policy is that you define that based on the response from the CloudWatch, what action should auto scaling take, whether it should scale up or scale down, that is defined in the policy. A trigger is nothing but the what you receive from the CloudWatch. When a CloudWatch you receive an alarm from there, it would be part of that. It is part of a CloudWatch alarm and auto scaling policy. So as soon as the alarm crosses the threshold, it notifies auto scaling. Auto scaling policy would be executing the thing. That's the whole thing is called as a trigger. And auto scaling keeps checking the health of the instance regularly It does perform the health check and keep the check of the status of the health. So as soon as it finds any instance unhealthy, it would terminate that and launches a new instance on place of that. What are the use case for the autoscaling? It's ideal for the web tiers or stateless tiers. So you should use it for the Apache, Nginx, Tomcat, JBoss, wherever you have a web server tiers, it is required for that. Can you use it for the load database? You cannot. We'll see in a moment. So ideally, when you have web servers which are facing the external web traffic, or when you have a stateless tiers which does not manage your state, that is the case for the auto scaling. We learned the three types of the scaling: manual scaling, scaling by schedule, and scaling by the policy. It's a recommended that you should have two policies, one for scaling up and one for scaling down. Let's try to see a little bit of the scaling in depth. The scaling is recommended when you have a gradual rise or the gradual low. If you have a spiky requirement, scaling is not for that. Yeah, there's a spike of the increase, scaling is that. But what I meant is spike up, down, up, down, up, down. That is not the case for the scaling. You can create up to maximum 100 launch configuration as part of the auto scaling. In some case, you want to suspend the scaling. You want to resume because you are doing something new installation. You are doing something over the instance. You know that. So you can suspend or resume the scaling also. You can have maximum 125 scheduled actions for auto scaling group. So every day it can have allowed 4 actions per day. That's a possible. Also, when auto scaling is terminate the instance, you can define in which way it should terminate. That is the oldest instance first, newest instance first, instance with the oldest launch configuration first, or instance which is closest to instance R, that is for the pricing base first. You can define that also, and we would see that also in our demo. We know that EBS back AMI boots faster than the instant store back. Ideally, word should be instant store back AMI. And even it's easily to make also. So that's a recommended to use the EBS back AMI as much as possible. Yeah, you cannot modify your existing launch configuration. So in case you have created a new AMI and you want to change the launch configuration, what you have to do is create a new launch configuration and modify the auto scaling group with this new launch configuration. You cannot update existing launch configuration. You can use spot and reserved instance also with the auto scaling. Auto scaling works across the multiple availability zones within a region only. It works seamlessly with or without ELB. In some cases, you might not need ELB because you're doing some Hadoop or batch processing. You can use the auto scaling for that purpose also. Auto scaling checks the health of the EC2 instance regularly. It does perform the health check, and during the health check, if find the status of the EC2 instance okay, then it's a good. If it also performs the health check of the ELB also, if it find the ELB health check in service, then it's a good. If it find it's not running, because what happens, an EC2 instance is registered with the ELB. Now, when it's registered, the status of the EC2 with the ELB would be in service. Due to any reason, if it's out of service, auto scaling would mark that instance unhealthy and terminate that. If an ELB is unhealthy, all instance will be also marked as unhealthy. Auto scaling does also support its own metrics for the CloudWatch. They are like what is the minimum size, maximum size, desired capacity. Yes, if you have enabled the detailed monitoring with the auto scaling for EC2 instance, that is a chart. Auto scaling should never be used with the database unless it's a read-only data. Why? Imagine a case, you have a database. Now, suppose the load rises and you say, I want to spin up new database instance. What would that result? It would result in inconsistency because some data comes to this machine, some data comes to this database. The data is not consistent. You cannot have a two instance. So, and plus auto scaling can terminate this also whenever this load decreases. So your data would be lost. Since it's a persistence tier, auto-scaling should never be used with the database. If you have a read-only database, then only you can do that. So what happens that your data is coming only for the reading part. It's not doing any insert, dealing, anything, update part over there. Then it's okay, because if you have a 3 instance, 5 instance, even if the one terminated, you don't mind because it's a read-only thing. When we go to the RDS, we will see that read-only part too. If you have a critical configuration like log, audit trail, something coming to the EC2 regularly, you should plan keep moving them to the S3 at regular interval. You should also optimize your resources after monitoring pattern. You should keep monitoring your resources regularly, and whenever you find upward downward scale, you should add or remove the resources too. So this is all about the auto scaling in the theory.
Hi, in this we are going to learn about the Amazon economics, and we will also have Amazon billing and account overview.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Till now we have learned the various Amazon services. We went the deep down of many services like EC2, EBS, CloudWatch, up to RDS, Route 53. We were covering many services in deep down. We also get a very good overview with the hands-on demo for the DynamoDB, Glacier, CloudFront, import, export, SES, all that we tried to cover here. So the purpose was, we all should be prepared and understand why this is helpful. You should understand why these services are useful and how would I use in a practical case. At the same time, when you are preparing for Amazon architecture, it's also important to know how do I optimize the cost, how do I plan for the Amazon, what budget would Amazon need, or what would be our monthly costing. How do I monitor those aspects also? So it's very important to know the other aspect of apart from knowing the Amazon services, the other and very important aspect of the Amazon. So for that part, we would be learning about the Amazon economics. After that, learning Amazon economics, we would be going to the Amazon account overview. So I'll go in there. I am on our website awsamazon.com/economics. When I'm here, you can see it gives me some overview about the economics, how Amazon can help you optimize the cost, you can save the money, how much, and you would be wondering with the numbers, are these numbers true? Would I get my return on investment in just 6 months? How would I get more? Gartner has always put the Amazon in the leader quadrant since the beginning. So even we know that in 2015 this was the leaders quadrant. How would we know how much am I going to save this? So for that part, I'm just clicking on the resources section on the left hand side. So when I click on the resources, it gives me a few calculators, and which are very nice to have the calculators. Apart from that, Amazon also gives a good white papers. One of them is how does Amazon pricing works. So you can know and read about this, that how you would be, whatever you're planning, how much Amazon would be charging you. Also, introduction to Amazon economics. These are the very nice white papers. You must follow that or read that. For now, we are going with the AWS total cost of ownership white paper. So when I select this, this is my total cost of ownership white paper, where this would be useful. So when you are just planning as an organization, you are planning to move to the cloud. You want to move things to the cloud, but you don't know how to do that. You are not sure how would I optimize my cost. You are not sure how am I going to reduce the cost, or whether Amazon is the right solution for me or not in a pricing wise. For that case, you might need to go with the AWS total cost of ownership calculator. So when you go, I'll just click on the launch the total cost of ownership calculator. This would be giving you an overview about if you're hosting something on your on-premise thing and something you are going to host on Amazon, how much you are going to save the cost. That is the concept here. So let me start with the basic. We go with the USD as a amount. Okay, so what are you trying to compare against? I say, are you going to use on-premise or are you going to use the co-location? I say I'll be using on-premise, where whole infrastructure was going to be in my data center. Now instead I'm thinking to move to the Amazon. So what is the cost comparison between that? Where are you going to host? In which region? I would say I'll start with the US East region. Were you planning to use the physical machines or were you planning to use the virtual machines? In that case, I would say I was planning to use the virtual machine because that would give me more resource optimization. But I was planning to use the virtual machines. Okay, so how many things are you going to use? I say I was needing a web servers, where I had at least 4 web servers requirement. They were all 4 CPU, 8 GB RAM. I'm just going a rough estimate. For a hypervisor, were you going to use the VMware or open source? I'm saying I would use the VMware. The costing would be different for the VMware because it would be having a license cost also. As I was requiring app servers also, where I required 4 app servers. They all had a 4 CPU but required a more memory, 16 GB RAM they were required. I'm just putting a rough numbers here. Then I needed database servers also, where I would have 2 database servers, one primary, one secondary, but they would be very high configuration. So this is my requirement. Do you need a storage? I say yeah, I need a storage, but I don't think I would be having more than 2 terabytes of storage. That's the okay for me. I'm not going to even use 1 terabyte. So just keeping 2 is a buffer part. I'm okay. And now I say run calculate total cost of ownership. It's a calculating some magic numbers for me. And what it says, over 3 years, you would say almost $200,000. That's the whopping number, $200,000 just saving. You would be great, glad. Wow. Let's see how it works. So Amazon, when giving you this estimate, it goes for the 3-year reserved instance part. So that is where you would be saving, because we know with the Amazon, even 3-year reserved instance helps you save almost 40 to 50% of the cost. You would just try to compare the things. So your on-premise server might be costing you $161,000. How this cost come, you would see in a while, because the bottom Amazon has explained everything. Well, Amazon, it would be costing much cheaper. Storage also would be very cheaper for Amazon. Your networking cost, you need to procure a network, which Amazon would not need to. So your total cost is almost this way compared. So from comparing 239 to 42,000, that's how you would be saving almost $197,000. If you go a little deep down about each and every aspect, what Amazon has compared. So when you say I was requiring a 4 VCU and a 8 GB RAM machine, Amazon recommended M4.large for that. For app server, it recommended M4.extra large, and for database it recommended M4.4x large. So these are the 3 things it has recommended to us. Then I'm going to use the storage part. So how is the storage going to help me? So in the storage, you would have a 2 terabytes of storage required. So that's what it has considered. Here it has considered CPU. How is this matches? Going little on a pie chart way. This is how the costing for the on-premise works well. For the Amazon, this is all about the your infrastructure cost. Also storage cost is how this is considered. Now how did Amazon calculate these things? So we come to the calculation part. So Amazon says in the left hand side, server hardware cost for these machines. So it would be using these machines, and this would be costing you around 6,947. So this is the unit cost it has worked out. For each unit would be costing around 10,000, and it considers that the vendor is giving you 25% discount. So this is how the cost is working out. And this cost it has got, we'll go a little below and see how this cost has come out to also 900,000. If it's for your organization, that's a different cost, you can consider that. This is the hardware maintenance cost you might be paying over the year, 3 years. You might need the racks. So what is the cost of the rack infrastructure? That is also coming. The rack is a very costly infrastructure. Virtualization software. So if you are going with the VMware, you would be paying 100,000 almost for the VMware. Your facility cost, your server cost breakdown, how it's coming out for you. Now when you compare everything, also your storage cost, total data center space, power costing and cost. So it has also counted, because you need a data center. You would be paying for the electricity. You might be paying for the cooling cost and everything, AC and everything. So that's the cost also it has counted. Considering all this, it's a much higher. Then this is the networking cost, which Amazon you don't need to pay. Yeah, in the Amazon you need to pay for the support. So that's the support cost, it is counted also. Support cost for the reserved instance also it is considered. So all these costs it is considered. Now we go for the methodology. How does this work? It says total cost of ownership uses the following methodology equal to acquisition cost plus operational cost. So how much you need to pay for the for procuring this infrastructure and how much you need to pay to keep it running over the period. So this is your cost is coming out. Server cost, storage cost, network cost, everything. Also for the on-premise or co-location, how much it is costing you. So your total cost of ownership. Then your server cost, storage, everything what you are counting, Amazon has considered that. So you should be able to refer this to what Amazon offers and what would not be available in your infrastructure, which you might need to pay additional for that. What are the assumptions Amazon has made? So here the pricing also, the server and rack pricing. So for that it has considered Dell PowerEdge prices, which is available from here. It has considered the HP ProLite rack servers pricing, which is available from here. So different kind of a rack, HP, all that pricing it is done. Considering all this, it has made the assumptions and the calculation for you. If you have any questions also, there are the few questions answered here. You love the report, you want to show to your management saying I'm going to bring 200,000 savings in 3 years, everybody would love that. That's where you can download the report also. So this is how the Amazon is one of the most effective or cost optimization way for you. Yeah, you might need to go for the reserved instance. This is a much higher level, or I would say 30,000 feet overview Amazon cost optimization technique for you. In some case, you would need to go deep down and understand how am I going to save the cost for each and every service, or how much Amazon going to charge me. So for that, in the resources, there is AWS simple monthly calculator available. If I go to the simple monthly calculator, this is the simple monthly calculator, which is a very helpful tool which would help you to calculate the various cost of Amazon over the period. I'll start with the Amazon EC2. So what I'm going to use, I would say I'm going to use web servers. How much I'm going to keep it running for all the time, 100%. What type of instance are you going to use? I'm going to use the m4.large. The m4.large cost you 12 cents per hourly, but if you go for the reserved instance, it will be effectively 0.04. So for now, we are not going with the reserved instance, we are just going with the normal case. I would say I need 4 for the app servers. Again, I would need 4, but I would need a much larger capacity now, not much larger, one larger, m4 extra large. Then I'm going to use the DB servers, 2 m4.4x large. So considering also you would need a storage, so you would say yes, storage. You would need one volume, we are just going, I'm going with the general purpose. I would need 2 terabyte almost storage. Am I going to take the snapshot? Yes, I am going to take the 2 GB of the snapshot every month, or 20 GB. So that's where over the period my storage would keep increasing. And are you going to use the Elastic IP? Would that Elastic IP be unattached? How many Elastic IP remap you are going to do? What is your inter-region? What is your intra-region? All the kind of a data transfer you are going to read or do. What is VPC peering? If you are going to use, we learn about VPC peering. How many elastic load balance are you going to use? So considering all this, when I go to estimate of your monthly bill, it comes to $3,000 per month. Here it is considered, it is going to give me the first 12 months free tier, also it is counted. So out of this 3,000, almost $2,400 cost is for the EC2. It is considered the AWS support cost also. I would go and say I don't want to count the reserved instance, sorry, free tier part. So here my monthly cost comes to almost 29-21, and again my EC2 cost comes to 2,450. I'll just write it down, 2,450. We'll need to wipe out anyway. And we have not used anything like a reserved instance as of now. Let's see if the reserved instance is going to save some cost for me. I would say for 1 year all upfront reserved instance. In all cases I am going to see. Remember, we were paying $2,450 per month. Same way, 1 year all upfront. I'll just put down the things in the notepad also for our easier reference. 2,450, no reserved instance cost. Then I go and say, here now my monthly cost has come down to $300 from 3,000. Why? Because I have already made a payment of almost $17,000 to Amazon as an all upfront cost for the reserved instance. So now then it would not be charging me anything on a pay as you go model. But what am I going to save here? If you see, now almost 17,000, 16,900. So almost 16,900. One time payment I have done. But what is it saving me? At the same time, it would be saving me almost 2,450 per month, because that's what it's not going to charge me. Let's do some math. Let me open the calculator. Almost $17,000, and 2,450 into 6.5, almost $16,000. So almost we say in 7 months I am able to recover all money. So from 7th month to 5th month or 12th month, the 5 months cost I would be saving a lot with the reserved instance. Here, because I have paid one time upfront almost 70,000 from first go, this way I am saving 5 months of cost. If I am going to keep on running 24/7, I am going to run by the 5 months of cost. If I go with the, instead of 1 year, I go with the 3 year all upfront. My monthly bit says same, but my annual payment or one time payment is now raised to the 32,854. 32,854, 3-year payment. Now what is the difference here? If I consider the monthly also, yeah, let me open my calculator. $2,450 into almost 14. Okay, so almost in 13 months only. If I was on demand, I would have been paying 2,450 fixed cost every month. So in 13 months only, I might have paid 31,800, 32,000 almost. So in 13.5 months only, my reserved instance payment would have been recovered. 3 years. In 1 year per reserved instance, it was in a 7 months, here in a 13.5 months. If you see another important thing, if you are going for a yearly reserved instance, you pay 16,900. So if you are going year by year renewal, that means you are paying almost 33,000 or almost 34,000 in 2 years period. While if you go ahead and pay for 3 years upfront, you are saving almost whole year even on the reserved instance 1 year payment. So this way, reserved instance helps you save a tremendous amount of cost. Yeah, it's required. You need to understand that when I'm going to use the reserved instance, it's going to cost me in a way, because even if you don't run the instance, it would keep on costing you 24/7 for 365. So if you're sure you're going to run your environment 24/7 365, you must go with this reserved instance option, which would help you save a lot of amount of money. We would see different services also now. You can clear the form from this part. We will now check some other services also. So if I click on Amazon S3, this is how you can help or you can calculate the cost of Amazon S3 storage. For example, you are going to store 500 GB on Amazon. How much would it cost you? What would be the how many requests you are making? How many get and other requests you are going to make? So for each and every, are you going to use the infrequent access storage object? Are you going to use the RRS? Or what is the data transfer you are going to make? Each and every service would be costing you. Data transfer in does not cost you. Data transfer out only cost you. But Amazon says it's good to put the number so you are aware about then how much it would be costing you. Also, we can clear out this form also. So we know that for the S3 it would be costing around $15. I can clear out. I can go for Route 53, CloudFront, RDS, DynamoDB, whichever service is offered by Amazon. All services are mentioned here. Also, if you are going to procure the Amazon support plan, the Amazon support plan cost is also mentioned here. Now, Amazon also gives some ready to use examples. Like if I want to use the disaster recovery backup or large web application all on demand, where this is an example created by Amazon, which looks like this, where it would be a 3-tier application, web tier, app tier, and the database. It uses DynamoDB for session management, Amazon RDS with the read replica or the standby, multi-AZ, Amazon S3, CloudFront, all it's using. I'll say go and give me the details. Here the monthly cost is coming almost $1,000. So in the $1,000, when you go to the EC2, it says it's using two web servers, but all small. It is using the 300 GB of storage and 10% of the storage as a snapshot. It's using Elastic IP also, an Elastic load balancer. Same way it might be using the various other service, so it would be using the Amazon S3 also, so the cost of the S3 also mentioned. Then cost of the Route 53, what it is using, CloudFront service, RDS service, all the services cost mentioned here. So you select the RDS, it uses the one MySQL database, multi-AZ of 5 GB, M1.large. So how much it would be costing you? So that's your RDS cost of $337. One thing it's very important for us to understand also, whenever we are selecting, remember to select the region also, where you are going to host. Because if you change the region, the pricing would different also. So from US East to US West, the pricing US West is almost similar. But here, when I go for Asia Pacific, if I'm going to host something here, the pricing would be different for me. So you have to think for which region you are hosting and select the accordingly. One good thing also Amazon gives is you can save this. So you can say save and share. So when you say save and share, it would create, you can put down the numbers, details, all that. And you can say, when you say okay, it would generate a URL for you. A static website hosted Amazon S3 URL for you. This URL would be very helpful for you. because now this URL would allow you to share with any of your peers, colleagues or managers, and they can directly come and view this here. Let me see if I copied correctly and I can put the paste here. Oops, no, I should try again. This is how, when I paste it, it would bring down the same thing for me. So you can use it for copy and share also. So this is all about the Amazon simple monthly calculator, a very powerful tool and very helpful tool also when you estimate your monthly budget, yearly budget, what service you should use, reserved instance or on demand or what, how much difference would it make for me, everything it would come handy for you. After looking at the Amazon economics aspect, it is also important for us to understand the Amazon, how does this real billing things works and how do you manage that. In the CloudWatch session, we learn about that we can always create a unique, or rather we can create a billing alarms, which we did that. We would be going here. So when I am here, under my name, I would be clicking my account. And there is a billing and cost management. Two aspects are there. I would be just starting with the my account. So this is my account settings. So this is my 12-digit account ID. I can change the password. Then this is my billing. If I want to define anyone else also for the billing contact, so if there is some issue or there is any escalation, it would be mailing to this person. What are the operations? What are the configure security challenge questions? So I am user access to billing information, account contract information, any communication preference, your cancel service, all this would be, if you want to cancel out your service completely, you can do that. If you want to close your account, you can do that here. So this would stop charging you anything. You could come to the dashboard. This would give you your monthly spending. So last month there was 82 cents. This month it might be costing me around 79 cents. This is just an anticipation from Amazon. Now, if I want to see my bills, I can go to the bill section where it would be giving me detailed report. So I can click on the March, and this is the March consumption report where it says $82. Out of that, my major cost was Elastic Compute Cloud. Though I was using free usage tier, it charged me for the net gateways. So net gateway cost me. It charged me for the database. Then in the Elastic Compute Cloud also, I had demanded a medium instance for the OpenStack and all that, Opsworks. It did that. So that's also one cost. Then Elastic Block Storage, whatever the cost was there. So this is my Elastic snapshot cost. Snapshot would be chargeable. These are the cost of the snapshot for you. Elastic IP address, time where my IP was not released, almost for 82 hours, it also costed me. So all this cost is counted out, and then it cost me almost. So this is my Route 53 cost. I did some Route 53 for a while. Simple email we tried, so that's also cost for that. So considering all this, this is my total cost, almost 54 Indian rupees coming to this. I can view various reports also. So Amazon gives you an option to create a reports based on the usage part. You can go and create reports. I can also do the cost allocation. So if you have created a various tags, like you have created a tag for the production, or if I say VPC, there was based on the name. So based on name, we were giving a various name. So you can generate what are the tags you generated, and then based on that, you can create the various reports also. Then what are the payment methods? Your credit card information would be stored here. Then there would be a payment history. How much payment you have done till now. There is a consolidated billing account. That's an important. If you have a multiple AWS accounts, you should instead of paying from the one account, you can use the consolidated billing account. So in that case, what would happen? You have a master pay account, and you have three different verticals within your organizations. You can say it's a production, development, and test. And this is the another account for your HR or admin or somebody or IS team. It is using that. Now, since you have 4 accounts, you might be getting 4 bills. You would be paying for the 4 different person for this. How would you manage it? Here for you, you can configure a master pay account and link all this account with this master pay. So you have to send sign up consolidated billing, and you have to send all 3 accounts request for this. Once they accept the request, henceforth all the charges for this account would be billed to this account. So this becomes a master pay account. It's just a payment facility. So instead of 4 bills and 4 separate payment methods, only one account is paying for you. So that's how you would be setting up the consolidated billing also. You would have your own preference, and this is where we set up the billing alerts part. So we can set up the billing alerts. If you want to get the billing alarms, you want to receive that, you can do that also. If you want to receive the emails of the invoice by mail, you should mark that. So this time every month it would be sending you over the email. You want to get the credits. If your Amazon has given you any credits and you want to use that, you can add those credits here. How does the text settings work? So if you are having any PAN number and you have done any settings, you can do that also. So this is how your overall dashboard. And it's a very important. You should go to this your console, keep checking your bill regular interval every 3-4 days, and without fail, you should have set up the billing alerts. This is a very, very important aspect. You should not forget that. We can see that apart from that, there is a security credentials also. We checked that before also. I'm just giving a very quick overview. So in the security credentials, you can modify your passwords from this place, your account. If you want to enable your multi-factor authentication for your organization, for your root account, you can do that. Access key and secret access key, these are helpful when you have a access key and secret access key available when you want to access Amazon services like EC2, EBS, RDS, VPC, anything over the web APIs or SDKs or command line tools. This would be helpful for you. CloudFront key pass are also very helpful for you. So CloudFront key pass would be when you want to secure the access, you want to create a unique URL, you would be able to use that. X509 certificates are helpful when you want to make a SOAP protocols over the web service. When you want to use the REST calls, you might use access key, secret access key. For SOAP protocols, you might use the X509 certificates. For the account ID, this is my account ID, and this is a canonical user ID which is useful for the Amazon S3. For when you want to configure the AWS access control list, you can give this canonical user ID also. So this is how the security things will work for us. So this is all about our Amazon account overview. AWS Glacier. Here we would have an introduction of the Glacier. We would understand what are the key terminology of the Glacier, and we would see a demo. Now before we begin, what is a requirement for the archival? Suppose you are having a very large data set, but that is very infrequently used. If I give you, you are having a banking data, right, where you need to keep the transactions of your own bank transactions for at least 6 to 7 years as per IT laws, but you are not referring them day-to-day basis. You might need to store them. Now suppose this is a company and where there are the huge data covered like that, which might be in a gigabytes of the size. You need to maintain that. Or you think of there is a factory where there is a manufacturing going on, where there would be lots of data available about the manufacturing units, the procurements, the POs, invoices and everything. You again need to maintain those data. Now the common factor in all this part is this data is hardly used. Like in the banking data, only when there is an audit requirement you would be able to use, or in the invoice or some other where there is a query you would be able to use. Otherwise you don't use it, but you still need to maintain them. So you need data to be stored only considering there might be a future need. There might be. And another point is, you don't want the data to be available immediately. You don't want the case that, okay, I need data now, give me in a moment. You are okay that most of the cases, even if you get in 1 or 2 hours or 3 hours, you are okay with that. This is the perfect case of archival. These are the cases where you would be using the archival services. Amazon Glacier is an extremely low cost storage service used for the data backup and archival. It's a AWS managed. It's a scalable archival service. So your advantage is you don't have to do any capacity planning. You don't have to do any hardware provisioning, any kind of a data replication, hardware failure and detection, repair, automatic. So maintenance of that. Everything is being taken care by Amazon Glacier. You just have to put the data, it would be archived and managed on behalf of you. Imagine you have a terabytes of the data and you need to maintain that. How would you do that? Amazon Glacier would come very handy for you. Glacier, when we try to compare with the Amazon S3, if I am trying to store a 500 GB of the storage, Amazon S3 would cost me around $15. At the same time, Glacier would cost me $3.5. Now when you compare these two, this is almost less than 10% cost, or almost I would say 20% or 25% of the cost of this, less than 1/4 cost. So that is the advantage of the Glacier. But Glacier is not a replacement to Amazon S3. They both have a practical difference. The cost wise, S3 is cheaper, Glacier is the cheapest. They do charge you for the put, copy and different services. Even object size, S3 supports maximum 5 terabytes, Glacier supports maximum 40 terabytes. Here, the difference you lie is access. When you go to S3 and you try to access, data is available immediately. With Glacier, it takes 3 to 5 hours minimum to make the data available to you. In S3, data is stored in a unique bucket. The bucket has to be unique across the globe. While here archive is available in a vault. We call it an object there, here we call it an archive. So the purpose is, this is useful when you have a frequently accessed objects. We learn about the static content storage. When you have static files, you want to store that, S3 is the perfect solution for you. Glacier is for archival only. When you don't need the objects to be available immediately, you request and it would take 3 to 5 hours to make that object available to you. But that's why you save the humongous amount of cost with that. Let's try to understand the concept more. Glacier has two concepts, vault and the archive. A vault is nothing but a container for storing the archives. While when you create a vault, you would be specifying a name. You select an Amazon region for this vault. So vault would have a unique URL, something like HTTPS. Everything would always be HTTPS. Then glacier.something, that is the which region it belongs to. Your account ID, this is your AWS account ID. Then vaults and then the name of your vault. This is how a vault would be created. Difference between vault and object bucket is, bucket name has to be unique across the globe because it was accessible over internet. Vault does not need that restriction because vault is not accessible over internet. So that's why it would always have account ID part of that. So it has to be unique for your account only, not across the globe. Otherwise you can think vault is like your bucket only because it's a container for storing the archives. Same way your archive is also like a file or object. What you want to archive, what you want to store the data. It can be any doc file, PDF, image, photo, video, whatever you have. You want to do that. Each archive has a unique ID. This would be archive for ID. So this would be your vault name, and after vault there would be an archive ID. A huge long around 64 digit plus ID offered by Amazon Glacier. These archives ID are always unique. So if I upload one archive, it would be assigned a unique ID. I uploaded second archive, it would be assigned a new ID over there. So each archive would have its own ID. And you can always store an unlimited number of archives in a vault. In this session, we are going to talk about the Amazon Elastic Compute Cloud, or popularly known as the AWS EC2. That's one of the core Amazon service for providing infrastructure as a service model. In this session, we would first try to understand what is EC2, what is an AMI, and what are the various types of AMI. We would also try to understand the pricing model of the EC2, some of the key terminology of the security groups, key pairs, elastic IPs of the EC2. All about this in this session. What is Amazon EC2? Amazon Elastic Compute Cloud gives you a virtual machine in the cloud. These machines are also known as a server instance. They are launched in Amazon's data centers using APIs or available tools and utilities. Now, you are allowed to use these servers at any time for as long as you need, but only for the legal purpose. Now, why is this so important, legal purpose word here? Reason is, the instances are available in various sizes, starting from 1 GB RAM to up to 244 GB RAM machines are available. Various sizes of CPU configurations are available, and that makes it very attractive for the hackers also. Something which is available on demand, something which is scalable, it can be easily used for some kind of a hacking purpose. And that's why Amazon says, if you are using it for the legal purpose, I'm fine. If I get some complaints, I get something that you are doing something mischievous or notorious activity from this machine, I may stop your access. And advantage is, this gives you an instance that you can use to meet specific needs. Here the advantage is, for various kind of a tenants, whether you are working as an organization or an individual user, you can define your requirements, and based on that you would get the server. Now you can define your requirement means you go and say I need 3 GB RAM. No, that's not the case. Amazon has a preset sizes, 600 MB, 1 GB, 2 GB, 4 GB, 8 GB kind of a sizes available. You select from that, and Amazon would provide from the infrastructure. The most important part, this is a pay-as-you-go model. Whatever you are using, you are going to pay only for that part, for nothing, anything extra. So this would also help you to save a lots of cost in compared to your data centers. If you remember, in the AWS overview, we talk about that when your need arises, you want to achieve the scalable aspect, you have to procure a new infrastructure. But if you were in a cloud, it can give you on-demand scalable infrastructure which you use as long as you want, and if you don't want, you would be able to dispose that, and with the pay-as-you-go model you would be able to save the money. Now think, what are those aspects over I'm talking about? Available on demand, whenever you need available, elastic or scalable by nature, resource pooling, pay-as-you-go model, accessible over internet. This is the perfect offering of IaaS, the infrastructure as a service model by Amazon EC2. It gives you the required resources. EC2 is real elastic by nature. It's very flexible and secure. Flexible means it comes in various sizes, various pricing models. It gives you options to work with. It's a highly reliable services. I'll tell you, I'm running a few of my instances since years, and I have no option or no downtime at all over the period of time. Yeah, you have to take care of the certain aspects for the scalability and all that, but it's a wonderful thing. And security, we spoke about, it's all about the shared responsibility. I have ensured the security of my resources. It's working perfectly fine for me. And that's why it's a ready to use AMI is also available here. It's a very cheaper, very cost effective to be used. So with all this, Amazon EC2 makes a very likely choice for a hosting service in the cloud. Now what are some key terminology you would like to understand for the Amazon? For the EC2 perspective, if you think about what is an AMI, AMI stands for Amazon Machine Image. Amazon Machine Image is more like if you have to use the ghost image, if you are in a or ISO image. This is the exactly kind of a scenario. It could be a little odd analogy to give, but that is the case. What happens in an ISO image or ghost image? When you run this, it would create an environment including OS, registry, the required software as it is. So it makes a very life faster or easier for you to replicate the environment. Similar case is with the Amazon machine image. It's a pre-configured bundle software. I repeat, pre-configured bundle software, which when executed or launched would result in a virtual server. Now you would think, what do I mean by the virtual server or here? See, the case would be you would have an AMI. That AMI, think of it's a LAMP AMI. Now if you know what is LAMP, Linux, Apache, MySQL and PHP. When you have an LAMP AMI, you select that AMI and say launch. It results in a virtual server in the cloud, an EC2 instance. That server would have an operating system as a Linux. It would have an Apache installed as part of that. It would also have the MySQL database installed as part of that, and PHP engine also installed part of that. Advantage is you don't, after launching an instance, you don't need to go and configure each and everything again. It's readily available for you and within a few minutes. Now suppose you made certain changes here. You added certain configuration files, you added your source code, you might have added certain data to MySQL. What about this? If you want to replicate similar environment, you can create a new AMI out of this. We call it AMI2. When you have an AMI2 available, what you can do is, in future when you launch a new instance from AMI2, it would have this Linux, Apache, MySQL, PHP. In addition, it would have that your data, it would have that your source files, it would also have that configuration files. Everything would be part of that new virtual machine or instance. So AMI helps you to replicate environment. By just selecting an AMI, you launch it, it would be giving you the whatever the pre-configured software part of that bundle image would be available in that virtual machine. Now generally this server you get might have an temporary storage. If you want to get all the data persistence, because if you are using file systems, you are using the database, you need the persistent systems. Amazon Volumes or EBS volume helps you for this. EBS we are going to touch upon in the upcoming sessions, but EBS stands for Elastic Block Storage, that helps you to achieve a persistent storage. Each volume would also have, if you want to replicate more volumes like that, you want to take a backup of this, you can take a snapshot out of that. So that's the snapshot concept. From this snapshot, whenever a snapshot is taken, that volume would always be stored in Amazon storage known as Amazon S3, Amazon Simple Service Storage. If you make an AMI, AMI is always stored in the S3. The data of the AMI would be stored in the S3. Now you would say, can I see the data of the S3 or data of the AMI, whatever is configured? What happens? Whenever you create an AMI or you take a snapshot, Amazon would compress the data and store in its own format inside S3. So in the snapshot corner you can see what is the snapshot you have. You might not be able to view the exact data, but with the single click of a button you can create a new volumes, or in the same way if you have an AMI, with a few clicks of the button you can launch a new virtual server for you. So it's a very important for us to understand that what is an AMI, Amazon machine image. It's a pre-configured bundle software instance or virtual machine. That's the virtual server available in the cloud. Each AMI, when you talk about the Amazon EC2, an AMI would have two types of the AMIs basically. That is based on the root device available with that. First one is EBS backed AMI. In the EBS backed AMI, the default root device is an Amazon EBS volume. We spoke about the EBS volume in the previous slide. What happens? The EBS volume is a persistent storage. It's a plug-and-play device like. Now, when an instance is launched with the EBS-backed AMI, a default root device of EBS volume would be created and attached as a root device to this. Advantage is this root device would persist. So any changes in this file system or storage would also survive the instance failures. So even if your instance goes down, it's a crashes, don't worry, your volume might not be deleted and your file system can be completely recovered. Yes, there is an additional charge, that's of the Amazon EBS volume. But frankly, when you compare the cost of the EC2 running instance and when you think of the persistence it achieves, that's a very negligible cost. But just to make you aware that there is a little cost attached with that. At the same time, there is a second type of AMI which is now not very popularly used, but Amazon originally started EC2 offering with instance storeback AMIs. In the instance storeback AMI, when an instance is launched from this type of AMI, it will always have an ephemeral storage. Ephemeral means temporary. This ephemeral means temporary storage. Now this temporary storage happens what? That as soon as your instance terminates, all the data of the storage would be lost also. It would be immediately deleted. So there is no persistent attached with that. Yeah, in case you want to make something persistent, what you have to do is you have to create an additional EBS volume and attach to the running instance. So you get one advantage here. That advantage is you can control which file to persist. It would also help you save little bit of cost because the root device is ephemeral and root device is not EBS, so little bit of cost saving also. But that comes with the cost, as I said. As soon as the instance terminated, all data is lost, and that's not the recommended option. So unless you have a specific need where you need to use the temporary storage, ideally you should be using EBS back AMIs only. Even newer versions on a newer generation of instance are coming with the EBS back AMIs only. But still, it's important to note that there are second type of AMI also available with the Amazon. Let's see what other advantage or disadvantage you get with this kind of AMIs. If it's a instance storeback AMI, it would have only two states. When you launch an instance, initial instance would be in a pending state. Then once it's configured, it would be coming to the running state, and when you don't want to use it, you terminate that. Now as long as the instance is running, it would be costing you for hourly cost. In compare, when I go to EBS back instance, when the instance is launched, it would be initially in a pending state. Then it would come to the running state. If you're not using, it would be coming to the terminated state. But the advantage is there is a one more stage here that is called the stop stage. In the stop stage is more like a hibernate kind of a case where it completely stops the instance. It helps you from the savings of the running cost, and whenever you want it back, you can start it back. When you start, it would again come to the running state. You can use it as it is, and when you don't want, you can stop it also. Only challenge here is this thing is available with the EBS back instance, and that EBS volume would keep on costing every time, whether instance is running or not running. EBS volume would cost you. But remember, I mentioned it's still a negligible cost. Why? For example, roughly an instance costs you between 2 cents to $1.50 something hourly basis. If we say take a average, an instance is charging you 10 cents per hour, 0.10 cents. It's in a dollar charging, so it would be charging you that way. Suppose if you are in a instance storeback AMI, when you launch an instance, it would keep on running for 24 hours. So your cost would be coming around $2.4 per day, and over the month it would be coming total cost of the $72. When you are in the EBS back instance, the cost would be same. The running cost always remains same. Yeah, there would be an additional cost of the EBS. So suppose you take the EBS volume and it cost you 10 cents per GB. So you created a 100 GB, which is not you are going to use, but still if you have created 100 GB volume, it would be costing you $10 extra per month. Now imagine in this case your total cost of EC2, if it's a EBS back, would be 72 plus 10, so $82 it would be costing you. You get multiple advantages which we see in the next slide, but just imagine a case. You need this AMI only between 9 AM to 5 PM. That's an 8 hours a day. If I am using EBS back instance, I run only 8 hours a day. So over the period of time, over 30 days, I would be paying total cost, because I'm going to pay only 1/3 cost now, as I'm going to stop it when I'm not using. My monthly cost would come down to 24 and $10 fixed cost of the storage. So total cost would come down to $74. Sorry, $34. Can you see the huge saving here? If you stop, advantage is you can immediately come back to the running state when you require within a minute, and it would help you save lots of cost here. Apart from that, when you say EBS, we see it can be started and stopped. The data would always persist with the EBS. It can have up to boots within a minute. That's the one more advantage. When you are talking about the scalability, this is more important because you want to scale up as you want as early as possible. The size limit also, it's up to 16 terabytes persistent storage it can provide. And one of the biggest advantages, if you want to make an AMI out of an instance, EBS back AMI gives you one-click option. With just a right click you can make an AMI, while in instance store back AMI it takes a lots of steps of 5 to 10 minutes to create just an AMI. Overall, this is very useful. Even the performance wise also this is very useful. So Amazon recommends going forward, unless you have a specific case, you should go with the Amazon EBS back AMI only. Yeah, some people fondly call instant store back AMI as a S3 back AMI also, but the right terminology to use is instant store back AMI only. Now you want to launch an EC2 instance. So what are the parameters you need to take care of? In the hands-on demo we would be doing this, but just to make you aware, when you are going to launch an instance, you have to understand what is the parameter you are going to use, which region you are going to select, which is the operating system you are going to use, which is the software you are going to use. Are you going to use the EBS back instance or instance store back AMI? Which AMI are you going to use? So making an AMI, these are the criteria you need to select. Then when you launch an instance, you might need to select the 32-bit or 64-bit OS you are going to see. What is the size of the instance? Instance has a multiple size, which we are going to see in upcoming slides. Also, you need to check what kind of a IO performance you need, and that also makes a decision in selecting size for your instance. Let's see the different instance types. I am in the website awsamazon.com/EC2, and then here when I open, I click on the instance types or instances, it would show me the various instance types. What Amazon has done is, Amazon has distributed the instance into various families based on your usage. The first family is known as a general purpose family. This is where you want to get the balance between the CPUs and the memory. Each instance would have a separate CPU and memory comparing the other instance type. So if you see T2 family, T2 is a T2 nano, micro, small, medium, large, different kind of a instance size available. Each would have a different kind of a CPUs and different kind of a memory available here. That's the RAM. This family is only EBS back AMI only. They work with the EBS back AMIs only. This family works. This is for the balance between the CPU and memory when you want to use that. And all the details pertaining to that family, what is this features about this, is available on this site also. Second is M4 instance. Again, it's a general purpose family only, where M4 is the newer generation or latest generation, which is more for the performance. The storage when it gets is a SSD based storage only. It gives you dedicated throughput, and again based on which large, extra large, double extra large, 10x large, you can get up to 160 GB RAM. The one generation previous, that is the M3 family, had also mix of the CPUs and memory. And you can see there are various use cases also listed down for M3 and M4 family, which you can select, and based on your requirement you can use that. Now suppose you have a requirement where you want the higher compute power, you want to run something batch process, you want to run some analytics, you need more compute power. So this is the family available for you. C4.large, C4.extra large, double extra large, different kind of a family available for. In the C4.extra large, when you see, you would have a compute to memory ratio little higher. So you would get more compute power comparing the memory you are getting. Same way, you have a C4 family, C3 family, and various kind of family. And I tell you, based on each family or each instance type you are selecting, Amazon charges you separately. Second is memory optimized instance. In the memory optimized, you get more memory compared to CPUs. You need for the caching or other purpose where you require a lots of memory part. So you can see you get up to 244 GB RAM machine with 32 CPU. And you know, again, this is an advantageous for you. This is pay as you go model, very faster for you. What you want to do? Within a few minutes you get 244 GB RAM with CPUs. What do you want more? Do you need graphical process unit computes? Amazon does offer that with the GPU units. Also it has that available, which is having high performance NVIDIA GPUs. This is more for the 3D application streaming, machine learning when you want to use that. In some cases where you have a high storage requirements, you need the very dedicated IO and all that. That's also available with the storage optimized instance. So it has a high IO instance, dense storage instance. When you see all this, you would get the complete summary of each and every instance. Along with that, what kind of a network performance they give you, what is the physical processor they are having, what is the clock speed available here. So you can get the summary of each and every instance type, the families, what is the performance in the from this page.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Now, if you have observed, everywhere there was a word used was a virtual CPUs. This is around a couple of, or rather year or a year and a half back, or something like mid of the 2014, Amazon has started believing this is more like a vCPU. Virtual CPU is made popular, or terminology made popular by the VMware. This is based on the VM's operating system. Before that, all Amazon families were coming in the Elastic Compute units. Now the challenge was with that unit was Amazon keeps adding new and new infrastructure. So suppose they procured some infrastructure in 2007 and now in 2010 they might have procured some other infrastructure. They both would be offering you M3 large instance. Now the clock speed, CPU capacity of both the instance would be different. In that case, this is an advantage. In this case, there is an advantage for you that when there is a difference in this, if you get an instance from the newer generation firmware or hardware, your instance might be performing little better comparing the same M3 large instance which was given from the older generation of the hardware. And to overcome that, Amazon has now made it a standard that this is the what CPU unit I measure, and based on that you would be getting the output. Let's understand a key terminology of the Amazon. Let's understand a few key terminology of the Amazon. What are the important things when you want to learn about when you are talking about the Amazon EC2? First and foremost is Amazon key pair. They are a public and private key pair given by Amazon. They are also known as a PEM files. That's a Privacy Enhanced Mail Security Certificate.
In that case, what would happen? When you see PM file, when you are launching an EC2 instance, you would get a public and private key. So you go to EC2 console, which we will show in the demo. You create a key. Amazon would give you option to download the private key. You have to download and save that key. Once that key is saved, you have to ensure that it would stay with you always. And when it would stay with you always, because Amazon does not store that private key on behalf of you. It just stores the public key. Now, where do you use this key? Whenever you are launching an instance, whether you are launching a Windows instance or a Linux instance, you have to attach this key with the instance. Advantage is you can SSH or RDP to that instance using this key. This key would be helpful. A private key which belongs to you would be helpful to connect to your instance remotely. So it's very important that when you create this key, you download the private key and store it at a secure place. A security group we spoke about briefly yesterday is a virtual firewall offered by Amazon. Whenever you are launching an EC2 instance, you can attach a security group to that instance. You can attach one or more security group to same instance. Each security group would have its own rules. And if one instance is having a multiple rules, it would be supporting the bigger of that. So if one security group does not allow port 80, but another security group allows port 80, eventually it would allow port 80 because one of the groups says allow this. If you make any change to the group, immediately that would be applied to the instance. You can control your inbound and outbound traffic. So this is what the security group would look like for you. You go and create, and you can select which inbound rule you are configuring, whether you are allowing 80, 22, what are the allowing that. And the source would be from which source do you allow. And it's a very important. You can specify your own IP address. That's your home machine, your laptop, or your office machine from where you are accessing. That IP address you can mention. That's the source IP you can mention. Or you can, if you don't want to mention that, then you provide a complete range. That means 0.0.0.0/0. That means everybody is allowed here. Anybody can connect to this machine on port 80. When we are launching an instance, this is the normal life cycle it would go through. First, you select an AMI and then you say launch. Initially, it would always be in a pending state. From the pending state, it would then come to the running state. Sometimes, due to any reason, you might need to reboot that also. It may reboot also. When you don't want to do this, you terminate. It would be shutting down and then it would be terminated. Yeah, if you want to stop, it's an EBS back AMI. You can stop the instance also, and you can restart again as and when required. Now each EC2 instance would have different kind of a IP addressing. Every EC2 instance would be assigned a different kind of an IP addressing. They would have a private IP and public IP both. Generally, I would say 90% cases, whenever an EC2 instance is launched, if you launch normally, it would have a private and public both kind of an IP address. And those IP address would also have a mapping DNS name also. Now, why do you need a private and public both kind of IP address? You need private IP address because if one instance wants to talk to another instance in the same zone or same region, they can talk over the private IP. The public IP is required when you want to talk to instance from the internet, so from your home office, or if one instance wants to talk to another instance in the separate region. Remember the word region, because regions are the separate entities, so they would be completely different geography location. So one instance can talk to another instance in the separate region over the public IP. Along with that, Amazon also offers a concept called Elastic IP address. This Elastic IP address is nothing but a static IP available to your account. The reason is you need a fixed IP address for your EC2 instance. So whenever an instance is available, you want to connect to that, you want to attach connect with a fixed IP address, you can do with that Elastic IP address. By default, Amazon gives 5 IPs or 5 Elastic IPs per region. So Amazon is having 10 regions, you can get up to 11 regions, you can get up to 55 IPs. But that's not limited. In case in the one region only you want more than 5 IPs, you can request Amazon, they would increase your limit. So Elastic IP advantage is it belongs to your account and it doesn't belong to any instance. So even if an instance terminates, you can remap this Elastic IP to another instance. Yeah, it does cost you, and that's a very important for you to understand, because when you are going to do the hands-on, this might be costing you, and there are root cause of a little charge because of IP addressing. Because if you have procured an IP, Elastic IP, and you are not using it, you have not attached to any running instance, that would cost you. Elastic IP helps you to achieve the high availability. So for example, an instance 1 is having a Elastic IP of 1.2.3.4. That's accessible from the internet, right? Now due to any reason, instance 1 fails. What you do is, you launch a new instance and assign the same 1.2.3.4 to instance 2. That second instance is also now accessible via the same IP address. So you just remap the Elastic IP, so your application will work as it is. You don't need to go and inform everyone that my IP has changed now. So Elastic IP or static IP helps you to achieve the high availability scenarios. Now let's understand the pricing of the EC2. Amazon offers the 3 kinds of pricing models. First model is a pay-as-you-go model. In the pay-as-you-go model, you pay only for the resources you are using, and that would be charging you separately. So if I go to same AWS amazon.com/ec2/pricing, you would see there is a free tier concept which I'll come in a later part. But we are talking about the on-demand instances, and on-demand Linux would cost you separately. So that's a 0.0065. That's almost half, a little more than half a cent per hour. If you go for the micro instance, you would be charged at a 0.01, almost 1 cent or 1.5 cent kind of a case. Same way small would be charged like this. So based on your size, it would be charging you on hourly basis. This is on-demand instance. Also, it's very important to understand that based on OS, Amazon charges you differently. So Linux, which is available free of the cost, there is no licensing cost of the operating system, it costs you like this. If you go to Red Hat Linux, same thing would cost you a little bit more. So something which was 0.063 or 0.0 something, yeah, we'll go with the micro. So micro in the Linux was costing you 0.01. Here it's a costing 0.07 because that's the cost of the Red Hat Linux license. So some license cost is part of this. Advantage is, again, this license is available on a pay-as-you-go model. So if you are going to use only for 20 hours, you would be paying for this 20 hours license only. Same way if you are going with the Windows, or Windows with the SQL Server, or Windows with the SQL Web Server, Web Edition, or Windows with the SQL Enterprise Edition, based on that it would be charging you differently, because that includes the cost of the OS and the SQL also. Also, each region would charge you differently. Suppose I am here and this is the cost of 0.065. If I go to the Ireland region, same thing changes little bit. In the Ireland region it would be costing me a little bit more. So based on each region the pricing also changes. Advantage is you have no operational expense, only capital expense here. Now we go with the reserved instance pricing model. Reserved instance is an option which helps you to save cost up to 75%. With Amazon, if you go here, what Amazon says, you show me the commitment and I give you the discount. So what you have to do is, if you are sure you are going to run any instance for at least 1 year, you should go and procure a reserved instance. Why I say 1 year term is, if you procure it, Amazon would immediately start giving you discount between 30% to 75%. But yes, this is for the commitment. So whether you use the instance or you don't use the instance, even if you stop the instance or you terminate the instance, Amazon would keep charging you. So Amazon says, I would give you huge discount provided you keep on using it for 1 year. If you do a simple math, anything or any instance which you are going to run more than 6 to 7 months is eventually going to save you money. Is eventually going to help you to save the money. In reserved instance, there are 3 types of payment types. All upfront, which means you pay everything from the beginning, then there will be no monthly cost. In partial upfront, you pay 50% or some amount from the beginning, and then it would charge you very minimal amount every month. In no upfront, you don't pay at all, but it keeps you costing fixed amount at every month. And for all these options, it will charge you even if you are not using the reserved instance. So when you are going to procure a reserved instance, you have to select which instance size you are going to use, what is the region you are going to use, what is your payment terms, what are the payment options you are going to use, all, partial, upfront. The payment terms means whether you are going procuring for 1 year or 3 years. If you go for 3 years, you get much larger discounts also. Advantage of the reserved instance is it's a very cheaper, it's a flexible, so you can select for the various models you want to use it. It's a very reliable also, because it ensures that you reserve the capacity. It's a very easy to use also, the user can get it. It's a scalable. There is also some marketplace available in the Amazon for this. So if you want to trade in, you want to buy, you want to sell, you can do that with the marketplace. Means you have procured a reserved instance and you are not going to use it, you can sell it off, though there are certain Amazon restrictions based on that. Or you can also procure a reserved instance from the marketplace. Third option of the pricing after on-demand and reserved is a spot instance. This is a very curious and important case to know. Amazon says, I have a humongous unutilized capacity. So I can give you this capacity at a very cheaper nominal rate. So if you say my on-demand instance cost me 20 cents an hour, I can give you same instance at 2 cents an hour. 2 cents, I'm talking about 2 cents. How? You have to bid for this. This is more like an auction. You go and say, I'm going to bid this instance at 15 cents per hour. Though it's costing me 20, I'm bidding for 15 cents. Amazon says, great, you bid for 15 cents. But you know what? My current market rate is only 5 cents an hour. I'll give you at 5 cents. I'll keep you giving for 5 cents as long as the market rate does not cross the 15. It means what would happen here? Suppose you bid for the 15 cents per hour rate. The current market rate keeps varying. That's the Amazon based on the demand and supply, it would keep varying. So this is the 2 cents, this is 5 cents, and this is 15 cents. Just an example. Now, as long as this is within the limit, it would keep giving you. If due to any reason this market rate increase beyond your bid rate, you bid it for the 15 cents, Amazon would terminate the instance immediately without notifying you. Yeah, it may notify you, but without giving any warning, it would terminate the instance. So this is not the great use case for the production, though it can be leveraged in the production in a different way. But when you want to run something temporary, like you want to run a batch process for an hour or two, which requires a humongous, like a GPU kind of resources, why don't you go for the spot? You bid for that and you would be able to get the capacity in a much cheaper way to you. Each AWS account would have a different kind of identifiers. It would have a unique ID which will help you to identify your Amazon account. That's a 12-digit number available to you. That number is very helpful because you can share your own account's details with someone else using AWS account ID. Along with that also, it would have a canonical user ID that is used with the Amazon S3. When we talk about the Amazon S3, we'll show you that canonical user ID is also, it's a very long 20-digit number which will help you to share your Amazon S3 resources with someone else. Now comes the most important aspect. Free usage tier. What is that? Let's see in the browser. Each Amazon, when a new account is created, up to 12 months from the account creation, it gives you some free usage tier. Yes, if you want to learn the Amazon, that is the best option you need to do. AWS free tier. So you first register with the Amazon account. You must have procured your Amazon account. After that, you have to use the Amazon resources within the defined size and configuration, and I assure you Amazon would not charge you. It's not my assurance, it's Amazon assurance. My assurance is, if you follow my tips, whatever size or whatever tips I tell you, if you follow that, it would not be costing you. So for various Amazon services, there is some free usage tier available. You can go to awsamazon.com/free and look out all the various services offered by Amazon as a free of cost. Like if you go for Amazon EC2, it gives you up to 750 hours of the Linux or Red Hat Linux or Windows instance of micro instance size free of the cost. And that means total 750 hours. Means if you run one instance for whole month, or you can run two instances, each instance for 15 days. Total, as long as it's not crossing 750 hours, it is free of the cost. Advantages, even if it crosses 750 hours, like suppose you run an instance, it runs for 800 hours total, Amazon would charge you only for 50 hours because first 750 is free. When we progress, and for each and every service I would keep telling you which service to use, how does it cost, and how it's a free tier, you can use that.
So first we'll be learning and understanding what is Amazon RDS. So RDS, the full form of it is Relational Database Service. It is a web service provided by Amazon, so that this service, it makes it easy to set up and operate a relational database on the cloud. So they provide all the access, they provide all the facilities, which is more than enough to create a database on the AWS cloud and just change some configurations like the endpoint or the host name. Just change that and it will work exactly like your MySQL database. If you're using MySQL, it will work exactly as a MySQL database, because this particular relational database service is a MySQL service which is running in the AWS data center. So AWS RDS provides these 6 options for you to choose from. First is Amazon Aurora, and then MariaDB, PostgreSQL, Microsoft SQL Server, MySQL, and Oracle Database. So these 6 are the options which they provide. And Amazon Aurora is a database service which is provided by AWS themselves. They manage it completely. It is not a different database engine which is hosted on Amazon Aurora. But in Amazon Aurora, they use MySQL and PostgreSQL, but all the functionalities which include those 2 database engines, to make them faster and make them reliable, they made their own architecture on which this MySQL and PostgreSQL engines will be hosted on, so that they become more reliable and highly available. So now, these are the benefits of using RDS. So first, administration burden will be reduced. You need to maintain or upgrade or patch your databases. AWS will do it for you. And again, cost effective. You only pay for the hours or the storage of the database, which is taken up by the database which you have created. And then security, yes, AWS. So security is basically a shared responsibility. You'll have to take care of not leaking the sensitive credentials. AWS will take care of maintaining the data center. They will keep the data center secure enough so that no attacks are made on them. And then highly available, yes, the architecture is made that you can create multiple databases, multiple readers, and multiple availability zones in one region to make them highly available in that particular region. You can also make them available cross-regionally. For example, if you have one database hosted in one particular region and you also have a customer base in another region, so you can replicate this database into that region and create multiple instances there so that you can make it highly available in that region also. And then scalability. So basically AWS provides us scalability, that is, they automatically do it for us. They increase the database in 10 GB incremental size. So for example, when there is a need for more data, and they'll automatically add until a certain point. And after that, you can create for example, you can vertically scale also. If you have one particular database instance type and you want more compute power, so you can change your database instance type, which has more compute power than the current database instance. And finally, free tier for RDS. So you can see these 6 options. For these 5 options, you have free tier capability. For Amazon Aurora, you do not have. I don't know why, but for these 5 options, they have provided, because these 5 options, in these 5 options, you can use T2.micro. That is some instance type. You can use that instance type database. So that instance type is provided under free tier. But Amazon Aurora does not support T2.micro instance type. So that's why you cannot practice Amazon Aurora for free, but you can practice the other databases for free. Moving on. Now, which AWS database to use when? So here you can see database types, few use cases, and the AWS service which can be used for it. So relational. You can use Amazon Aurora, RDS, and Redshift. So Aurora and RDS are traditional database types. So you can use them for traditional database needs. And Redshift is a warehousing tool. You can use Redshift for example, you can store your operational data so that you can take that data and analyze it and create some visualizations. So Redshift is a warehousing tool, and Amazon Aurora and RDS are relational databases. You can use these for traditional applications, for ERP, for customer relations management, and also e-commerce websites. So these are few use cases. And coming to DynamoDB. So DynamoDB is mainly used for high traffic web applications, for example, Amazon.com, or which requires a lot of personalized content. For example, if you go to Amazon, you might get not in Amazon, if you go to Google, you get personalized ads. And even though you go inside Amazon.com, if you want to search for a particular brand, a particular shoe, so you just provide its name, you filter it out. So to get that data and give it to you back. And same example with gaming applications. So if you would have played PUBG or any Battle Royale or any kind of games, there will be a leaderboard for every region. So you can click on the leaderboard and you'll get data within seconds. And that for that particular application, you can use DynamoDB because it gathers the data of that region at that particular time and it gives it back to you in a fraction of seconds. So you can use DynamoDB for high traffic web applications and again e-commerce websites. There can be 2 different databases used for the same application for different purposes, and then gaming applications also, as I told you, for leaderboards. And finally, for caching, you have Amazon Elastic Cache. There are 2 types, Memcache and Redis. So I think Redis is better than Memcache in a lot of sorts, but these are the 2 available options for caching in AWS. So you can use it for caching, and also you can use it for gaming leaderboards, because if the data is not changed for the gaming leaderboard, for example, weekly leaderboards, so the entire week the leaderboard will be the same. So you can keep the same and you can store it in the cache memory so that every time somebody checks for the leaderboard, it comes back. So now, where do they use DynamoDB? So this is an actual company which uses DynamoDB. You might or you might not know Duolingo. Duolingo is a course provider. They provide courses on languages. So they have 18 million monthly active users. They have 80 different language courses and also 6 billion exercises every month. So you could think of the amount of data which Duolingo needs, because they provide courses on 80 different languages and also they have 18 million different users. So that data has to go to all of those users, all of those single users. So for that, they have used DynamoDB so that they can gather data in a faster rate. So they can they can retrieve data faster than normal databases, traditional databases. And DynamoDB is a key value file database. Like you can store data in JSON format. And so this is one of the examples for that. So you can see, let us consider Amazon.com. So you're placing an order. So that order is stored in the operational database in DynamoDB. So you might or you might not know Lambda. So let me give a basic idea of Lambda. Lambda is a service which will run a set of code which you have mentioned in Lambda as a function. So whenever there is a particular action happening in DynamoDB, Lambda will automatically be triggered. For example, if a new order is placed, when there is a put operation, Lambda will get automatically triggered. And now a use case for Redshift also. I wanted to show a use case for Redshift. So now that data will be pushed into Redshift. So now Redshift will contain all the operational data. So now you can use the Redshift data to create analytics. So you can create some visual graphics and you can create some data visualizations for your company, for your organization. So this is the use case of DynamoDB and Redshift. These are used in various places. In what places you use warehouse, you can use Redshift over there instead of any other service. And for a key value file database, you can use DynamoDB, because if a company the size of Duolingo uses DynamoDB, even you will also get benefited by using DynamoDB. Now coming to Amazon Aurora. So Aurora is a fully managed relational database engine that is compatible with MySQL and PostgreSQL. So as of now, MySQL and PostgreSQL are the only compatible database engines with Amazon Aurora. So just a second. Okay. So as I told, you can only use MySQL or PostgreSQL for Amazon Aurora. So when creating a database in Amazon Aurora, you get the option of either choosing MySQL or PostgreSQL. Now Amazon Aurora, so you'll be already using your MySQL or PostgreSQL database locally for your local application, or internally you might be using within the company. So you can use this code, the same tools, the same application you use with the existing MySQL and PostgreSQL database with Aurora also. You will just have to change a few configurations. For example, in the local, let us consider you're using XAMPP and the type name would be, host name would be localhost. So now if you just change localhost to the endpoint which is provided by Amazon Aurora, it is more than enough for you to write data into Amazon Aurora and read data from Amazon Aurora. So as I told you, it is compatible with MySQL and PostgreSQL databases. And performance, so Amazon Aurora's architecture is designed as such, it provides you high performance, because in Amazon Aurora the storage and compute is separated. That I'll come later. So now let us see this. So without changes to existing applications, Aurora can give pi into throughput of MySQL and 3x throughput of PostgreSQL. And in Amazon Aurora, for 1 DB cluster in the sense one primary database and one read replica. So for that, you get 64 TB maximum size. So the minimum would be 10 GB when you create a database. The minimum size would be 10 GB. And for MySQL, it can go up to 64 TB. For one database cluster, and for PostgreSQL it can go up to 32 TB, and the minimum is the same, it is 10 GB. Now coming down, so now let us discuss about Amazon Aurora's database cluster. Database cluster consists of one or more database instances and a cluster volume. So you can see the compute and the storage is different. So in Amazon Aurora, the architecture is designed as such. The compute, that is this part, and the storage is separate. And when you create a database cluster, you will be provided with one primary instance, and you will be given 6 different data nodes in 3 different availability zones. So you can see there is an availability zone A. You can see there is an availability zone B. And you can see there is an availability zone C. So now when you create a database cluster, so let us consider these replicas are not created. So now you created one DB cluster and there is one primary instance created in availability zone A, and you will be given these 6 data copies in 3 different availability zones, even though there are no, for example, you are only creating an availability zone A and you don't have any database instances in the other availability zones. Even if they are not available, you will still have data copies in those availability zones. For example, if you are creating a replica later, for example, after 1 month you are creating a replica, so now you will need a data copy. So instead of creating a data copy at that time, it already has a data copy in that availability zone. And then if you create an Aurora replica, it will automatically take data from there. So now whenever data is written to one particular primary instance, so for example, when a user is registering, so this is the only point where he can write, and these are the points where they can read from. So the data is stored here, but you will have different endpoints for this primary instance, for this replica, and for these 2 replicas. You will have separate endpoints. You will have to specify those endpoints in your code so that you get this particular for example, if you mention the endpoint of this read replica in one particular, for example, let us say for login, you only provided this Aurora replica. So every time that data will be taken from this Aurora replica. The data will be read from this Aurora replica, not any other Aurora replicas or the primary instance. So now whenever you create one DB cluster, one database cluster, it will have one primary instance and one read instance under the same availability zone, and also 6 data nodes in 3 different availability zones. So this, while I'm creating a database cluster, I'll explain it in a way that you'll get to know where this primary instance is available and where is the replicas, because I'll show you how to create a replica also. So now these things cannot be proved, these cannot be taught you with a proof of concept, because these reside at the back, these reside in S3, but I can show you where they are stored and why the architecture is like this. So now let us move on and check this. So first, primary DB instance. So as I told you, the primary DB instance supports read and write operations, and any data modification operation for update or delete, anything happens in the primary database instance. If it is a single master database cluster, as I said, single master database cluster in the sense there is only one primary database instance. You can also create multi-master, that I'll come later. Now let us understand primary database instances and Aurora replica. So now primary database instance is the only endpoint or the only place where you can read and write and also do other data modification like delete and update. And also, now coming to this, Aurora replica connects to the same storage volume of that of the primary database instance. They are the same volume, but Aurora replica only supports read operations. Now here you cannot, in these replicas you will not be able to write. If you write in this primary database instance, it will be replicated in this Aurora replica once the change has been made. So if you come to this slide, you can see that. So once the change has been made in this primary instance, first it will be happening synchronously. So at the same time, when there is a change made here, for example, if there is a change made in this primary instance, it will be copied to this data copy, it will be copied to this, and it will be written in this. So synchronously it will happen to all the data copies, so that when somebody, once you change something here and when somebody is trying to read that same data from the Aurora replica after it gets written on all the 3 data copies, they should be able to access it from this replica also. Because once this is written in this volume, in this data copy, that means this replica can access this and get the data out of it. Because all the volume are common for all the availability zones, not like the DB instances. The database instances or the Aurora replicas are just for that particular availability zone, but the cluster volume is common for all the availability zones. So you can see each Aurora database cluster can have up to 15 different Aurora replicas in addition to the primary database. So what does this mean is, for example, coming back to this. So you have three availability zones. So let us consider in availability zone A, you have the primary database instance. Now your application is very read intensive. So many people are trying to read data. There is a lot of workload. So what you do, you want 15 Aurora replicas. So what do, you can create Aurora replicas in this availability zone and also in this availability zone and also here. This is somebody trying to, I'll continue that. Okay, so you can create 15 Aurora replicas within these three availability zones. So for example, you can create 3 here, you can create 5 here, and you can create the rest here. But you cannot create more than 15 Aurora replicas. AWS does not allow you for that. Instead of that, you can create a clone of this database, then create Aurora replicas of that clone. So that we'll discuss later. So connection management, in the sense, now we come to the endpoint part. So Aurora involves cluster of database instances instead of a single instance, as I told you. If you use RDS, it only creates one instance. You can create read replicas after that, but when you create an Aurora instance, it creates one main primary instance and also one read instance within that particular availability zone which you created it. So now the host name of that primary database is called the endpoint, and also the read instance. That read instance will also have an endpoint. That endpoint, again, it is also called an endpoint, but it is called as a read endpoint. As told you, it's a reader endpoint. So there are 3 different types of endpoints. One is cluster, one is reader, and one is custom endpoint. So Aurora, as I told you, it involves a cluster of database instance, not a single instance. And why do we use endpoint mechanism? Because you don't need to write your logic for balancing the load in Aurora. It reroutes to the healthy instances for you automatically. So when one instance, for example, in one region, you have 5 replicas. So somebody is trying to read some data. Let us say there are a lot of people trying to read some data, and suddenly 3 of those instances go unhealthy. So now the endpoint for all of these 5 different instances will be 1. So now when whatever, you don't need to change the endpoint now. The same endpoint will take you only to the healthy. It does not take you to the unhealthy instances. Once they come up, then it automatically balances it. So now when there are only 2 instances available, all the coming instances, all the coming in requests, connection requests will go alternately. That Amazon Aurora will take care of. It will balance our load for us. And if there are 5 instances, now the load balancing will spread and the connection requests will go to all the 5 different Aurora replicas. It will use all of those Aurora replicas. Now cluster endpoint connects to the primary database for that database cluster. So you get a cluster endpoint, which is the primary database's endpoint name, which is the host name of the primary database, and reader endpoint connects to one of the available Aurora replicas in that database cluster. So as I told you, if you have 5 replicas in one database cluster, it will take you to one of that database replicas. It won't take you to everything. It will take you to one Aurora replica in that cluster. So it will take you according to the maybe CPU util that Amazon Aurora takes care of. It will check the utilization of all the Aurora replicas. If one is less, it will take your connection request to that Aurora replica. And coming to custom endpoint, you can also create your own custom endpoint by selecting few database instances. So for example, you just want, if you are testing in one particular Aurora replica, so you don't want to use that Aurora replica for some time. So what do? You can create a custom endpoint which only uses few database instances which you select. So now, as I already told you, now let us consider again there are 5 instances, and in that one instance you are using it for some testing purposes locally. So now there are only 4 database instances, 4 Aurora replicas. So you can create a custom endpoint and choose all of these 4 and now change the endpoint to this custom endpoint. So now whenever there are connection requests coming, it won't even care about the other replica available, the 5th one. It will only go to the 4 which are connected to this custom endpoint. So it will automatically load balance it for you. You don't need to do anything else. It automatically load balances. So these are the 3 different types of endpoints. So as I told you, now let us look at the structure of it. So now the master, this is the only primary database instance, and these are the data copies, and it is in 3 different availability zones, and these are the read replicas in these availability zones. So this is one Aurora replica, this is one, and this is one. And for master, you have one cluster endpoint. For these replicas, you have one reader endpoint. So now you can see the users are the same. So when they are trying to write or read, if you are using the cluster endpoint, it goes to the master, get the data from here, and it gives it back to the user. Now if you are using the reader endpoint, it goes in here. It can take you to any one of these replicas. You won't know that. You cannot know which replica it is going to take you to, but it will take you to one of the read replica, get the data, and send it back to the user. So using reader endpoint, that is the main use. You can use the reader endpoint for just reading and use the master endpoint for writing, which will segregate the workload across reading and writing operations. And before that, I have a local application which I have already. So just a second. So it was. So I'll just register now. Region are replicated with typical latency of less than 1 second to secondary AWS regions. As I told you, what if you choose global, you can create database instances, primary database instances in multiple regions. But again, there will be only one primary AWS instance where you will write, but they will be replicated in the secondary AWS region in database instances within seconds. So if they are telling us they will do that, that will happen in within seconds. So you can use global or you can use regional. So now we are going to go with regional. We are going to create one database cluster in one region. And database features. So there are 4 different features. One would be one writer and multiple readers. As I told you, this is the typical Aurora cluster. There will be one primary database instance where you can write and read, and the rest of them are Aurora replicas. And then this one is multiple writers. So in multiple writers, what you can do is you can create multiple primary instances in all the availability zones. So you can see supports multiple writer instances connected to the same storage volume. This is a good option for when continuous writer availability is required. So for a write intensive application, you can use multiple writers because you can create a custom endpoint with all these 3 database instances, so that every time somebody is registering, first time it goes to the first database instance, second it goes to the second one, third it goes to the third one, but every time there is some data change in one of those instances, it will be replicated in all of the instances because the storage is the same storage. All of them have shared storage. So yes. Then there is one writer, multiple readers, parallel query. So this improves the performance of analytic queries by pushing processing down to the Aurora storage layer. So I think you can connect this with Redshift and use for operational data purposes. So you can use it for analytical queries to get a lot of data. And then server provide a lot of information actually. You just specify the minimum and maximum amount of this. Aurora scales the capacity on database load. This is a good option for intermittent or unpredictable workloads. So what you can do in serverless is, for example, you think your database will always have an amount of 10 GB to 100 GB of data. So now you can specify that storage space, and also you can specify the processing power. So you can specify you need 10 virtual CPUs, that is the minimum, and 200 virtual CPUs as maximum. So now what Aurora will do for you is, whenever there is, it will check for the workload's capacity it needs. If the workload needs 20 GB of data and also like 20 vCPUs, it provides it. And if it requires more now, there is a lot of data coming in and the processing power is increasing. So now it provides you with more vCPUs and it will also provide you with more storage space. Now, a lot of data is getting deleted. Now again, it will reduce the storage space. Also, it will reduce the processing power. It will, it will decrease the number of vCPUs provided. So this option is a good option, and also here you will not pay for the maximum amount. you'll only pay for the size of data which is stored at the time, and also the vCPUs used. The total hours of the running hours, the total running hours of those virtual CPUs, only you'll get billed for that. You'll not get billed for the maximum number you put. If always your databases are using the maximum capacity, then yes, you will be billed for the maximum amount. But for now, you won't be billed. You will only be billed for the amount of database usage and the CPU usage which your application is using. So now I'm going to go with one writer and multiple readers. Now for Amazon Aurora, there is no free tier capability. You don't get to practice in Amazon Aurora, so they charge you. I'm going to go with a dev or test environment. So if you go with Amazon RDS, then you get a free tier. So I'll just choose something. Let's see. Oh, yeah. So you can see there is a dev and test and also a free tier. So a free tier in the sense you can only use one database type. There is only one instance type, which is t2.micro. So only that instance you can use, but you won't be billed for that. You can use a total of 750 hours in that particular database instance. So that 750 hours is calculated for 1 month. And for example, you run 5 instances. The total of that 5 instances is less than 750 hours. You will get it for free. If it is more than 750 hours, then you will be billed for that. So now Amazon Aurora does not have the free tier available. So I'll just go with dev or test environment. And you can name your database clusters. So let it be 1, not a problem. And then master username can be happen, not a problem. Then master user password you will have to provide. So this is to access your database again. So now I'll just go with a simple password. Yes.
You were saying there's no free, that means if we do our lab ourselves, we won't be able to pick this option.
No, I don't get it.
There's no free tier option. You said you mentioned
yes,
about
for Amazon Aurora, yeah.
Yeah. So if we want to practice, do some lab,
you'll have to take test.
Okay, so for selecting that is free too, right?
No, it is not. You will have to choose. I'll tell you, if you want to practice, I'll tell you what to choose. Either choose t2.small or t3.small, because they cost you like $0.02 per hour or $0.002, something like that. So if you use memory optimized classes, they'll charge you more. So for practice, you can use burstable classes. You can use t3.small. So they provide you 2 virtual CPUs and 2 gigabytes of RAM.
If they charge or not, do they list it there so we know? We don't get in trouble. But
they provide that. So we'll have to go to the
on the right hand
pricing options to see that. So you want to see that right now?
No. Just want to be careful for the team that if we want to practice, we know what to choose.
No, I was charged very less, so let's see.
It would be incorporate the price onto that page.
It's over here. So for t3.small and t2.small, it is $0.041, and for everything else it's a bit more. And for the memory optimized, it's more. It's more expensive than this.
That's per hour, so we need to be careful.
Per hour, yeah, it's per hour.
So we shut it down right after.
Then you'll get charged like a percentage of it. You'll get charged for that minute you use.
Okay.
Yes. So next is availability, and so I'm going to choose t3.small.
In this drop down, it is saying EBS.
Okay, then just a second. Okay, so the backups are taken in S3 and the storage. Yeah, I got it. So the backups are taken in EBS and the storage is the backups are taken in S3 and the storage is made in EBS. Okay. So I gave you the wrong information at the start as S3 as I read at that time. So I confused between the backup storage and the actual storage.
Okay, so even in this case, we'll be charged for the 6 GB and not just for the 1 GB, right?
Yeah, so just a second. But I think you'll be charged for the 6 GB.
Okay.
So I think that's correct.
So actually, that means you'll be charged in EBS. So how much charge you get for EBS will be charged double. So I think okay, we'll see this. That is multi-availability zone deployment. So as I told you, while creating a database cluster, you can either go with multi-AZ deployment or don't create an Aurora replica. So when you use this, what happens is when you create this database cluster, automatically they'll create one Aurora replica or a reader node as it's another name for Aurora replicas. So if you create an replica while creating, so when you create, that replica will be already available. But when you click on this, then after creating the database and after doing all the operations, then you will have to create a replica. So I'm just going to go with this. I'll be showing you how to create a replica inside the console. So right now I'll just go with don't create an Aurora replica. So I think this will do good. And then VPC, I'll just go with my default VPC. And then additional configuration, yes, it should be publicly accessible. If it is not publicly accessible, then you'll not be able to view your database. For example, you cannot connect it to your local MySQL shell. The thing is, you can connect your Amazon Aurora's endpoint and view the tables inside Amazon Aurora's endpoint in your local MySQL shell also, in your even in the XAMPP shell also. So you can use the endpoint to do that. So yeah, I'm just going to go with that. And again, the security group is going to be default. I'm not going to change anything right now. And here you can choose one of these availability zones where your primary database should be available. So actually, primary database is for the entire region. But when you create, there will be another instance created with that primary instance, right? As I told you, it is a cluster. A primary instance and a read node also will be created in the same time. So now, if you choose one of these availability zones, that reader node, that reader endpoint will be in that availability zone which you choose here. But I'm just going to go with no preference. And then coming to the other options. So here you can see the database options. This is the database instance identifier. This is the name which we give for that. And this is the database name inside the database. So once you create, there will be default databases like test and other databases, I don't know. So there will be a database like that. Here, if you enter a database name right now, so once this database gets created, then you can go inside and check whether this particular database name is available or not. So I'm just going to give the database name which I use in my local application also. So it is going to be registration, and these are the parameter groups. So why 5.6? Because you can see over here, yeah. So the MySQL which you choose is a 5.6 version. So a parameter group is nothing. It just gets the data of. It will just store the data of what kind of a version is it using. So you can use this parameter group to create another database cluster of the same type. So you can choose this, and this will be chosen in default. You cannot change these parameter groups. Once you choose a version, it will be automatically taken. And next is failover priority. So now when you create a database, you have a primary database and a secondary. So now you can choose the failover priority. There are 15 priorities because you can create up to 15 replicas. So for example, let us consider you have created 15 replicas, and for one first replica you have provided tier 1, and for every other replica you create, you provide a different tier. So now why is this? Because if your primary database instance goes down, whichever Aurora replica has the tier 1 failover priority will be made as the primary database. It will be provided with the right privileges. So that's why they provide this failover priority, and it is up to 50. Tier 0 to tier 15. So you can provide for the primary till the till the 15 replicas. So, but what if you provided the same, for example, you provided tier 0 for two different database replicas. So that will be considered accordingly. That will be taken care of Amazon Aurora. It will choose one of those and provide the privileges. So it might choose according to the database capacity. For example, you provide a different class for that Aurora replica. So while you create that Aurora replica, if you want that Aurora replica to be more powerful, so for one Aurora replica, you provided the highest database instance type, and for the second Aurora replica, you provided just T2 So now Aurora will check between these two different Aurora replicas, which is the most powerful, and then it will provide that the failover priority. So that instance will be made the number one primary instance. So that is why you will have to provide here. But I'm just going to go with my preference again. And then backup. So backup retention, in the sense you will be taken. You can see, choose the number of days that RDS should retain automatic backups for this instance. So, for example, right now you have some data. So that data will be automatically backed up, and if one availability zone goes down or your data goes down, so what you can do is your data will be backed up in S3. So now what you can do, you can use that snapshot to create another database cluster, and if you create that, yes, the data will be the same, because the snapshot contains the data up till the point where it got lost. So that's why you can choose this, and you can retain the backup retention data up till 35 days. So up till 35 days, the maximum moment of retaining automatic backup is 35, and the default period is 1 day. And also, if you are providing any tags for this database instance, it will be also copied to snapshots. So why tags? Tags are just to monitor or track. For example, you will be given a tag for one database instance, and that snapshot will have the same tag, so that you can understand this particular snapshot is for this database. And if you have another database and you again copy tag to that snapshot, so you can differentiate between which snapshots are for which databases. So that's it. That is the use of these tags. And then enable encryption. So
sorry, question. Yes. The snapshot is the same thing as backup, right?
Yes.
Okay,
snapshots are the name for that.
Okay, so this is, in other words, it's copy tags to backups, right?
Yes, exactly.
So it's just
copy tags, in the sense the name of the snapshot will include this tag also to understand.
Oh, okay.
Yes, so this backup is for this particular database instance. So tags are just to keep track of them.
Okay, so what if I want to keep backup over 35 days? I want to be longer.
No, you cannot. These are automatic backups. So these are used for point-in-time recovery. So after that, again, another backup will be taken. That will be again saved for another 35 days. Then the next day, another backup will be taken. It will be stored for 35 days. And it's not just one day you can only take backup. Once you can take multiple times, and also you can manually take backups also. So I think the maximum retention period for an automatic backup is only 35. What you can do is you can manually create a snapshot. That snapshot you can keep it for a year or 2 years, or you can keep it for your entirety. But automatic backups can be retained for only 35 days.
Okay, got it. The automatic backup, is there a schedule that you could specify, or it's Amazon?
For example, let us say at 5 o'clock your database goes down. So at 5, it will check for the latest time when the database got backed up. If the database got backed up at 4:50, then it will take that snapshot and recover the database.
Do you have control of when the backup runs?
Yeah, I think you can set up that. I think you can set it up.
Another interface.
No. I think you'll have to create a automatic backup setup for that. Or no, I think you don't have access. I've never seen a automated backup access in the creation console.
Okay, so does that mean later on you will go to another interface to set up when the backup runs?
There is a snapshot interface separately.
Okay.
Yeah, I'll show that once I created this. We'll go inside that and explore that part also.
Okay.
Yes. So now encryption, this will automatically be done by AWS. So it takes the default RDS key and encrypts our data. We don't need to worry about this. This is AWS part. They do it for us. And this is the key ID. And then backtracking. So backtracking in the sense, if you have created a snapshot 2 days ago and you need to make your database as the same as the data which was available 2 days ago. So now you can enable backtracking and provide the number of hours it can backtrack. You can provide 48 hours. So it goes back in time. It does not go back in time. It checks for the 48 hours, what and all data modifications which have been made, and the most recent snapshot which was taken will be taken into account and the database will be recovered. So you can see this here. Backtrack lets you quickly rewind the database cluster to a specific point in time. So you can go to that specific point in time where you took that snapshot and get it back. So without having to create another database cluster. You don't need to create another database cluster. The same database cluster will be recovered using that. So you can provide the number of hours over here for the number of hours which it can backtrack, and the maximum is up to 72. And you can see it over here, typical user costs. It costs you $57.52 a month for db.3.small, and let's go 72. It becomes 86. Yeah, it costs some money. So if you want backtrack, I think you can backtrack it for a database which is the data stored in it are really valuable. Then I think you can use backtrack. And then enhanced monitoring, again, this will cost you, but this is if you are using a separate monitoring tool for monitoring these databases, then you don't need to enable this. Basically, this will provide you more metrics. This will provide you more insights. But if you want just the basic metrics like CPU, util, and stuff, and for that you don't need enhanced monitoring. CloudWatch provides you for that for free of cost. They provide you default key. And then you can also so some logs will be published in CloudWatch. You can select the log types which has to be published to CloudWatch also. The audit log, or if any errors, that logs, or any normal logs, the written, write log, we read, all those queries, all those logs can be published in Amazon on CloudWatch, and you can get those logs from CloudWatch. So I'm not going to use logs right now. So it is, if you want any error log, for example, you want to check all the errors which were happening so that you can rectify it in the future, you can just click on this. All that error logs will go to a particular Amazon CloudWatch group. You will have to go to CloudWatch. You will get the name of that CloudWatch group, because it will take the name from here, whatever database instance you create, database 1. So you can go there and get those logs from the CloudWatch log console. So you can use log exports for that. And finally, maintenance. You just
one question on the one question on the log was, so will it be having any performance impact on the application?
No, it does not.
So this is
that's
separate.
Yeah, because all the logs will be taken from, I think, the storage. So if there is any fault, that's what I read from the white paper. So what they explained was, as everything is separate in the Aurora architecture, so there won't be any impact in the performance of the application. So this process will be taken care by CloudWatch. So CloudWatch will be responsible for getting the log, check for each and every step going on. So it does Aurora.
Okay, and it will be utilizing the same CPU which is allocated for the application, right?
Yes, it does not. It will be using the same and the storage or anything else. So CloudWatch is responsible for that now. So you'll have to go inside CloudWatch and get those logs. So now the logs will not be stored in Aurora storage. It will be stored with CloudWatch.
So in terms of the audit log, is there another interface to configure what to audit?
Yeah, you can do that.
Okay.
Yes, you can do that. So you can use CloudWatch for that.
No, I mean,
so these are just, you will get all the logs. If you choose these, you will get all the logs in CloudWatch. Then from there you can filter it. There is no separate user interface for just getting a particular log.
So if you check audit log, so by default it's gonna audit everything, and then you go to CloudWatch to
logs
get the audit log and filter out what you need to see, right?
Yes.
Okay.
So if not selected, this will be captured, or anyway to check the error log in DB level, or it will be captured in Amazon logs then, right? Amazon servers.
Yeah, it will be captured in Amazon servers. Yes. Nobody's speaking. Okay. So I was at this maintenance part. That is, if you enable auto miner version upgrade. So what it basically means is AWS will do all the minor version upgrades for you. So if there is any update or patching required for that particular version of the database, then AWS will do it for you. You don't need to do anything else. You just have to pay the money which you normally pay for Amazon Aurora, and they'll do all the version upgrades and stuff for you. And also there is one more thing, maintenance window. So when there is maintenance going on, so there will obviously be some delays in it. So there will be some, it will affect the performance. So here what you can do is, you can create a particular time, and at that time you can have another setup made in another DB cluster just to use for that particular period of time where it will maintain. So you can see half an hour is the least. So it will maintain your database for half an hour, and once it also you can choose the time when it is very least used. You can choose the day also, you can choose the time also, you can choose the duration of that. You can also, for an entire day you can do, but your database will be still available to read and write, but it will have a few performance issues because AWS will be working on. So this you can select, and also you can give no preference, but I'm going to give no preference because my application is not going to have a lot of users right now. And finally, deletion protection is, if you click on this, you cannot go to your database instance console and click on the database instance and go to actions, click delete, and it won't delete. You'll have to go inside your database, modify it, and remove this enable deletion protection. Once you do that, only then you'll be able to delete it. So this is just to prevent carelessness. So if you're trying to click some other option, if you click delete, you will get a prompt, but still there is an option to enable deletion protection, and this is to protect from accidentally deleting your databases. So now let us create the database.
So one more question about the minor version upgrade. It's online upgrade, right?
Yeah. So it will be happening in the data center.
So I mean, it doesn't affect the database. If I have load going on, and it just happened that Amazon's doing the minor version upgrade.
Yeah, there will be a little bit of
issues at that particular time. But obviously, you will have all the availability zones, the version upgrades will not be happening at the same time. So if one availability zone is having less performance, it will take your connection requests will be taken to the other Aurora replicas by the endpoint.
It's online. Everything's online. Okay.
Everything is controlled by Aurora. So yes, it load balances for you. So that's why even though the performance delay is there, for example, if
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services or AWS is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
the version upgrade is happening in all the regions, then yes, there will be some delays.
And the configuration of failover, I don't see for master database. If it crashed, does it fail over to?
That automatically happens. As I told you,
the priority. I saw the priority setting. That's which one is used for the read replica.
It's over here. Yeah. So if you select one of this, it will be taken for the instance which will get created with the primary database. So the primary database will not have any failover priority because that primary database is going to be failed, right?
So this failover priority is for the primary to fail over. Yes. And act as primary. So I see the sequence from 0 to 15. So there's 16 of them. Okay.
Yeah, there is 16 of them. So you can create multi-master clusters also. You can have, like for example, you have 2 different database clusters. Then you will have 30 Aurora replicas, and you can use these tiers. So these don't. So this is provided by AWS. This is just to mention your priority. I don't know why there is 16, but yes, there is no priority needed to be provided for your primary database. You just need to provide it for the replicas. So even if I provide a priority here, it will be taken for the read node, which will be getting created.
So if that, if I set up no preference, and Amazon will primary database to just anyone, so right?
If you don't prefer any, if you don't provide the failover priority for any of your Aurora replica, then it will choose, AWS will choose automatically. It will choose which replica to provide the privileges to.
And that one will become a primary?
Yes.
Okay. Thank you.
Yeah.
So one question for the DB upgrades. So these DB upgrades, is it like controllable by us? Like let's say Amazon decided to increase the version of this MySQL 5.6 to some other version, right? So can we control this if we don't want this upgrade?
No, it's not like that. So if you choose 5.6, then the version will be 5.6. Minor upgrades in the sense the data center upgrades, maybe for example, you are trying to increase your instance type. That will be made by AWS. So when your database will be shifted from a lower capacity instance, for example, 2 virtual CPUs to 5 virtual CPUs, then that will also be upgrade from one instance type to another. So it will not, if you choose 5.6, then it will not change your MySQL version.
Okay, so it is all about the patches for the DB updates.
It is all about the patches.
Okay. And all those patches will be controlled by checking that box like automatic minor updates.
Yeah, it will be taken care of. Like they'll take care of it. I think if you don't provide it, I think we'll have to do that. I've not worked with that actually. So as far as I know, that is AWS does everything for us. That is the minor patches, everything will be done by AWS.
And those patches could impact my application too, right? So that's why I'm asking. So if we selected that, saying okay, I'm okay with minor updates, which could include patches. So
you can cancel that. Yeah, you can just uncheck that box.
Right, but if I checked it, so will they give like advance notice saying by this date this patch will be applied, so the application has to be compatible with that, or like they just do it by themselves at some point of time?
Thing is, I've never had an application running and I've never got anything like that, so I can't answer that question, but I'll check into that because whenever I create a database, I provide that because I've never had a time to uncheck that. I always check it, but I'll check into that question and I'll answer in the next time when I'll be using MySQL and PostgreSQL in Aurora.
Yeah, so, thank you.
Yes.
I have a question.
Yes.
So do we have an option to auto scale the writer instance?
Auto scale the writer instance. You can create, you can see over here, you can create a clone. You can also create a cross-region preserve, because if you create a clone,
is something that I clone and then have it running, right? So that would be kind of paying for two writer instances. What I'm asking is, like, can we auto scale based on the resource utilization? Let's say if my CPU is more than 80%, I just auto scale to another writer.
Yeah, that
and
you
then
can do. That you can do, yes. That I think you can set up an alarm, and once that alarm exceeds the condition, then you can increase the size or you can change the instance type. So there is that. So we provided t3.small, right? So I think you can automatically upgrade the instance type so that you get more storage, and also there is that.
No, but we if we change the instance type, then that's a vertical scaling, right? Which means that there's going to be some downtime. But what if I'm looking for an horizontal scaling?
So that's what I told. The maximum, if you consider storage, the maximum one Aurora DB cluster can go is 64 terabytes. So after that, you will have to do horizontally. For PostgreSQL, it can go up to 32 GB. After that, you'll have to go horizontally.
Storage. What if, let's say, if my resource utilization is more than 80%, and I want to spun up another writer instance, which gets attached to the current cluster instance.
Okay,
can I do that?
Yeah, yes, you can create an alarm for that, and you can create a group where you attach all of these database clusters and launch one more instance.
When you say resource, you are either talking about CPU or talking about memory, right?
Yeah, that's right. CPU or the database connections or memory. Yeah.
Right. So
I think there is a replica auto-scaling. Writer auto-scaling.
Yeah, so I just want to know if there is a functionality built in, or we need to do something on our own.
So there should be an option. I'll just a second. Monitoring. So I'll do that. I'll do that automatic scaling if it is available in the next session. I'll do a demo on
that. Okay.
Is it fine? Yeah.
Yep. Should be fine.
Yeah.
Thank you.
So now we've created a database cluster. So this is what I meant by a cluster. There is a main database, which is regional, and there is a writer. So if I click on this, if I go inside, you can see two database endpoints. One is the writer, one is the reader. So as I told you, for a cluster, there will be one writer instance, which is the primary database, which can both write and read, and there will be a replica created in the same availability zone as of that. Like for example, it can be in any availability zone because I gave no preference. So it is in US East 1D. So this replica is in 1D. So now, if I provide this endpoint to read my data from the database, then yes, it will directly go to my read replica in that availability zone and get the data back and build. And if you want to write something, you can use this. But same, if it is a small application, you can just use this and access both read and write. But if it is an application which needs high availability, you cannot just go with one database cluster. Either you can go with multiple database clusters, or you can create. So here, this is my localhost. This is my local system, which has the database. So there are some commands. I think you'll obviously know that. Where is it? So I just used MySQL dump, which is already available in my registration, but I'll do it once again. This is my local database. So I'm writing the data in my local database into a registration.sql file, which is in this location with this. So once I do that, I can use that SQL file. I'll run that SQL file when I connect the database using the Aurora instance. So once I connect that, I'll be able to import that data by using this command. So I'll push this commands inside this SQL file that will be run inside my Aurora database. So this I'll have to change. The endpoint I'll have to change. So once I change that and run this, then the data which is stored in my local will now be stored in my Amazon Aurora cluster. So now I can go inside my code and change the endpoint from localhost to my Amazon Aurora's endpoint. So that will make the transition seamless. So these are for small applications, but for huge applications, when your database server has an IP address, you can use database migration service. That is a separate topic. We'll not go into that right now. We'll do that in a separate session. Right now, we are just going to make a SQL file which will run in the all the MySQL operations will be done on Amazon Aurora database, which will create a table which will put all the data from my local inside the Aurora, and then we'll just change the endpoint from localhost to my endpoint which is provided by Amazon Aurora. So first let us run this command and get. So yes, I think it's done. Next, what we have to do is I'll show this. So you can see all the content of that database has been stored here. So you can see my content Intellipaat, Intellipaat@gmail.com, Intellipaat1, Intel@gmail.com, Cody@gmail.com. So all the data is stored here. So I just have to run this so that all the changes are made in my Aurora database also. I'll just close this. I'll have to paste my instance endpoint over there. So I'll go to my RDS console and then copy my cluster ID. After that, I'll put it over here. That will be my host name, and I'll have to provide the port number. After that, I can run this. So if I run this, these changes should be made in my First, let us try to connect into our instance. So username is admin. My port number is 3306. Password, host name, just copied it. So yes, I am able to log into my Amazon Aurora database. So So yeah, you can see there is a registration database. So while creating the database, I gave a default database name as a registration. So sorry, not default, the initial database name as a registration. So once your database is spun up, so you can go inside and check whether that database name is created. Yes, a registration database has been created. So right now, I'm trying to dump my content of that inside this. So that should happen seamlessly. I don't know what is the problem with this. So check with this endpoint. So can anybody tell me if anybody knows what exactly is this problem? Did not face this before. Specified key was too long. Max key length is 767 bytes.
Open this registration SQL.
Registration?
Yeah, open this registration.sql.
Yes.
That's a data.
Okay, column length extension. Create table users, username, email, primary key. Dumping the data.
Okay, what is, wait. So you are inserting data in users table, right?
Yes.
And what is this third column? Can you go up when you create this user table?
Password.
But it says line 25.
Line 25 is around here. Sorry, it's around here.
You could view line. View line. Okay. Sorry.
Go down.
Yes. So I'll try to just create a database. I'll create the same table inside it. I'm not able to jump it, so I'll just log into my database. And okay, so what I'm going to do is I'm going to do the same thing, but not with the SQL file. I'll just create a table and I'll insert some data. I'll just register it and then I'll sign up. So I'll just use this. So okay, so now you know that my application is connected to your local database. So now to make it access my Aurora database, so it's pretty simple. You have to enter your code. So my code right now here is it's in server.php. So I'll open. So yeah, so here I provided localhost, root and registration. So here I'll have to provide my endpoint. Here I'll have to provide my username and my password. So my password was admin123 and my username is admin, and I'll have to provide my endpoint over here. So now if I provide my endpoint and save right now and just refresh it, now my database will be shifted to Amazon Aurora. So it's just simple to change it from here to there. So right now let me just copy my writer. So yeah, so I'll paste it here and I'll save it. So done. Now I'll just close it. Now if I try to log in, I'll not be able to log in because there is no content. I'll have to sign in. I'll have to sign up. So first let me sign up. I'll sign up as Intellipaat at gmail.com. Again, I'll provide Intellipaat and Intellipaat. So now before doing it, let us first check whether there is any data in one. So it's an empty set. So once I click on this, my Aurora database should have a table inside it. So let me click on registration. So yes, it has logged in, but did it create a table? Yeah, so it created a table in my Amazon Aurora database. So the transition was simple. So even a person who is using and suddenly the endpoint has changed, there will be minimal, there will be very less time taken to shift from your local to your Amazon Aurora database. You just have to shift the content. For that, you'll have to import your data into Amazon Aurora database. So once all the process is done, once everything is consistent, then you'll have to shift from your local to Amazon Aurora. So right now the data is stored over there in my Amazon Aurora database. So now I think you get the point here. So because we've used localhost now, to access Amazon Aurora, it's very simple. You just have to use its endpoint. So That's where its compatibility comes in.
So introduction to AWS DevOps. The first thing is, why DevOps on AWS? So you can use DevOps on any cloud service or even on your on-premise environment. So if you have a business running, you will have an on-premise environment. You might have an infrastructure for yourself. You can run it on it also. But why AWS DevOps? That we'll see moving on. So first, what is AWS DevOps? AWS DevOps is a set of developer tools which is provided by Amazon Web Services. This allows us to create a CI/CD pipeline from the scratch to the deployment stage, that is from the source. For example, a version control tool, maybe GitHub, maybe Azure repos, maybe AWS code commit. So from the source stage till the deploy stage, we can do everything. It is the same as any DevOps tools, any DevOps lifecycle, or any DevOps process, but the tools are provided by AWS. And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS Developer Tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you will launch a virtual machine using code deploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is code commit, and then code build, and then code deploy and code pipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss code commit. So the name suggests that code commit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS, and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using code commit. You can also see over here code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. For if you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub, it is like Bitbucket, it is the same kind of tool, but it is provided by AWS. And then AWS Code Build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS Code Build, 100 build minutes. That is, for if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS Code Deploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS Code Deploy. So first is automated deployments, and then minimized downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. Sorry, it doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it is automatically, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds, and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched, and you will have to change your code over there. When you do that, the downtime increases, but using Code Deploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console, and you can control all of the operations happening in Code Deploy, Code Commit, and Code Build. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS, or Lambda. That means if whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is Code Deploy, guys. And then finally, AWS Code Pipeline. So we are going to use Code Pipeline. We can use Code Pipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website, or you can automate your application which is running on Code Deploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to Code Deploy and the change will be made. So that's how you use Code Pipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS Code Pipeline. And then, so you can see over here, easy to integrate AWS Code Pipeline with GitHub or with your own custom plugin. So you can integrate GitHub and Code Pipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. and then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments, so it is basically free. Whatever services you launch using it, for example the EC2 instance, so those are charged, not these services like pipeline or code deploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage and then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS code pipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using code pipeline and code deploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. abspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application, but right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is we'll have to create a code deploy application. So let me click on application. So I already have one, so this is what I tried. So create application. The first thing it asks is your application name, so I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS, I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to, that is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Machine Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance T2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with T2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys, this is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions, and here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we have done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the name is, sorry, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag to, so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now just I'll go back, and now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. Sorry guys. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to code deploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a code deploy application and a deployment group, and also how to connect a EC2 instance with code deploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay, guys. So next, code pipeline. So only using code pipeline, we're going to connect our GitHub and code deploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new code deploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role. It needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts, that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built, so I don't need to worry about building. So I'm going to skip build stage. So now you will have to deploy. You will have to click on a deploy provider. So you can see over here there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose Opsworks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group, I have only one deployment group. I'm choosing it and moving on next. So this is again same thing. basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now let me see my instance is running. So currently if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded, my code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now code deploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my code deploy got succeeded. So right now if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this is not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my app.spec.yaml file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html, and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world, and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID, the commit, which commit it took will be present over here. Once it succeeds, that change will be implemented in my code deploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world, and you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using code deploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so whenever there is a change happening in your version control tool, that is this change, when it is committed, in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to code deploy. So code deploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using code deploy and GitHub. So we've learned how to do this. So right now let me recap all of the stuff we learned in this session, guys, and after that we'll end this session. So the first thing, I'll go to the slides once again. I'll come from the beginning. I'll just go quick. So first thing, what is AWS? It is a cloud provider. It's the #1 cloud provider in the world. So many Fortune 500 companies are using it, and it provides you a lot of services with a lot of benefits. And also you have a pay-as-you-go method. That is, you'll only have to pay for the time you have consumed those services. And then what is DevOps? DevOps is a methodology. It is a union of people, process, and products to enable continuous delivery of value to our end users. So it is basically providing value continuously to our end users without reducing the downtime and also increasing the deployment speeds. And then introduction to AWS DevOps. So basically it is using DevOps principles on AWS, and there are few developer tools which is used to do that. And then why AWS for DevOps? Because fully managed services, you can scale easily, programmable, and then automation. You can automate your entire company's process, and then it is secure. And also, as I said already, it is pay as you go. And then we saw all of these 4 services: code commit, code build, code deploy, and code pipeline. And then so we saw these 2 tools, and here we learned how to create a code deploy application and also how to create a code deploy deployment group. So using code deploy, we created a deployment group which basically targets to a particular instance. And then code pipeline. So we used the version control tool GitHub and also code deploy to create a pipeline, so that whenever there is a change made in my GitHub, so whenever there is change made there, it will send that changed code to code deploy, so that change will be available in my instance also, so that it will reduce downtime and the change will be automatically made in my website. So right now you can see over here, so this is my this also I explained rapid delivery. You can configure your workflows. It is very easy to start, and also you can integrate it with many of those version control tools or other tools like Jenkins, and also you can connect it with Elastic Beanstalk or EC2 or S3. So you can connect it with other AWS services also. And then finally we learned how to create a CI/CD pipeline, and so this is what we learned. We created an instance, we created a deployment group, and after that we created a code pipeline using the source from my GitHub repository and the deploy as my code deploy application, which has a deployment group which targets to this instance, guys. So after that, when we ran everything, everything ran successfully. So my website got changed whenever I changed my code in my GitHub repository also. So this is how you create a CI/CD pipeline, guys. Okay guys, now let us start and look at why do we need AWS SysOps administrators. So why SysOps admin? Creating automatable and repeatable deployments of networks and systems on the AWS platform is the basic requirement or the primary function of an AWS SysOps administrator. So now, what is the average salary of an AWS SysOps admin? And according to Glassdoor.com, in the USA it is $83,000 per annum, and in India it is 4.7 lakhs per annum. Coming back to the SysOps admin part, so SysOps administrators are 2 different roles actually. So SysOps is system operators and admin is an administrator. So these 2 are two different roles in a huge organization. But when you come to AWS, you will have to configure or create automatable and repeatable deployments as well as maintain the servers. You will be operating the servers and also maintaining it. So right now, a work for a system operator and an administrator is combined together. That's why AWS SysOps Administrator is a role here. So AWS SysOps Admin is one of the popular roles, and systems operator or an administrator could take up this certification and become a AWS SysOps Admin. Now moving further, now let us see the roles and skills of an AWS SysOps Administrator. So the first role or the first skill he has to have is configure the AWS Cloud Management Service. Yes, you can segregate this role into three parts. One is Amazon Web Services, one is System Operators, and one is Administrator. So this person has to know how AWS works. Second, he has to know the work of a System Operator. Third one, he has to know the work of an Administrator. So now, configure the AWS Cloud Management Service. He should understand what is that organization's usage of AWS services. According to that, he'll have to configure it to make them better. And then coming to this point, that is monitor and manage these services. As I already told you, if he configures those services, obviously he'll have to maintain and monitor them and constantly upgrade it whenever there is a need. And then efficiently monitor billing and to develop cost optimization strategies. So he'll know how the entire architecture is working right now after he configures it, after he monitors it and gets the metric data. After all of those operations, right now he'll understand how this entire architecture is working, and he can now efficiently monitor the billing costs and create a cost optimized architecture. And the fourth point is infrastructure security and data integrity. Yes, he'll also have to maintain the security because he'll be the person who will be creating users for the organization, and those users should have strictly lesser permissions for only their tasks. For example, a web developer should not be given access to the database part, or let's say an administrator has the complete access. But if you take a different let us take a business analyst. A business analyst doesn't need EC2 servers, or he does not need Elastic Beanstalk. But and web developer will need them because he has to host his web pages inside a server. So the administrator has to decide that, and so that this infrastructure is secure enough, and also the data is confidential, and also the data sent or coming in are the same. So the integrity is not.
AWS was introduced in 2006, and since then they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top three companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services, or AWS, is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Going away. And then automate infrastructure deployment. I already told you the basic primary need of an AWS SysOps admin is to automate a process. So that's exactly what they are saying here, that is automate infrastructure deployment. So to do that, AWS provides a stack web service, that is CloudFormation. You can use CloudFormation and you can create a JSON or a YAML file which you can run on CloudFormation, which will automatically create a complete AWS architecture for you, which you have designed in that JSON or YAML file. And then finally reduce the time required for the production. So yes, your organization might have applications. So when an application is created and is tested and it's successfully running in your staging environment, you will have to, or the company wants to shift it to the production environment. So to do that, it takes some time. You will have to create a plan, or you'll have to keep the services as such. This process is seamless as possible because this will directly affect in your profits. Because the faster the application is up and online and running, people start buying early so that you can get more customers. So you'll have to do that. So these are some roles of an AWS SysOps admin. And now let us see the skills required for an AWS SysOps admin. As I told you, first one is AWS skills. He should understand in depth how AWS is working and also the best practices of using Amazon Web Services. And then second one, as I told you, it is a two different role combined together. One is systems operators and one is administrator. So he should understand how a system operator works, that is he runs servers and he configures it. Administrator takes care of everything else, the complete infrastructure. So he should understand how both of those roles work and he has to keep his work aligned as such. Third one is Linux and Unix, because most of the organization's applications are hosted on Linux. So he has to understand how it works and also how to configure those Linux environments. Fourth one is secure and cost optimized architectures, and we discussed this in the roles. So secure and cost optimized architectures should be created by this person. So he should keep the architecture secure enough, and also it has to build the company. So the bill has to be the lesser cost. It should not go beyond an expected limit. He has to create an architecture, or the person who is an SysOps admin has to create the architecture as such it gives the lowest bill possible. Fifth one, and one of the most important tool, is he should understand how automation tool works. Automation tools in the sense he has to learn few of the DevOps tools, that are like Jenkins, Kubernetes, Docker. So these tools will be used by an organization for hosting or for CI/CD processes, for a complete software lifecycle. So they'll be using this. So this lifecycle will be implemented on AWS. So this person, as in SysOps admin, he has to understand how that works so that he can help and implement and also make the process more automatic, and also the repeated processes are made better so that very less time is taken for our software to be uploaded to the AWS environment. So guys, this is done. So now let us go ahead and look at monitoring services and other tools further. So first, what is monitoring? To observe and follow a process over a period of time to get data out of it, which could be of help to the business or rectifying an error. So what this means is, if you have a particular process running for you, you will have to follow and observe that process and get data out of it. That is, if you're watching a football game or a cricket game, and so what do? You record the scores, you record the runs. If it is a cricket game, the number of balls has been played, and you see what is the economy of the player, or if it is football, how many goals a player has scored. So you check all of these. So these are the data which you get out of something. So the same thing goes with monitoring. So you get some data out of it which you will use to help the business. So you can use this data in sports, you can use this data to make the team better. So you can give guidance and help the team to get better using all of this data. So the same goes with monitoring in a software. So you can give all this monitoring metric data so that they can make the software better and build it better. And then also, what is IT monitoring? So basically, monitoring is so generic. Monitoring can be done on anything in this world. So monitoring is a generic term. So IT monitoring is the term which we use for monitoring a complete organization which runs on a complete infrastructure and IT infrastructure. So basically what we are going to see is, what is IT monitoring? That is information technology monitoring. Yes. So IT monitoring is the process of gathering metrics or telemetry of the organization's applications to ensure everything works well and also to support them. As I told you previously, for a sport team, let us consider a football team, they see which player scores a lot, which player passes a lot, which player assists a lot. So they take all this data and then they use it to help the team play better. So the same goes with IT monitoring. So if you have 3-4 applications and you have so many features within that applications, let us consider we have one application which has 4 different features. So what do? You monitor all of those features individually and get metric or telemetry data from those services or from those features. So when you do that, what is the advantage of getting data from each feature? We can understand which is the most used feature, which feature has the most time used on. So the amount of time people are spending on our application, the amount of time people are spending on each feature. So we can understand which is the most used feature and we can make that feature better. And also we can find out why people are not using the other features as that much as the first one. So we can do this by collecting metric data. So this is what IT monitoring is called. Moving on. Now let us see why monitoring is a need. So the first thing is better usage of IT infrastructure and hardware. If you are a huge organization who has their own on-premise setup, so basically when there is an on-premise setup, it has to be monitored and maintained by the organization itself. So when the organization itself does it, they'll need to have a proper monitoring tool to monitor it and also get all the metric data so that they can build their IT infrastructure as such as all the hardware is consumed, all the resources are finally used. So this is one of the reason. And when it comes to AWS, it is the same thing. When your infrastructure is on AWS, again you will have to monitor AWS to get the best out of it and reduce your bills. Second one is analysis and graphic visualization in near real time. So when you are getting real-time data, so you can use that data to build visualizations and graphic patterns. You can build charts so that it can be helped. So when you're going in a business meeting, instead of taking numbers, you can take a complete PowerPoint or a presentation with all these graphs and graphic visualization, which you can get from even CloudWatch or other tools which you're using for monitoring. So you can get all these tools and explain it in a better way. And also this can be easily read, right? So why do we use graphic visualization and data visualization? Because they are easy to read, they are pleasing to the eye. So if you just take numbers, tell 60% of my IT infrastructure has been used, the rest 40% is not. Instead of that, you can show why the 60% is used, what are the services used in those 60%, which resources are not properly used, which resources are not required at all. So this you can graphically visualize. So this is one of the need. Then lesser time spent on controlling the resources. So when you monitor anything, so you'll be getting constant data. So when you get data in real time, you will understand, when you check the data, you can get to know where the mistake is, or when there is something wrong with a particular resource, you can correct it in real time. So whenever you get it, you can be able to make those changes. But if you're monitoring a tool, it's not in real time. So basically what happens is, if you're not doing proper monitoring, you might get an error, but that error might have already occurred like 2-3 days back, and still it's going on. So now you get that data, and with that data, even if you correct it right now, you lost business for 2 days. So this is one of the reason. And then prevents errors. When errors occur, detects faster. So prevents error in the sense, you can keep your monitoring tool so that you can set up maintenance windows. You can set up maintenance windows in the sense like every 5 minutes or every 10 minutes or every hour, every day. That is your wish. You can set that. And also you can code as such as that they prevent the most common errors. So you will know what are the errors which are keep on occurring constantly. So you can code as such, these errors, when they occur, they are automatically prevented. And also when there are errors found, you will be able to see them in near real time. So that will help you to detect it faster and correct. So these are the 4 most important points which you have to know why we need monitoring. So to know why we need monitoring, these are the 4 most important points. Moving on. So questions on monitoring data. Even this comes under why do we need monitoring? Because these questions have to be answered while you are creating a monitoring service, or while you're using a monitoring service. So for what metric is the data collected? So for what metric is the data being collected, in the sense, if you are running a particular EC2 instance or your own on-premise setup, that particular instance or that particular server will have a lot of metric data going on. There's CPU utilization, the amount of bytes going out of the system, coming through the system, the throughput. So there are a lot of metrics. You will have to choose a particular metric or 2 or 3 metrics for which the data has to be collected, which will be useful for you. And then how valid and accurate are the data? The data has to be nearly accurate, or they at least should be valid so that it can be used for the business, the betterment of the business. And also if the data is available or accessible immediately. So the data might get stored somewhere else and it might be hard to get them back. They should be stored in a place where it is easily accessible and available, like an S3 bucket, so that you can get it back easily. And also to acquire data even in AWS, you have some retrieval fees. So you will have to also check that which is the most efficient way and the cheapest way to retrieve data, because while monitoring and keep on doing the changes continuously, you will have to know how to acquire data from a particular source cheaply. So moving on. So we've learned what is monitoring, what is IT monitoring, and why do we need monitoring in the first place. So these 3 questions got their answers. Now let us see what are the monitoring services which AWS provides, and after seeing what are those services, after seeing that, we'll be looking at best practices which AWS themselves recommend. So AWS monitoring services. So in this session, we'll be looking at these 3 services. These 3 are the most used. Basically, Amazon CloudWatch is the most used monitoring tool in AWS. Then comes CloudTrail, and Trusted Advisor is one of the tool which is not used constantly, but it gives you a lot of suggestions and it is paid. So CloudWatch and AWS CloudTrail can be accessed for free. A lot of their services and features can be accessed for free, but in Trusted Advisor, a lot of their services are paid. So now let me explain what are these services, then let's move on. So first, Amazon CloudWatch. Amazon CloudWatch is a monitoring and observability service. So what it means is, CloudWatch can be used to monitor any AWS service. If you consider EC2, for example, you can check the CPU utilization of that particular EC2 instance. You can monitor that and also observe in real time what is going on in that service. So AWS CloudTrail is a service service that enables governance, compliance, and operational auditing. So Cloud Trail basically gives you logs of particular services. You can create a trail for any service which you want to create for, and after that, after creating a trail, what you can do is you can use that trail logs and you can push them to AWS CloudWatch, so that in CloudWatch you can create alarms using them. So when there is an unnecessary log, or when you don't need a log or you need a log, you can just mention it in CloudWatch and you can create an alarm using that. After that, AWS Trusted Advisor. So Trusted Advisor is basically a tool which will guide you how to provision or how to keep your services, and also how to reduce your billing amount. So basically it checks all the services available and it has its own limits, service limits. So when you exceed that or when you are equal to that, it shows you a red flag. If you're slightly above the expectation, it shows you an yellow flag. And if you're correctly using all the services, it shows you the green flag. So these are the services. We'll be looking at these services in detail. Right now I just wanted to show what are the services which we are going to learn and the most used services in AWS. So now let us go to the AWS Management Console and do this. So guys, this was the dashboard. So right now we'll have to go to alarms and click on create alarm. So now we'll have to select a metric. But how do you get a metric? So for that we need an EC2 instance. So first let me create an EC2 instance quickly, and I have a code in that, a CPU util code. So I already have an AMI to create that. So I'm going to launch an instance, configure it, and just add storage, and I'm done with this. That's it. So launch. I have a key pair, but I do not know whether I have over here. So I'll create a new key pair, not required. So I'll just go with this, launch instances. Yes. So my instance is launched right now. So what I'm going to do, I'm going to run that code within this instance. So when I run that code after creating the alarm, so that it will go to alarm state when the CPU util goes beyond 60%. So while this is creating, let me show what exactly we are going to do in alarms. So we are going to launch an instance, add a script to increase CPU util. I already have the script. I'll show how the script looks. So I'll show that, and after that what we are going to do, we are going to create an alarm which will basically send an email to us, whichever SNS endpoint we have mentioned. It will send an email to that telling the CPU util has gone beyond the threshold value with an extremely detailed information. So that information I'll show when showing my count. So right now just remember this. So okay, so right now let us get back with this. It's running right now. So let me open my instance here. So I'll open Putty, and then I'm choosing this and then clicking here, authorization. I'll have to browse. So my key pair is over here, so I'm opening it and open. So yeah, so now if I do an ls, you can see there is a Python code over here. What I'm going to do, I'm going to open this and first show you what it is exactly. It's a simple Python script. So basically it creates a loop, so it just keeps on running. It increases the CPU util code. So this multiprocessing, and you're importing pool and CPU count. Basically this code will increase the CPU util. That's how much we have to know. And yes, so just closing this file. So guys, right now let me run this code. So done. So my code is now running. So right now we'll have to start creating the alarm. So first we'll have to select a metric, click on select metric. We'll have to choose the CPU util metric of EC2 namespace. So this is the namespace, clicking on it. So these are the metrics, but right now there is no metric over here for my instance. So let me copy the instance ID. So this is the dimension. I'm going to paste it here and search it. So you can see there is no CloudWatch metric over here because I just started my instance. There is not enough metric data to create a metric for that particular instance. So what I'm going to do, I'll go back, click on create alarm once again, click on select alarm, go to EC2 namespace, go to per instance metric, and you can see still it's not available. So what I'm going to do, I'm going to wait until, so just a second, I've stopped this from running. So let me wait until these metrics are available in my CloudWatch dashboard. So once it is available, then I'll run the CPU util code, and after that I'll create an alarm. So guys, let us check once again. So right now, yeah, there are 173 metrics. That means it has been created. So let me search with my dimension, that is my instance ID. Yeah, there are metrics for my instance ID. So you can see over here, network packets in, network packets out, CPU util, network in, network out, and a lot of other metrics. So we need CPU util. So right now, if I click here and go to custom, give it as 1 minute, you can see the CPU util was 63.9 at some point when it got created, but right now there is no other. So let me make this place. So yeah, so what we can do is now we can just wait. Before waiting, we'll run this. So what I'm going to do, I'll run this. Yes. So right now the CPU util is going to be increasing. So within that, we'll create the alarm. So I've selected the metric. I need CPU util selected. So now starts creating the alarm. So my alarm name is going to be, so it's not over here. We'll have to mention that later. So currently it is CPU utilization. The metric I've chosen is CPU util. The instance ID is this, the same instance as this. And then the statistic is going to be average. So you can choose that over here. You can basically keep it as maximum or minimum. So you can do that. So I'm okay with average. Yeah, so period, let us keep it for 1 minute, because you see only a period greater than 60 seconds is supported for metrics in the AWS/namespaces. So if you have your own custom namespace, then you can give less than 60 seconds. But if it is an AWS namespace, then 1 minute is the least time you can provide. And then now we'll come to this conditions part. In the conditions part, I'm going to give 60%, greater than 60%. So here we'll have to give greater than 60%, and static normally detection greater or equal, lower or equal, lower. You can select anything over here. I'm going to go with greater or equal. So if it is greater than or equal to 60%, then it will send a notification. So additional configuration is not required. We are good with one data point. Next. Yes. So now we'll have to configure our notification, guys. So for that, what you will have to do is, if you already have an SNS endpoint, you can just select an existing one, or you click here, enter the topic name. It can be my new subscription or whichever topic name, like this, my new sub, and then click enter the email address which you want this particular email to be received in. So give that and click on create topic. Then it will be getting created. Now you'll have to go to the email address which you have mentioned. There will be an email, so you'll have to click on the link there. So once you click there, the subscription will be achieved. So basically it's like verification. So subscription will be verified. After that, you can use that in SNS end topic. So right now I'm going to select the existing topic which I have. I'm choosing this, and the email endpoint is this. So we can view it in the SNS console, or we can just proceed. So whenever this is an alarm state, it has to send an email to this particular SNS endpoint. So that's it, guys. And next. And also I didn't mention one thing. You can add an EC2 action also. For example, you can stop the instance or terminate the instance or even reboot the instance if it is in an alarm or OK or insufficient data state. You can mention whichever state you want to, but I don't want anything. Let my instance be running. So next, alarm name we'll have to provide right now. So my alarm name is going to be CPU util alarm. And next, if you want, you can give a description. So right now you can see it went down after I removed the CPU util code, and right now it will be increasing, I'm pretty sure, because I already ran that code and it has been like around 2 minutes after that. So right now just review your alarm and click on create. So this is how you create an alarm, guys. So you can see the condition. My alarm name is CPU util alarm. It is in the state of insufficient data, and the conditions are CPU utilization greater than or equal to 60 for 1 data points within 1 minute. So for 1 minute it calculates the average, and if the average goes above 60, then an email will be sent to my SNS endpoint. So right now let me open my SNS endpoint. So this is my SNS endpoint. So you can see there were a lot of, I had 2 other SNS notifications. So right now, let us go back to our console and let us wait until it goes to alarm state. So still now it is in insufficient data state. That means still now it has not calculated the average for 1 minute. So let us wait, and we can see the code is still running. And if you want to also check, you can go to graph and you can see the CPU util here. So till now it has went down. After that it's not showing, it is going up. So we've given 1 minute. Let us wait until then and let us check after that. Then this insufficient one will be 0, and in alarm it will be 1. So we'll have to wait until that happens, guys. So that's how we will know the alarm has been triggered. So once it goes to alarm state, if I open my SNS endpoint, I'll have a mail a detailed mail on what this alarm is about and what happened in my alarm. So why it changed the state, or which state it was previously available in and now what state it is. So it gives a detailed explanation with all the details which we require. So still now it is an insufficient state. So let us wait until it goes to alarm state. So guys, right now the alarm is not found in the insufficient section. So we'll have to go to alarm section. We can see it is in state in alarm. So this means I would have received a mail. So you can see my inbox is 1. So basically I've received a mail from AWS CloudWatch and I've received it in my SNS endpoint. So let me go over there. So first let us check here. So you can see the CPU util went up to 99.6 from this period to this period. So yes, within this it went up till this. So right now let us go to my SNS endpoint and check it. So you guys can see alarm, CPU util alarm, and you're receiving this email because your Amazon CloudWatch alarm, CPU util alarm in the US East region has entered the alarm state because the threshold 1 out of 1 last day endpoints is 99.63770491. It gives the most accurate value of your CPU utilization and gives the date and the time, as I told you, date time stamps, and it gives that, and then it also showing it went from OK to alarm transition. So basically you can see the alarm details. The state change was actually from insufficient data to alarm because it was collecting data. It was within OK, but it never turned to OK because it was already in the alarm state when the alarm was calculating the average. So the first state change was alarm. So you can see alarm details, name, CPU alarm, insufficient data alarm, threshold crossed 1 out of 1 lost data points, and you can see all the details over here. It timestamps Sunday 20 October 2019 and even the time, and it is in UTC guys, not in local time. And then here you can see monitored metric. It was the AWS EC2 namespace. It was CPU utilization metric. The dimension where my instance ID period was for 60 seconds. The statistic was average. The unit is not specified, and the data is treated as missing. But right now you can see states change actions. There was only one action which happened. That is when an alarm, it has to send a email to this SNS topic which it sent. So guys, we have succeeded in creating an alarm and also to make it send an email whenever it crosses the threshold value. So let us go back and see. So right now it went back to insufficient data state. Let us stop this. So I don't need this right now. I'll just close this. Yeah, so right now we've done it. So let us go back to the slides and start with the next portion, guys. What is cloud security? Cloud security is a set of procedures and technologies that work together to protect cloud-based systems and data stored in the cloud. We, the customers, we store our data and host our applications on AWS, and we also pay AWS to do that. So AWS has to provide us security in return. So AWS or any other cloud service, first priority is to provide security because they want to restrict unauthorized access and also to keep the data secure so that they do not leak. Let us see why cloud security is a priority in AWS. So at AWS, cloud security is the highest priority, and by AWS, you will benefit from a data center and a network architecture which is built to meet the requirements of the most security sensitive organizations. As we know, AWS also hosts government applications which have highly sensitive and mission critical data in them. So they also provide the same data centers with the same network architectures which are secure enough to host government applications and data for other organizations and also customers. So you can understand how much AWS values cloud security. Now let us see, why is cloud security a priority? First thing, protection against DDoS attacks, that is distributed denial of service attacks. DDoS attacks might reduce your sales or your business because whenever there is an attack, nobody can use your service. For example, if you're using Facebook to sell your products in the marketplace, if Facebook has a DDoS attack and Facebook has stopped for the period of time until Facebook comes back again, your business is lost, so that you'll be losing money for the time. So that is DDoS attacks, and AWS provides you services and security so that you can prevent DDoS attacks. And then data security to protect sensitive information. As I already told you, AWS provides data centers with extremely securely built network architecture which can protect government applications and also highly sensitive data. They provide that to organizations and also customers. So this makes it highly secure, and we can trust AWS to store our sensitive information in that. And then flexibility when scaling up and down. So basically, we use cloud so that we can scale our applications infrastructure up and down as per the requirements of our customers. So flexibility is also one of the reasons why cloud security is a priority, because whenever the scale goes up and high, the security measures taken should also increase with it. And whenever it comes down, the security services which are involved will have lesser time, and also they can easily detect all of the vulnerabilities and security issues going on. But when the application scale increases, the security's surveillance should also increase. There should be a lot of time put into security to look for vulnerabilities and loopholes so that we can fix them before a hacker tries to get in. And then comes high availability and support. So if you prevent any unauthorized access, DDoS attacks, and any other type of hacking attacks, you provide high availability. Because whenever your site doesn't go down, it is available for customers and also anyone who are using that website. So to make it highly available, you should allow cloud security. You should allow services to protect your web application or any application you have hosted on AWS. So to protect high availability, to provide high availability and also support to your applications, you will have to enable cloud security, and you will have to use proper services so that your application is highly available in all of the data centers across the world. Now let us look into AWS security services, which we'll be learning in this session, and also we'll learn some best security practices which we can follow if we are using an AWS account. We can follow so that we don't leak our sensitive information, and also we don't give our access to our root credentials. Now let us look into the security services which we'll be learning in this session. So these are the security services, guys. So first is Inspector, then KMS, Single Sign-On, Certificate Manager, and WAF. So Inspector is an automated security assessment service that helps improve the security and compliance of applications deployed on AWS. We'll look into these services in detail later. Now let me just give you an introduction about them. First is Inspector. Basically it is used to automate security assessment process. And then KMS, it provides you a service where you can create and also manage encryption keys. You can create keys for encrypting your data and also create keys so that it can help you with other AWS services. And then Single Sign-On, this is a service which helps you to keep just one credential where you can just log into that and access all of the applications which are registered to that particular email address. And then Certificate Manager, it provides you, and you can also create SSL or TLS certificates for which you can connect them with AWS services and also take these certificates and implement it in your own on-premise setup. And then WAF, as I told you, it is a web application firewall. This helps you protect your web apps and also other web applications from common web exploits or attacks like DDoS or SQL injection attacks. Moving on, now let us look at the best security practices that AWS recommends us to take up. The first thing is keep your AWS root account password safe and vaulted. So what are they saying over here is, they are telling us to keep our root account to ourselves and we should not let anyone know our root account password, because root accounts are very powerful in AWS and you can launch any services with it. So that keep your root account password safe and only provide IAM credentials to whoever asking for any credentials to you. And then use IAM permissions and IAM users to provide access to services. As I just now told you, create IAM users and give those users enough permissions to do whatever services or requirements they have. For example, you might give a developer access to an EC2 instance, then access to Elastic Beanstalk, and then access to some other services like S3, but you do not need to give him all the access, or you do not need to give him the administrator access. You just need to give permissions for the tasks which that particular person is going to perform. Third point is enabling multi-factor authentication.
So multi-factor authentication enables you to keep your account secure because every 30 seconds or 1 minute in equal periods of time, it provides you a new code or a new set of 6 digits. So you can only log into your account if you enter that 6 digits which are currently showing in your authenticator app. For example, you provide your root credentials to someone, and if they're trying to log in, it'll ask for the MFA number. So you'll only have that MFA number in your mobile or wherever you have installed the authenticator app. So there is an application called Google Authenticator. You can download it and install it. So that Google Authenticator will show that numbers, and you will have to enter those numbers so that you keep your account more safe. If somebody else is trying to do unauthorized access, they'll need your mobile application and they'll have to know that 6-digit number of that particular 30 seconds so that they can log into your account. And then encrypt important volumes and data storage with KMS. So you might have EBS volumes and S3 buckets with sensitive information stored in it. So please create encryption keys which make them secure. So you can apply these encryption keys to those EBS volumes and also S3 buckets so they are safe enough to prevent unauthorized access. So right now we are going to start off with the hands-on. We saw how to install and configure AWS CLI. Now we'll be doing it in practical. So first let us download and then install and then configure AWS CLI in our PC. So this is the website. This is the documentation provided by AWS. You can follow this document to download AWS CLI for the respective operating systems. So you can see here there is for Linux, and then for Windows, for Mac OS, and for virtual environment also. So my PC is a Windows operating system, so I have to install it on Windows. And they also provide you multiple options. The first option is to download the MSI installer, which gives you the executable file, which you can just install like a normal setup file. And then you can install it using Python and pip in Windows. And then you can also download just the setup file and install it and just copy your path to the environment variables. So instead of doing that, we can just download and install using the MSI installer, which is much simpler. You can choose the 64-bit version or 32-bit version according to your computer specifications, or you can just download the setup file. So this has both the 32-bit and the 64-bit MSI installers. So now let us just download 64-bit. So if you do not know which type of system is your, what kind of specification configuration is your system is, you can just download the setup file and install. It will automatically install the correct appropriate version in your system. So once this gets downloaded, we can open it up and start installing it. Once we install, I can take you to the command prompt and show you how to configure it. Now let it download and then it'll open, then I'll show how to install it. So the download has been completed, guys. Now this file has to open once the entire download is complete. So the download is complete and now the setup file or the MSI installer file has opened. You can see over here, welcome to the AWS command line interface setup wizard. So this is nothing, there is nothing complicated over here. It is just a normal installation setup. Like you can just click on next. If you want, you can read this license agreement and then click on next. So once you entered your admin password, the application will start install. If you do not have any admin password, it will automatically start installing. Once it gets installed, I'll take you to the command prompt, and in the command prompt I'll show you how to check whether the AWS CLI has been installed on your system or not. So right now it's going to get completed. I'll open the command prompt and keep it ready. So let us wait until this completes. Once this completes, we'll be able to check. So before that, we'll check right now AWS -- version is the command. So right now AWS is not a recognized command. Once this installs, it will be a recognized command because it will be installed in our system. So right now it's done. Let me hit finish. Let me check once again whether is it showing here. It is not. So now we just have to open a new command prompt and hit AWS -- version. So now it is taking some time. That shows AWS CLI has installed in our system and it is showing the versions. It is showing the AWS CLI versions, the Python version installed in our system, the Windows version, that is Windows 10, and also the Botocore C SDK.
So about this protocol SDK we'll be looking at later, but right now just think about AWS CLI. Python has been already installed, so you just ignore that part. Let us just consider we have installed AWS CLI right now. So now let us configure AWS CLI. To configure AWS CLI, the command is AWS configure. So this is the command to configure AWS CLI and hit enter. So the first thing it asks for is the AWS access key ID. I've already entered one access key ID when I last tried to configure it in this PC, but right now I have deleted that key. So right now it requires a new key ID and a new secret access key. And also guys, I'll be showing this access key and secret access key, and I'll be making them inactive and deleting it. So if you are having an access key or a secret access key, don't share it with anyone who can misuse it. So right now I'll just go to my console. To get your access keys, you'll have to go to your security credentials. Click on it. You'll be taken to the IAM console. In IAM console, you'll be seeing all the security options over here once this page loads. After that, I'll take you to the correct place to get it. So you can see it has been loaded. So it's not password. You'll have to go to access keys. So now you can see I've created 5 different access keys and I've deleted all of them. So right now I'll have to create a new one, and you can either download the key file or just show it over here. Downloading the key file is a safe practice. Let it get downloaded. So right now you will have to copy this, go here, paste it, enter. You'll have to go here, copy this entire code or key, copy it and paste it here. And then coming to default region name, I've already entered it as US East 1. So let me once again enter it as US East 1 because I'll be always working in North Virginia region. If you work on a different region, enter that over here. And then default output format none. If you want, you can enter JSON, or you don't need to enter anything. So let it be JSON, no problem. This is the first hands-on. We have completed installing and configuring AWS CLI. Now let us move on with this session. Now let us go ahead and use some commands to launch or deploy an EC2 instance directly from the AWS CLI. So let me first show you the commands which are required to do that. So first, this is AWS EC2 create key pair, because when we do it in the AWS management console, after the complete process, it asks for a key pair. Either you will have to create a new one or you have to use a old one. So right now let us create a new key pair which is named as newkey.pem, and you can see over here create key pair. So key name is new key and query is key material. So it will be written as key material inside our key. So it is just a query. And then coming to security group, we'll have to create a security group. And for that security group, we are allowing inbound rules. That is, we are allowing SSH port 22 and it can be accessed by any IP address. That means we can open this using SSH. And then finally we are going to launch an EC2 instance. So we are giving the image ID. The image ID can be taken from the AWS CLI, or you can just go to the AWS documentation and get it, or you can describe all the instances in the AWS CLI and get it, or you can directly go to the management console and go to AMIs and get the AMI ID of the particular instance which you have to launch from the AWS CLI. So the count is 1. I just have to launch one EC2 instance. If you want 2 or more, you can include it over here. Instance type is t2.micro because t2.micro is the free instance. That is the free tier limit instance. And then the key name is new key because that is the key we created, and security groups is taken as new group which we just created. So now let me open the command prompt. So we have already configured it. So right now let us start off with it. So first let me create a key pair. So enter. So this will create a key pair. So okay, there are some mistakes here. So let me just remove this part and hit enter. So a new key already exists. This means I have already created a key called new key. So let me name it as new key 1 and let me try to install. So an error occurred. The key pair new key already exists. So just a second, I'll have to change the name over here. So that is here new key 1. So once I do this, yes, the key pair got created right now without any error. So let this be tried. The first time there was some error in the code. Second time there was the error because it already had a key pair called new key. So now I have created a key pair called new key 1. So I'll have to change that over here. So new key 1.
and others are the same. So now let us create a security group. Let me copy this and paste it over here. And EC2 create security group. Group name is new security group and description is security group for my new instance. Enter. And it also should be created. Yes, a group is created and the group ID is SG and they've given a separate number. We can go to the AWS management console and check this, and this will be available right now. And then coming to providing inbound rules, let me copy this and again paste it, and I think we'll have to change the name over here, that is new security group. Now let me copy this and paste it and hit enter. So right now the inbound rule should allow port number 22 from any IP address. So inbound rules are done. So we have done the three main processes. One is creating the key pair, creating the security group, and allowing inbound access. So the fourth and final step is to create an instance from the CLI. So this is the command, that is AWS EC2 run instances, image ID, count is 1, instance type is t2.micro, key name is new key 1, security group is new group, but we have changed the name to new security group. So let me use this, copy this and paste it over here and hit enter. So right now the process for deploying an EC2 instance would have started. So yes, you can see a complete JSON format output has come over here, groups, instances, image ID, the AMI ID, instance type is t2.micro, key name is taken as new key 1, and there are other options over here. So right now guys, so you can see private IP address, and you can see a private IP address over here also, and it has a root device name as /dev/sda1. the root device type is EBS volumes, security group is new security group, and the group ID. Code is pending, so right now it has to be creating. Now let us go to our AWS EC2 dashboard and check whether an EC2 instance is getting created or not. So if it is not getting created, that means we would have done some mistakes, but it should be creating right now. Let me open. There are 3 running instances. So this is the current instance which I created. So these were the previous instances which I already had. So currently this is the instance which is running and initializing. This is the instance we created. But how to cross check this? Okay, now let us check this instance ID. Let us see 0C9. Let us go back to the CLI, go to the instance ID and check this. Yes, 0C9. It's the same instance guys. This is the instance we created directly from the AWS CLI.
Today in this session, we are going to discuss the top AWS questions that can be asked to you in your next AWS interview. So without wasting any time, let's go ahead and start with the agenda to see what all we'll be covering in today's session. So we'll start this session by first discussing the domains from which we have collated these questions. These domains are directly mapped to the AWS exam blueprint, which was recently updated in June 2018. So there is a high possibility that your next AWS interview might contain questions from these domains. So I want you to pay the utmost attention that you can so that you can gain as much knowledge as you can from this session. Alright, so let's take a top-down approach. Let's start from the simplest questions that are some generic questions on AWS that can be asked to you in an interview. Alright. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You are basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer, which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. Alright, so the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time. Right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. Alright. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are auto-scaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. Alright. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elastic Cache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elastic Cache. So Elastic Cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elastic Cache, that data can be captured or can be cached inside Elastic Cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elastic Cache, and that is the exact use of Elastic Cache, right? So you use Elastic Cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elastic Cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the request to page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. Alright, so I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Request to page option to access via AWS billing, again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number 1. Second, whenever you want to give permissions to services or permissions of services of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you are using EMR and S3 together, that basically means that you create a policy that gives you, the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So, okay. So this is Simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time, you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are 2 types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite. That is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? All right, so to rephrase this question, basically you have an application which has 2 kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the tasks should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? you can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that a database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS global infrastructure does AWS Cloudfront use to ensure low latency delivery? Now, AWS Cloudfront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places.